Let's see if this has started streaming. Yep, it looks like. Hey folks, welcome to my stream in which I will be going through AI research and engineering workflows and will be giving my views on Google I/O and other topics that have come out recently, and we will also be going through some of the security breaches and other manipulations and hacks that I have been facing on my OS and other services which are a part of the cloud. And we will top it off with the EAFC 26, where I will try to do SBCs and see if my workstation allows for online play because it requires quite a bit of resources which I do not have at the moment. Let's begin with the emails. First is the state space, that's Mamba. Stabilized data dependency with heavy tail action. This is a PR in the Mamba 3 series, and it became highly unstable at higher learning rates when using WSD. And in the 2B hybrid models at 300 billion tokens scale. So they replaced soft plus with heavy tail activation for data dependent A. This is a PR issue for the resettle generative scoring entry point. This is a VLLM supporting Mamba hybrid models, alien aligning prefix cache. Triton MLA supporting FP8 KB cache. This is Moonshine streaming. Transformers V5.9. Break support for PyTorch with use distributed 0. Module not found. So this is specifically continuous batching, distributed PY, and this has been closed and resolved. Okay, so it broke the support. This is reduced TP communications for large vocab graph models and D-flash part speculative decoding, front end resettle generative scoring entry point, AMD MI355X Kimi K5 2.5 2.6, XPU block scale W8 FP8 path, model runner V2 spec decode CUDA graph rejection sampling. This is Triton MLA for FP8 KV cache needed for SM. On streaming, this is breaking support. Same one. When 3.5 multimodal speculative decoding draft models. Adding log available router, add dynamic SD, add linear. check enough KV, cache memory, add Colbert query, GLM 5.5 PP model loading, building AutoWare with Pixie RoboStack, add support for per GPU worker, RDMA and NIC selection, convert to FP32 first while doing image resize, don't transfer spec decoded look ahead blocks, reject out vocabulary before they reach the GPU block probe path. CUDA error, MOE layer, supporting draft models, TP of any speculative decoding. LoRa MOE, GLM, multimodal draft model, LoRa MOE, eager mode changes, KV cache split causes large accuracy regression, Cutlass W4A8 linear kernel fails, Mistral large, hangs on initialization, 8x black B300 Blackwell, W4AFP8, MOE Triton kernel. This is from Liger. This is Sonic MOE kernel, which has been implemented from this paper, Sonic MOE, accelerating MOE with IO and tile-aware optimizations. Oh, this was a pretty like famous paper, and that included the Hopper and the Blackwell GPUs. Uh, so the latest speed up that you looked at is 25% to 15%. So that was fun. Let me log into my Mendeley and save this paper again. This was from my namespace, Mayank. Uh, uh, he's Mayank Mishra. When Teo Go treat Teo, many other famous first personalities. So like these are the top of the line people who are doing research ML, specifically this state space model and MOE research, and are dabbling in many different avenues. So I had this is the paper. These are the results, as you can see. This was accepted to ICLR 2026. This is the memory efficient memory algorithm that they used. Forward pass, upward projection with this, grouped GEM, down projection, export aggregation, the backward pass with export aggregation of project at uh, gradient and up projection weight gradient. These are 8 launched kernels grouped by yellow boxes. 3 and 5 kernels are launched during forward and backward computation respectively. These are the arrows that are indicate arrows to a yellow circle, indicate a variable loaded from HPM to SRRAM, and outgoing arrow represents variables stored to HPM. We color boxes of all variables on HPM with purple boxes indicating the output forward and backward, while blue boxes indicating immediate variables and weights. So this is the overview of Sonic MOE kernel, and the W1, W2 are the weights. The pi is the, I think so, the standard. Uh, Let me try to find if they have written somewhere. Pi is from 0 to 1, is binary valued mask matrix, where pi TE represents whether token T is routed to expert E. The yellow arrow indicates that the epilogue once finishes the epilogue of work tile and signal the MMA warp. That epilogue warps owned tensor memory on the chip, Blackwell GPUs. So this is why I was wanting the NVIDIA's Spark, DGX Spark, because I needed to experiment with these kernels, and as I was in a research writing an architecture for a small uh, SSM uh, hybrid transformers, like SSM transformers hybrid model. So yeah, that is still kind of work in progress. The results weren't that great, so we decided not to pursue writing a research paper on that. But yeah, uh, it was quite fun doing that. But this we haven't used Sonic. uh, the overlapping with asynchronous I/O kind of research, like the ping pong uh, type of on the Blackwells. So it will be fun to experiment and like whatever the claims are. So these are some of the comparisons with the existing MOE kernel design. Scatter MOE, MOMOE, Mega Blocks, Megatron LLM, Deep Games, and so this has been introduced in the Liger kernels. I think so. They were trying to reproduce it using. Let's see. Hmm, this is XPR 05 expert only speed. I don't know what was that about. Fix wrong partial rotatory factor calculation for bailing MOE. W8A8 FP8 linear kernels. Marconi style admission policy for hybrid cache. AWQ dequantize on Intel XPU and refactor auto AWQ config. Yeah, so this is specifically with respect to quantization. in VPLMs. This is for Intel XPUs. Support apply Liger kernel to DeepSeek v4 and unit test. Flash MLA, Ampere, architecture, bringing up issues. Align MOE interface for EP-TP compatibility. And they're wanting trainers. I don't know what will I train them. They're saying me to, telling me to give me foundations and prompt engineering and this vector databases and RAG and React and Next.js. I don't know what's the use of, like, why will I spend my time giving an online training or something like that? GTC Taipei.
Fastest storage servers, the fastest storage system the world has ever made.
Right now.
And the reason why this is so vital
Oh, let's go through that then.
is in seconds. They live in a world that's in nanoseconds. When it critical path of the most expensive part of the data center.
This live stream has just been overtaken by NVIDIA's keynote, Taipei.
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, turning data into knowledge, reason, action. They reveal patterns in complexity you could never see. Mirror our cities to keep us safe. And lift us high above them. Tokens help robots learn from us. Work alongside us. They go where we cannot. Lending us helping hands. And closing the gap between hope and healing so that we breathe easier. And the smallest hearts beat stronger. Tokens are helping us break new ground on a scale never attempted. reach
Star Cloud 1, separation confirmed.
to infinity and beyond. Together, we take the next great leap into a bright new future built for all mankind. And here, in Taipei, is where it all begins.
女士们、先生们，欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
大家好 Welcome to GTC Taiwan. So great to see all of you. Very good to be home. I brought my parents home. Where are my parents? Everybody give a round of applause to my mom and dad. And a round of applause for our pre-game show superstars, ladies and gentlemen. Look how adorable they are. The superstars of Taiwan. There are so many of you here today. We are broadcasting this right now to 70 other watch parties across Taiwan. 70 different conferences are going at the same time. Everybody is watching this keynote. We have so much to tell you, and I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem above the computing systems that NVIDIA builds. But NVIDIA's ecosystem spans all the way upstream to all of our supply chain, here in Taiwan, where it all begins, and downstream all the way to data centers and eventually to end users. Today, we're going to talk about almost all of the ecosystem. There are so many people to thank. I love my ecosystem here. I mean, there's so many companies here, and some of my favorite ecosystem partners. So many. Taiwan's rich ecosystem. The richest ecosystem, the world's best supply chain ecosystem. Unbelievable. Well, thank you all for being here. And this year, our businesses together are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%. Unbelievable. Well, we have a lot to talk about. Let's get going. 2 years ago, when I was here, I started to talk to you about how AI has moved from generative AI and the other waves of AIs that are coming. The next wave of AI was agentic AI. And today, we can say that agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of agentic AI is software coding, one of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth, but say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they push it back up. Okay? And so if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits. In the first few months of 2026, it has nearly tripled. Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth for the rest of the industries. Say $100 trillion of the world's industries is generated by $3 billion worth of salary. That $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired, and the reason for that is very simple. If you can hire a software engineer and you could generate $9 trillion worth of productive work, why wouldn't you want to hire more software engineers? If that line was flat, then obviously people will hire fewer software engineers. But because the output is so incredible, people want to hire more software engineers. This is going to show up in our economy somehow soon. And so the first thing is useful AI has arrived. Now, what does that mean from the industry's perspective? From the industry's perspective, that means that tokens are now in extraordinary demand. Because if you could do this, you're going to want to produce more of it. And because tokens are now profitable units, Tokens are now profitable units of revenues. Because it is now profitable, the AI companies want to build a lot more tokens, generate a lot more tokens, build more AI factories, which is the reason why compute demand here in Taiwan has skyrocketed. It is precisely the reason why all of you are so busy and your businesses are doing so well. In fact, that looks like some of your stock price. The compute pattern has changed. Everything has changed. So the first idea is that useful AI has arrived. AI is now a profit generator. AI is now a GDP generator. And behind it is a whole new kind of computing pattern. Not just a large language model, but an agent. Today, almost everything we're going to talk about is going to be based on this. So let me take a quick moment and show you what I'm talking about. Inside, this is an agent. It's an agent application. In the old days, this would be application, this would be code, and this would be operating system. Application, code, running inside an application, inside an operating system. Today, it is agent, which consists of a large language model, or many, sitting inside a harness, and that harness helps it, orchestrates it to do productive work. This is the input. When that input comes, it has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example. This is orchestrated, this harness orchestrates this routing of information every single time it touches either processing the context, understanding what is happening, reasoning about what to do, coming up with a plan that it acts on. That orchestration path is orchestrated by some software. And so this is fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we do, we have long-term memory. And so the memory management system is incredibly important. This entire system is called an agent. The large language model is used to do the thinking, and the harness connects everything together, just like an operating system, okay? And so this is the new computing model, and this is what an agent. It can do incredible things. This is the big breakthrough. The simultaneous convergence of large language models that are now able to do a really good job thinking, reasoning, planning, using tools, and the fact that we have now these harnesses that manages memory, the orchestration, uses tools, we can now do amazing things. Let me give you some example. This is a prompt. This is the prompt. This is the code that is generated, and this comes out. This is the input. This is the input, and that's the output. What do you guys think? It's pretty amazing, right? We use Claude Code here, but Codex does an incredible job as well. Here's another example. This is the input. Create a GIF, NVIDIA green dots on black scatter, form Taiwan 101 building, morph to GTC Taipei 2026, morph to NVIDIA I logo, then scatter and repeat, right? So you saw that. That was the prompt. Here's the next one. I lost my remote control battery clip. It looks like this. Create a CAD file. It uses a tool, create a CAD file, ready for 3D printing to create a new one. Make sense? This is now the new computing pattern. Whereas we used to launch an application, click and type, we now replace that with explain to the AI what we want, our intent, and the AI generates the code or uses tools and produce the necessary output. This is how computers are going to work in the future. This is agentic AI. For 2 years, we've been building towards this, and now it has arrived. Now, one of the big breakthroughs, of course, is tool use. A lot of people have said, Jensen, AI is coming, agentic AI is coming, therefore all of the software companies are going to go out of business. I said, it's exactly the opposite. Because there are going to be so many agents, the world is no longer limited by the number of people. Therefore, those agents are going to use more tools than ever. This is actually an incredible time to be a software company. But the software has to be presented to the agent in a way that the agent can use it. This is a big breakthrough. And in fact, what we have done, as you know, what NVIDIA's treasure is all of our CUDA libraries. I call them CUDA-X libraries. This is NVIDIA's treasure. Today, we're able to now present these CUDA-X libraries to agents who can use it much more effectively than even humans. And so this is a wonderful time for CUDA-X libraries. Let's take a look. 20 years ago, we built CUDA, a single architecture for accelerated computing. We reinvented computing. 1,000 CUDA-X libraries help developers make breakthroughs in every field of science and engineering. CUDA-X libraries are tools for agents. cuLitho for computational lithography. cuOpt for decision optimization. cuDSS for direct sparse solvers. AIQ for deep research across structured and unstructured documents. Ariel for AI RAN. Warp for differentiable physics. Parabricks for genomics. At their foundation are algorithms, and they are beautiful. A round of applause for math. Math is beautiful. The computing pattern of software is going to change. In fact, let's come back to this. This is the agent. It is the ultimate disaggregated and distributed computing model. So many different computers are going to be activated in order to process this agent. The agent consists of model, harness, tools and skills, and a runtime. All of that is running at different places in a data center. You can think of the model as the brain, the harness as the body, the tools that it uses, working in a runtime, think of it as a workshop. So this is a person, a worker, working with tools in a workshop. Of course, this is being done at extraordinarily large scales, and each one of those steps are running in a different part of the computer. And you can see the large language model is thinking, context processing, observing, understanding the environment, reasoning, coming up with a plan, and acting on the plan. Every single time that happens, an entire rack of Grace Blackwell NVLink 72 is activated. It's thinking with a large language model. Whenever it uses a tool, a CPU is used. That tool could be a C compiler. It could be Python. It could be JavaScript. Or it could be accelerated computing. Today's agents are relatively simple users of tools. Tomorrow, they're going to be very sophisticated users of tools, which is the reason why the CUDA-X libraries that I showed you are going to be incredibly popular with agents. They solve some of the most important problems the world knows. And all of our CUDA-X libraries are now going to come with skills that the AI could learn how to use. So the CUDA-X library, some skills, basically a manual, the AI reads it and go, aha, that's how you use it. The ability to use these libraries by agents are going to be incredible. And so the tools run on CPUs and GPUs and large language models. The security harness runs on CPUs and a security processor called a DPU, NVIDIA's Bluefield. The orchestration of all this runs on a CPU. This is the entire harness, and the CPU is orchestrating all of the work. One of the hardest parts is memory. You could just imagine. The working memory is called KV caching. What to remember, compaction, not just compression, but how to retrieve. Do you retrieve structured data? Do you retrieve unstructured data? What is the ontology, the relationship of all of these different data to itself? That entire processing is incredibly complicated. The memory system of AIs is going to cause the storage system to be completely revolutionized. As you can see, every aspect of this computing model, this computing pattern, this new application called an agent, is fundamentally different than the way that applications used to run. A whole bunch of software sitting inside a binary, sitting inside an operating system. This is the reason. This disaggregated, this distributed, this heterogeneous computing problem is precisely the reason we built our next generation, Vera Rubin. Vera Rubin is not one chip. Vera Rubin is not a GPU only. It starts with a GPU, but Vera Rubin is incredible. This entire thing is Vera Rubin, from end to end. It has GPUs, Vera Rubin NVLink 72. It is orchestrated by Vera CPUs I'm going to tell you more about. The storage systems, revolutionary. Vera, along with CX9, our software stack called Doka, the security processor that's inside so that everything is encrypted at rest, in motion, as well as in use. Everything across this is secure because the AI model is so precious. This is the reason why this entire system obeys confidential computing. Each one of these systems would be a complete revolution in itself. Vera Rubin is the most ambitious endeavor in the history of our company. The whole company worked on Vera Rubin across all 40,000 engineers, not to mention all of you. All of you participated in the creation of this entire system. Vera Rubin is really a miracle, and it's not just one chip, it is so many. Well, it's even beyond that. A long time ago, NVIDIA used to be a GPU company, but over the years, we've evolved to become a systems company. You're looking here now for the most complex system, the most complex and ground-up system ever designed. But ultimately, our customers, our partners, don't want to buy computers. They want to build AI factories, which is the reason why NVIDIA has really started to transform ourselves yet again. You can see so much of our technology is now at the entire infrastructure scale. Our partners are at infrastructure scale. Power generators, cooling systems, the grid providers. So many industrial companies are now part of our ecosystem because ultimately, we're trying to build an entire stack, just like GPUs, just like when we were building Grace Blackwell NVLink 72, just like now, we are building a full stack system so that our customers could build amazing AI infrastructure. Let's take a look.
The world is racing to build AI factories, the largest infrastructure build-out in human history. AI factories are incredibly complex. Every layer, chip, rack, network, power, cooling, grid, must be designed together from end to end because compute is revenues. NVIDIA DSX is the blueprint, a reference design for building and operating AI factories at maximum efficiency and profitability. It starts with DSX Sim. With the DSX Sim Omniverse blueprint, partners design and validate an NVIDIA Vera Rubin AI factory before a single rack lands. They plan the layout, simulate the power and cooling, design the network, validate every integration, test every change in the digital twin. The factory powers on. DSX OS takes over and provisions, operates, monitors, and remediates the infrastructure, turning the installed systems into trusted, multi-tenant, resilient, AI-ready capacity. Today's AI factories over-provision power by up to 40%. DSX Max LPS lets operators safely deploy more GPUs inside the same power budget, adding billions in annual revenue. Breakthrough hot liquid cooling at 45 degrees Celsius uses less water and energy. More power going to revenue-generating compute. Incredible. Dynamic power allocation steers power from rack to rack, recovering stranded watts, sending them where work is happening. In-rack power smoothing flattens peak current spikes and power surges. Throughout the factory, teams of AI agents work with DSX Max LPS, continuously coordinating to balance cooling and power to meet workload demand. DSX AI factories are flexible energy assets that operate cooperatively with the grid. DSX Flex reads real-time grid signals and dynamically adjusts factory power when the grid needs relief. 100 gigawatts of AI factories will come online before the end of the decade. NVIDIA DSX AI factories run at highest efficiency, produce the lowest cost tokens, and make the grid stronger.
I've shown you ecosystem slides of the past where NVIDIA's computing layers and software and computing stacks are integrated into other people's platforms, third-party platforms and libraries that serves end markets. That was a computing ecosystem. This is an AI factory ecosystem. This is way downstream of all of you. Upstream of me is all of you, and downstream of us is this ecosystem. Because NVIDIA ultimately is not just building a GPU, not just building a system, we're helping customers build these AI factories, these AI infrastructure that is so immensely complex. Each one of these at 1 gigawatt level started at $30 billion. It is at $50, $60 billion, and soon it will be $80, $100 billion per gigawatt. $100 billion into an AI factory. It must work the first time, and it must work right away. The cost of capital is incredible. The complexity is incredible. So as you see, we used to design a chip inside a computer. And then we simulated a system inside a computer. Today, you saw just now, everything was built in Omniverse. I've been working with Omniverse with all of you for a long time. This was the dream come true. So that we can build these gigantic systems as large as the world wants to build inside a digital framework, inside a digital simulator, in a digital world, long before we build the first break ground and put our money to work. So this is our ecosystem. We call it DSX. RTX is for our GPU, DGX is for our systems, and now DSX, basically infrastructure. Because of the work that we do here, across this entire stack, including our systems and software, it's the reason why we could work with small companies and enable them to be world-class AI clouds. Every one of these I'm about to show you are small companies just recently. And now CoreWeave is worth $50, $60, $70 billion and growing incredibly fast. Recently, we worked with Nebius. And again, they're growing incredibly fast. Each one of these clouds have incredible customers. Cursor, the software coding company, Black Mountain Labs, Image Generation, World Labs, World Foundation Model, Revolut, the leading financial services AI company, and Shopify. Here's another one. This is Nscale, and their customers are British Telecom, Google. Google is using one of our AI clouds. Thinking Machines, a Frontier Labs company, super exciting. Here's Naver Cloud in Korea, Bank of Korea, Hyundai, so many incredible companies. Here's one in India, Yoda, incredible companies. Here's one based in Singapore, building in Australia, Together AI, it's AI Singapore. In Australia, incredible companies. It's AI Singapore. This is one in Indonesia. Each one of these companies are serving regional as well as global customers. AI is going to run everywhere. Every company will be powered by it. Every region will build it. Indosat here in Indonesia. Here in Taiwan, GMI. Here in Taiwan, GMI. It's okay to clap. So, incredible companies, incredible opportunity, but all of them need several things. Of course, they need the computing stack. This entire stack underneath. This is what made NVIDIA famous. All of our hardware and software and libraries, our connection into the world's ecosystem of third-party developers makes it possible for anyone to stand up an AI cloud. However, the AI cloud is so complex now. This is the software version. This is the computer science version. The money version, the asset version is what I showed you earlier. It's a giant factory. Having this ability alone is not enough, which is the reason why NVIDIA has become an AI infrastructure company. Now, doing this well and becoming incredibly good at helping customers build AI factories and deploying AI factories is incredibly important. And the reason for that is this. Compute is revenue now. Compute is profit. The absence of revenues and profit is loss. And so it's really important to realize that this is an example of an AI infrastructure coming online. It could be coming online quickly. It could take a while. Its throughput could be high. It could be low. Its resilience and reliability could be good or bad. And its lifetime of usefulness could be long or short. Because this represents 50, 60, going to $100 billion. This curve matters greatly, which is the reason why NVIDIA is such a great partner. Working with us, because of our fully integrated capability, we didn't just come up with a PowerPoint slide. We created the entire infrastructure. We connected everything together. We built out billions and billions of it ourselves to make sure that everything works well. As a result of that, our time to first token, our time to first inference, our time to training turned on is much faster. Second, because our throughput per watt, our tokens per watt is utterly world-class. And the reason for that is because we integrate everything, we design everything from the ground up, we simulate the entire system, and we use extreme co-design. Just like I showed you just now with the Vera Rubin rack, everything was designed in order to deliver on this incredible throughput. If your data center, if your factory has 1 gigawatt, it will not have more. 1 gigawatt means 1 gigawatt. That's all the power generation you could do. If you have 1 gigawatt of power, then throughput per watt is revenues, because every token is profitable. Every token is revenues. This is the future. Compute is revenues. Performance per watt is your revenues. Choosing the wrong architecture just because the chips are cheaper doesn't translate, doesn't make sense. You need to make sure that your revenues per watt, the more you buy, the more you make. And so tokens per watt. And then lastly, third is reliability. If you ever get a chance to see these data centers, there are so many moving parts, millions of cables. The ability for all of those computers to work harmoniously, reliably, is extremely low. It is just extremely difficult. We have now been operating very large scale for a very long time. That experience matters. That difference, mean time between interrupts, extremely important. And then lastly, this is very hard. The lifetime of these systems, the software is changing all the time. 4 years ago, which is in the time of Hopper, AI has completely changed. 6 years ago, this is the time frame of Ampere, AI has completely changed. We started out talking about CNNs. Here we are, then we talked about transformers, and then we talked about mixture of experts. Now we're talking about agentic systems. Every single generation, every single few months, the software industry is coming up with new technology. If your architecture is not flexible, if your ecosystem is not rich, then this curve cannot be long. You cannot predict how long your system can last. I can. NVIDIA systems is all over the world. Software developers start with NVIDIA CUDA. And by definition, therefore, the life, the ecosystem, the useful asset is going to be much longer. The difference is essentially cost. You could think of it as revenues, but the other side of revenues is cost. If the life of the asset is long, the TCO is low. This is the difference. This is what it looks like when compute. The more you buy, the more you make.
That's new from Jensen. The more you buy, the more you make. That's a nice evolution from the more you buy, the more you save.
Now, all of you are experiencing this with me. Isn't that right? All of your demand, your factories are working so hard, your people are working so hard all across Taiwan because everybody wants to make money. They realize that AI, useful AI is here. Profitable AI is here. Compute demand is incredibly high, and compute demand is the constraint. And so let's go work super, super hard and help the world stand up AI factories everywhere. This is why it's so important. I'm so happy. Here I am standing in front of you. Vera Rubin is in full production. Vera Rubin is in full production. The supply chain we created for Vera Rubin is twice as large as Grace Blackwell. It's incredible. And what used to take 2 hours to assemble one Grace Blackwell rack now only takes 5 minutes. So not only is the capacity higher, the throughput is a lot faster, and we need it all to support the demand. This ecosystem is extraordinary. Millions of square feet has been put online to support Grace Blackwell and preparing now, ramping up now, Vera Rubin. I want to thank all of you. Vera Rubin is now in full production. Thank you. Let's take a look.
Large language models generate answers. Now AI agents can do work. But processing agentic AI is a whole different kind of problem. Agents observe, reason, plan, use tools. They manage massive context, juggling working memory and long-term memory. They spin up sub-agents, specialists on demand. NVIDIA Vera Rubin is a multi-rack pod scale system built to process agentic AI and is now in full production. The manufacturing, automation, and orchestration across the supply chain, a miracle to witness. Our journey started when we launched the first AI supercomputer, NVIDIA DGX-1. Over the next decade, we pushed every chip and system to the limit, from Pascal and the first NVLink to Grace Blackwell, the first rack-scale AI supercomputer. And now, Vera Rubin, the first multi-rack pod-scale supercomputer, built for the agentic age. It starts at TSMC. The 7 new chips that make up Vera Rubin take shape through hundreds of processing steps. 3-nanometer process, CoWoS-R and CoWoS-L packaging, HBM4 memory from Micron, SK Hynix, and Samsung. The Vera Rubin compute board, 6 trillion transistors with over 18,000 components on one board. Vera Rubin NVL72 does the thinking, prompt and context understanding, reasoning, and planning. Next, a new modular compute tray, streamlined with a new PCB mid-plane design, super chips, Connect X9 Super NICs, and Bluefield 4 DPUs, all made in place, with no cables for resiliency at AI factory scale. 18 compute trays, 9 hot swappable NVLink switch trays, new high-efficiency manifolds, liquid-cooled bus bars, carrying over 5,000 amps, the equivalent of 20 electric cars at full acceleration. Together, 1.3 million components form this third-generation MGX rack design. Congratulations to Microsoft for their operational Vera Rubin MVL72 engineering rack. Congratulations to Dell and CoreWeave as well for standing up their Vera Rubin MVL72 engineering rack. Then, the Vera CPU rack, 256 CPUs in a single liquid-cooled rack, orchestrating the models, shuffling memory, launching tools. At Foxconn and Quanta, Grok 3 LPX takes shape. 256 Grok 3 LPUs across 16 trays, 40 petabytes per second of SRAM bandwidth for ultra-low latency. While MVL72 generates tokens at the highest throughput, Grok LPX generates them at the lowest latency. Vera Bluefield 4 STX, where AI keeps its memory. Storage processing accelerated by Bluefield 4, connecting memory, storage, and in-silicon security. And NVIDIA Spectrum X Ethernet Photonics, the world's first Ethernet switch with 200 gigabit co-packaged optics, TSMC's COUPE process, chip-scale packaging, and ultra-high-powered laser dyes on indium phosphide. Vera Rubin, 5 connected rack-scale systems, a supercomputer for AI agents, 150 supply chain partners across Taiwan, millions of square feet of factory floor, hundreds of sites, chips, packages, systems, and data centers pushed to the limits of size, power, and scale. This is what we call extreme co-design. We did this with Taiwan. Together, we reinvented computing for the age of AI. Taiwan was with us at the beginning, and here today, as we bring Vera Rubin to the world. Thank you, Taiwan.
Ladies and gentlemen, Vera Rubin. Vera Rubin was not just built for AI. Vera Rubin was not built just to run AI. Vera Rubin was built to run agents. This is an agentic system. Imagine the complexity, which is the reason why agents is the last computer science breakthrough. It has taken this many years for agents to realize its potential and become useful. It stands to reason that the computer that runs it is the most advanced in the world. This is Vera Rubin. Let's take a look. Can we bring out Vera Rubin, please? And Janine, do we have the racks, the systems? It looks heavy. This is Vera Rubin. Vera Rubin NVLink 72. This is the Grok LPX. At the next GTC, I'm going to talk to you about a lot more of this. Today, we have so much to talk to you about. This is Vera CPU rack, 256 CPUs, all liquid cooled. Let me tell you about Vera in just a moment. This is the Vera Bluefield storage processing system and also security system. And of course, this is our Mellanox networking, the world's first CPO. This is Vera Rubin. Incredible technology all coming together. Now, when we built Hopper, as you know, for pre-training. Pre-training was the most important application, the most important workload we were working on at the time. Then when we worked on Grace Blackwell, everybody said, Jensen, NVIDIA is really good at pre-training. Inference is so easy. Do you remember that? People used to say, inference is so easy, we could do that too. But as you know, inference equals money. And the models, MOEs, are so complicated. And to do it at incredibly high response time, fast interactivity, and high throughput at the same time is incredibly hard, which is the reason why we created NVLink 72. Today, NVIDIA's token cost is the lowest in the world, not by 10%, by X factors, orders of magnitude. All because we did extreme co-design, all because we understood the computing model, the computing pattern of inference, and we were able to create NVLink 72. Now, with Vera Rubin, it is beyond inference. It is now inference in an agentic system. This is Vera Rubin. No cables, no hoses, no fans. What used to take, the last time when I showed this to you, we had cables everywhere. The cables were amazing to look at. But now, there's a PCB in the middle, which connects both sides. What used to take 2 hours now takes 5 minutes. The reliability and the resilience of Vera Rubin is going to be off the charts. This is our Vera CPU tray, the most advanced CPUs that has ever been built. I'm going to show you that in just a second. And this is our storage tray. 2 Vera CPUs, 4 CX9, incredible amounts of software. This is our new LPX, LPU30, the Grok system, designed for very low latency inference. The throughput is delivered by Vera Rubin and extended with NVLink 72. If you want to extend that even further, you can have Grok LPUs. Here, we have the Vera Rubin NVLink, the switch tray. This is the switches in the middle, and this is revolutionary. Because of Vera Rubin's, because of NVLink 72 and the NVLink switches that we created and invented. And this is our Ethernet switches for scale out. What's amazing is we introduced these 2 systems for Grace Blackwell. These 2 systems were created for Grace Blackwell. And today, NVIDIA is the largest networking company in the world. I'm so proud of the networking team. This is such an incredible enabler for everything that we do. I'm going to now talk to you about the next major industry we're going to be part of. Thank you. Janine? Thank you. 再见. I think there are 2,000 people back there pulling that. Okay, let's talk about CPUs. Vera CPUs. CPUs built for the age of AI. All of the CPUs until now were created for people. We were the users. We were the users, we were the renters. The way we use CPUs, we live in a world counted by seconds. The way we rent CPUs in the cloud, each one of them, more CPU cores you have, the more you can rent. The economics of the use case of the old CPU and the economics of the old CPU, fundamentally different than agents. Agents are impatient. They don't live in a world that is in seconds. They live in a world that's in nanoseconds. When it uses a tool, it wants the response time to be as fast as possible. When it accesses database, it has to come back as soon as possible. Every moment that the agent is waiting keeps it from going to the next step, the next step, the next step. It is vital that we make the CPUs as low latency as possible, as interactive as possible. So we created Vera CPU for the age of AI. Now, inside our system, it's used for 3 different ways. The first way, of course, is Vera Rubin for thinking. And inside the Vera Rubin rack, there are already 2 CPUs. As you know, we are building and selling millions of Vera Rubins. We have sold millions of Grace Blackwells. NVIDIA already is one of the largest CPU makers in the world. In the Vera Rubin rack are 2 CPUs. One for orchestrating and managing the GPUs, managing the KV cache, dealing with all of the software that runs in the rack. We also have the Grace Bluefield that is used for security and isolation. The Vera compute is used for the harness, the orchestration of the AI models, tool use, accessing the database. And the data servers are right here, Vera Bluefield, the fastest storage servers, the fastest storage system the world has ever made. And the reason why this is so vital is because agents are accessing memory so incredibly fast. These systems, the storage server and the CPUs, are now the critical path of the most expensive part of the data center. This is the most expensive for a good reason. The economics of the AI factory is tokens. And the tokens are created here. And so, of course, you want to manufacture and generate as many tokens as possible. This is where you put all of your economics. And this has to not be in the way. And so Vera CPU has great pressure on the CPU architecture, which is the reason why we built a brand new architecture from the ground up, a CPU the world has never seen before. We call it Vera. This is CPU for agents. All the CPUs of the past, we built for humans. This CPU is built for agents. Well, there are 4 things to keep in mind, the 4 takeaways. The first takeaway is that the instructions per clock of Vera has to be incredibly good because we need the latency to be short. We need the processing time, single-threaded performance, not throughput. Single-threaded performance has to be world-class, absolutely the best. Single-threaded performance, which is the reason why the IPC, the instructions per clock of Vera, is so high. It's the highest in the world. 10 instructions fetched, decoded, and executed per clock. Number 1. Number 2, the bandwidth necessary to move data in and out for the CPU has to be utterly world-class. The second thing is bandwidth per core. The third is just bandwidth, period. We're moving, remember, I said earlier, agentic systems is fundamentally disaggregated and distributed. Disaggregated and distributed. When computing is disaggregated and distributed, networking becomes the problem. Therefore, we have to move the data around as fast as possible between the CPU cores and between the CPU and the storage, the CPU and the GPU. The bandwidth around the system and inside the CPU core has to be utterly world-class. This is the first CPU that's been built a long time that is literally at reticle limits with a fabric that connects all of the CPU cores that is speed of light, 3.6 terabytes per second. No chiplet tax, no chip boundary crossings, because we need to have everything, because the CPU cores are talking to each other with extremely high bandwidth. They're not rented core per core per core. They're all working together. The cross-sectional bandwidth of Vera is off the charts. It's the first one to be PCI Express Gen 6. It is also the first one to have LPDDR5 with 1.2 terabytes per second. 2 to 3 times the bandwidth of the highest performance CPUs on the outside, 3 times the bandwidth on the inside. The bandwidth per core and the bandwidth period is world-class. Now remember, I showed you earlier, the number of CPU cores, the number of CPUs is going to be quite high. And the reason for that is very simple. We created CPUs for humans in the past. And humans, there are only 1 billion of us. There will be billions of agents. And these agents are going to be using the CPUs with very little patience because the cost of the GPU they sit next to is too high. And therefore, too valuable, too precious. Therefore, these CPUs are going to be both performant, but they also have to be extremely energy efficient so that we can cram as much CPU as we can into the factory without taking away power from the token generation, which we know is how we make money. These 4 properties, instructions per clock or single-threaded performance, bandwidth per core, the total bandwidth around the chip and inside the chip, and energy efficiency defines Vera. It is absolutely world-class. When you compare it to the highest performance x86, it is just off the charts. When you compare it in real single-threaded performance, it's off the charts. It is incredible to be able to deliver 5% improvement on CPUs. It is incredible to be able to deliver 10%. But this kind of performance speed up is just unheard of. This is NVIDIA Vera. What do you think? Let's take a look.
Agentic AI changes the role of the CPU. The CPU is now the conductor, and the GPU is the orchestra. Traditional CPUs were built for a different era, maximizing cores per socket. Slice them up, virtualize, rent by the hour. In the age of agents, the CPU is now a bottleneck to GPU utilization, directly affecting token throughput, latency, and user experience. NVIDIA Vera is the CPU, built for the agentic loop, combining NVIDIA's custom data center CPU core with a scalable coherency fabric for the right balance of performance cores and bandwidth to maximize AI factory output. At the heart of Vera is the NVIDIA Olympus core, built for modern data center workloads, branch-heavy Python runtimes, tool calls, and sandbox code execution. Each core is tuned for throughput. A neural branch predictor evaluating 2 taken branches per cycle. A 10-wide decode engine brings in more work each cycle. A large out-of-order engine keeps instructions moving. Advanced prefetchers with a novel graph engine anticipating the next data path. But fast cores only matter when data arrives correctly and on time. Vera is the first CPU to use LPDDR5X memory while correcting multiple errors simultaneously without compromising bandwidth. Vera achieves 40% lower peak memory latency versus x86, keeping cores fed on time through retrieval, analytics, and sandbox execution. NVIDIA's second-generation scalable coherency fabric unifies all 88 Olympus cores
So we first time see the PCIe Gen 6 CXL 3.1 here, and the stats are like too good. If I go back a bit, 1.2 TB per second of memory bandwidth, 3x more bandwidth per core versus the 8x86 CPUs with DDR5, 40% lower peak memory latency versus x86. A null branch predictor and the 10 wide decode engine that can do multiple things in parallel. And the large out of order engine, advanced prefetchers. These are like the top of the line breakthroughs with the Vera CPU. This is, as I've alluded to, this is the Olympus with special multi-threading and
enabling 50% faster core-to-core communication than traditional CPUs. And memory-coherent NVLink chip-to-chip connects GPUs directly to the fabric. Beyond GPUs, NVLink chip-to-chip can scale Vera up to multiple sockets, enabling massive bandwidth between CPUs. Vera delivers 1.8 times the agentic sandbox performance of x86 CPUs. Standalone Vera racks run agent sandboxes, tools, code, and data pipelines. Tightly coupled to Rubin GPUs, Vera keeps accelerated workflows moving. NVIDIA Vera BlueField 4 STX powers context memory and AI storage. Compute, networking, storage. Vera is the CPU for the age of agents.
yeah, so they have like combined the compute network and storage and reduce the cable clutter, so everything is streamlined. And I think so those are into their fabric, the company that they bought. They should mention it here too. They're using their patented technologies in the Vera Rubin cluster right now.
This is going to be our new major growth driver. The reviews are already coming out, and it's pretty good. That's pretty good stuff. Now remember, Grace and Vera are also the most highly qualified CPUs in the world of AI because every single data center, every single cloud, every single enterprise, every company that works with NVIDIA on AI has already qualified Grace. The entire software stack has already been optimized for Grace. Every company will be qualifying Vera. Vera will be the most optimized agentic CPU in the world, simply because it's going to go with Vera Rubin, simply because we made the big hard switch. In fact, during Grace Blackwell transition, the biggest risk was going from external CPU x86 into Grace Blackwell. That transition was extremely dangerous, but we did it with incredible execution. Now Grace is literally synonymous with Grace Blackwell. When people say Blackwell, they say Grace Blackwell, because it is utterly now everywhere. Every company's software stack has been optimized for it, everybody's security stack has been optimized for it, and now here comes Vera. I'm super excited about that. Now look at some of the performance numbers. Speedups is one thing. It is extremely hard to speed up SQL. SQL, the most famous domain-specific language, DSL, that has ever been created. Before SQL, before CUDA, there was SQL. Before OpenGL, there was SQL, invented by IBM. Today, it is the structured database engine of the planet. Everybody uses SQL. This is SQL running 3 times faster, not 10% faster. Not 25% faster, 10 times, 3 times faster. Incredible. This is real-time. The next one is real-time stream processing. Remember, your AI is going to be not just reading documents. Your AI is going to be watching for telemetry, especially inside a factory, inside a stock exchange. You're going to be looking for telemetry continuously. The burst of data that's coming in goes into a CPU. This is Vera CPU running real-time stream processing for New York Stock Exchange. Lynn Martin, the president of New York Stock Exchange, has been so gracious to partner with us. This system is run all over the world in real-time stream processing. Vera CPU 6 times, all because of the bandwidth, the single threaded instruction execution, the bandwidth inside between the cores, the bandwidth outside. Vera is completely revolutionary. That's Vera. You know, X factors is something you talk about when you're talking about GPUs. It is quite rare that somebody talks about X factors on real workload that is associated with CPUs. So I'm so proud of the team. You guys did such a great job. We have an extraordinary roadmap coming. But what's really exciting is almost everybody is supporting Vera. They're as excited as we are. This is Vera opening up. It's opened up a brand new market. Agents is a new workload. We built CPUs for humans in the past. We need CPUs for agents, agentic systems. Their properties are different. Why would the old CPUs be the same? We are building millions and millions of Veras, And to go to market with us, Taiwan's ODMs and computer makers, all the OEMs, and you can see the early adopters. The early adopters are the agentic companies. This is the beginning of a new market, a market that never existed before. It's not going to take away from the old markets, but this is a new market, CPU for agents. And this market will surely be larger than the last. And the reason for that is because there'll be a lot more agents than there are people, and then the agents are very impatient. So NVIDIA, Vera, CPU. Thank you. This is the most important slide, really. This is the takeaway. The takeaway here is that this is the application pattern. This is the computing pattern of the next decade. Agents, harnesses, orchestrating large language models. Every company will run it. Every company will be an agent company. Every company will have agents running inside. Every company will see that agents will need its own operating system. Every company is asking us, how do we run agents safely? How do we build agents for our own workloads? And so we have the NVIDIA Agent Toolkit for Enterprise AI. You've seen me build this in plain sight. Almost everything that NVIDIA does, as you know, at every GTC, if you go back and look at my GTC 5 years ago or 10 years ago, you will see today. This. You've seen me talking about for several years now, because we've been building for this moment. There are 4 things that companies need in order to build agents as a service or build agents to operate. The first thing you need is you need models. Of course, large language models. The smarter the better, the cheaper the better, the faster the better. The second is you need a harness to orchestrate the whole thing. The third, these models want to use tools, and these tools come with its skills. And I showed you CUDA-X libraries. Those are going to be amazing tools for the agents in the future. And then lastly, you need a runtime. You need the operating system that holds it all together. This is the NVIDIA Toolkit for agents. It includes models that you can modify, NVIDIA's world-class open models, and I'll show you more. You can run agents from anybody. You could run Cloud Code, Incredible Agent, Codex, Incredible Agent. You could run it inside this harness called OpenShell, which will be highly secure for your inside the enterprise. The shell protects the agent, keeps it grounded in security policies. Privacy is protected. Its rights and privileges are given. Its identity is protected. And so this OpenShell is being adopted all over the world. NVIDIA OpenShell is open source. You're going to see so many companies adopt it. Red Hat, Canonical, Microsoft. It's going to be adopted everywhere. This is the runtime. And this runtime is fully optimized for the NVIDIA AI platform, which is everywhere. So you can run OpenShell in any cloud, on-prem, and even on device. So you have now tools and libraries that they can use. You have models that you can modify or use as is, or you have agents. This would be OpenClaw, Hermes, another incredible harness. These agentic harnesses can now run on-prem or for you anywhere, okay? So 4 things, and this represents the operating system of the modern enterprise. Now, how do we use this? One of my favorite use cases of agents is chip designers. It is the single most important thing that NVIDIA does. And so, of course, we have to partner with Cadence to build super agent, a chip design super agent. It is orchestrated by Codex or Cloud Code. It has RTL and architecture diagrams or schematics or specifications as input and whatever you need to fix. And together we created some super agents that are optimized for the NVIDIA runtime with Nemotron. And let's take a look. It's really incredible.
Cadence and NVIDIA are partnering to build chip design agents. Hundreds of thousands of NVIDIA chips come together to make the AI factories that power the world's frontier AI models. Designing these chips and the systems they run in is one of the hardest engineering challenges. Trillions of transistors, 3-dimensional circuits, microscopic scale. Every gate, every wire, synchronized to picoseconds, must work in perfect harmony with no margin for error. Physical prototypes are too slow and too costly. So engineers work in the digital realm. Each chip begins as a set of architectural specifications, then translated into RTL, the language of chip design. RTL must be verified in simulation. A single bug can delay a chip by months. At NVIDIA, thousands of engineers, billions of compute hours per year, millions of tests, written, run, and debugged. A cycle that takes teams weeks. To compress this cycle, Cadence and NVIDIA built a design verification agent. Codex orchestrates the process. Cadence chipstack launches the RTL verification loop, powered by Nemotron and secured by NVIDIA OpenShell, calling on expert sub-agents in RTL generation, test bench creation, regression testing, and debug. The system drives itself. The chipstack agents run hundreds of simulations with Cadence Xcelium, formal verification with Jasper. Design flaws, revealed. Bugs in the code, fixed. What once took weeks, now takes hours. Verification cycles, over 40 times faster. Together, NVIDIA and Cadence are reinventing chip design with AI agents.
From weeks to hours. NVIDIA has thousands of chip designers. We are going to hire hundreds of thousands of Cadence super agents to work with us so that we can accelerate our company, so that we can be even more ambitious, create even more amazing things, run even faster. You saw earlier that the toolkit with models, harness, tools. The tools in this case are Cadence simulators and verifiers, formal verification systems. It is the reason why we're working with Cadence so hard to accelerate all of their tools on CUDA, because the agents are impatient. The agents want the answer immediately. And so models, harnesses, accelerated CUDA, accelerated libraries and tools, and then the runtime. What you saw just now is all of that coming together. Now, one of the things that it starts with is a great model that Cadence could modify and tune to be expert at the Cadence workflow, at the Cadence expertise, so that they could create super agents that are proprietary to Cadence with their proprietary knowledge. They have to start with an excellent model. We call it Nemotron. NVIDIA is dedicated to build open models for the world so that all of you, all of us, could create our own agents. Today we're announcing the Nemotron 3 Ultra. Yep, our next open model, and it is smart. The Nemotron models not only give you the model, we give you all the data that we use to train the model, and because we have a coalition of incredible partners, you can see all of our partners down here, we work together, contribute data to each other. Nemotron is trained on one of the largest suites of long-running reasoning models, long-running task-solving, tool-using data sets in the world because of all of our great partnerships. All of this from the model, the training script, and the data made completely available to you. This is open models at its best. The best open model system policies in the world. Simple goal is so that you can take all of it, add to it, make it even better, make it yours. Nemotron. Three Ultra is 5 times faster. This is the world's first model based on a hybrid architecture of SSM state space models with mixture of experts. The architecture is incredibly fast. We made it fast so that you could think fast. When you think fast, you can think longer at the same cost. So 5 times faster. It is also 30% cheaper, 30% lower cost to run in total flops.
Let's go. This is awesome. Nemotron 3 Ultra 550B. Like, it performs, the cost efficiency is good. Like, I bet they would have tweaked the efficiency goes to the maximum to make this look good here and perform as well as it could. Let's see what the numbers are.
And total inference time than even the most cost-effective in the world. We're comparing against the world's best open models. Frontier Smart, 5 times faster, 30% cheaper, completely open. We're completely dedicated to this. This is now Nemotron 3. We're currently working on Nemotron 4. So this entire toolkit, from models, harnesses, tools and skills, and runtimes, is the reason why every enterprise company in the world has the ability now to create their own agents, just like Cadence did with their super agents. And we're working with so many companies, Cadence and CrowdStrike and Dassault and Palantir, SAP and ServiceNow. People always said, Jensen, the agents are going to disrupt these markets. I said completely opposite, and you can now see it. Agents is going to create the largest opportunity ever for my partners and friends. And we have the NVIDIA Agentic Toolkit for enterprise AI to help them. So, there you go. First, Vera Rubin in full production. 2, Vera CPU built for a new generation for agents. And 3, NVIDIA's enterprise AI toolkits, so that every enterprise and every enterprise software company can build agents. My relationship with you started here. And many of my friends and partners here in Taiwan, your companies started here. This is, in a lot of ways, the beginning of the modern computer industry, 4 years now. NVIDIA is 33 years old. The PC industry was already starting to get to Windows 1 and Windows 2 and Apple 1 and Apple 2. And by the time that we came along, Windows 3.1 was the PC. And as you know, Windows 95 made PC personal. It took PC from enterprises, companies, and made it into a consumer electronics device. Everybody should have one, and everybody does. This is the beginning. This computing platform did several things incredibly smart. Windows was not just disaggregated, as you know. Windows was properly abstracted. It was architected just right. Systems BIOSes, open chipsets. The operating system with drivers that could be connected and installed at runtime. And an abstraction layer with a multimedia API that opened up the PC to what we all know today. Each one of these elements were essential in making the PC so popular. 40 years later, Microsoft and NVIDIA are going to reinvent the PC. This is going to be the new PC. Now tomorrow night, I think it's tomorrow night our time, but I'm going to be with Satya. We're going to talk a lot more about the work that we're doing together. Microsoft and NVIDIA, over the last 3 years, it took this long to completely reinvent how the PC is going to work so that we could be ready for this moment. As I mentioned earlier, that compute pattern called the agent is going to run in AI clouds. It's going to run inside enterprises. It is also going to run on your PC. What's going to happen to that PC when it has an autonomous agent? An agent that's helping you, that understands you. You could talk to it. It could look at you. You could ask it to read files, go help you, do some research. It could do a lot more that I'll show you. But the new operating system is, of course, the old operating system plus large language models. Large language models, in a lot of ways, is the modern version of DirectX. It has, of course, input and output, understands prompts, it understands computer vision, it can generate video, it can generate sounds. It is the modern extension, the intelligence extension of the PC, of a computer. On top of that, the application, as I mentioned before, is going to be replaced by now an agentic runtime. And that is the modern application, an agent. Let's now take a look at what it can do.
It started with a spark, an idea, to reimagine the PC for the first time in 40 years, for the age of AI. What becomes of our personal computer in a world of agents? Agents running natively, connected to models, local or in the cloud. our personal AI, sandbox for security, running continuously, getting work done. The chips and the OS must evolve. Introducing RTX Spark. Everything we've learned over 33 years distilled into one chip. Blackwell RTX GPU with 6,144 CUDA cores, 1 petaflop of AI performance. A custom 20-core Grace CPU built in partnership with MediaTek. Fused by NVLink. 128 gigabytes of unified memory. TSMC 3nm process. 70 billion transistors. And in close collaboration with Microsoft, a Windows platform for agents. We're reinventing the personal computer. For creating. For gaming. For agents. This is the dawn of a new personal computing revolution. And it starts with NVIDIA RTX Spark.
Here it is. Of course, I gotta show you the most beautiful part, which is video games. It's also the closest to our heart. This is Forza. This is 007, by the way. The new 007 game, I'm looking forward to playing it. I look a little bit like him. Ladies and gentlemen, NVIDIA's RTX Spark laptops. Now,
So this is great. NVIDIA's RTX Spark 128 GB unified memory with 600 Gbps NVLink C2C, 20-core Grace CPUs, Blackwell RTX. This is the full NVIDIA stack that I can get.
thank you. I have too many things in my pocket. 太多东西了. Okay, all right. This is the most amazing chip the world has ever built. This is the N1X that we built in partnership with MediaTek. I think I saw Rick earlier. This is N1X. This is a beautiful chip. This is a chip that, frankly, would take 33 years to build. And the reason for that is because 100% of NVIDIA software stack runs here. If you want to run digital biology, no problem. If you want to do seismic processing, no problem. You want astrophysics, no problem. Everything associated with CUDA, all the physics, all the biology, all the genomics, all the AI, no problem. All the computer graphics, no problem. Every single application NVIDIA has ever created, and every single application that Windows has ever run. Microsoft and NVIDIA meticulously optimized everything so that this computer literally runs everything the world has ever created, plus it now runs agents. An incredible computer. I'm so proud of it. Okay, now I want you to keep that in mind in the next video I'm going to show you. Just imagine everything here is going to run on your PC. Now that computer could have a local Nemotron 3 Ultra model or Nemotron 3 Super model, or it could have a Cloud Code or Codex or some other model in the cloud or something on the network, and it's going to work and do something amazing. Let's play it.
Every house starts as an idea. Getting from idea to design takes a myriad of tools, expertise, and a lot of time. Now, an agent running locally on RTX Spark can help me design a house using the tools on my laptop with an OpenShell sandbox, running the Hermes harness connected to Claude Sonnet in the cloud. I select a site, share my concept sketches and mood board of styles to inspire my design. And the prompt, a text description of the requirements and the design intent. My agent goes to work. Using the tools on my laptop, it opens Rhino and starts modeling the site, shaping terrain, setbacks, and the building envelope. Then it proposes building forms, optimized for cost, comfort, and quality. With the form defined, my agent generates the interior layout. Walls, circulation, rooms begin to take shape. I jump in whenever I want, to adjust, to change. Doors, windows, and structural elements are placed automatically. My agent detects its own mistakes and fixes them. When I approve, the agent exports the model from Rhino into Blender. Materials and object properties transfer with the design context intact. I fine-tune the materials, get the look just right. Then, I pick the shots. Blender renders the house. My agent, using generative AI with the Flux 2 model, makes them photoreal. Multiple viewpoints, lighting conditions. What was once a complex workflow is now guided and simplified by my agent. Working with on RTX Spark. Design at the speed of imagination.
PC in the world of agents. The developers are so excited about it. This is an incredible computer. All of the acceleration, all the software capabilities associated with it, working with every developer to make it incredible for all of you. The next one, Adobe. Incredible tool suite, of course, used by tens of millions of people around the world. They have re-engineered the architecture, the core of Adobe Photoshop and Premiere, and they'll release it for RTX Spark. It is twice as fast. It's already fast. Now it's going to be twice as fast. And it's also designed to be agent-friendly. With its MCP server, it can now interact with agents on your laptop. The number of customers, the number of partners that are so excited to bring RTX Spark to the market is just incredible. You know, this is the first across the lineup of PC reinvention for 40 years. And I'm just so happy that all of you and the ecosystem around the world has joined us. This is basically everybody. Everybody will support RTX Spark and will be building incredibly smart and powerful and beautiful laptops with all of us. Thank you very much. But that's not all. That's not all. RTX Spark is a reinvention of laptop. But in fact, Microsoft and NVIDIA is reinventing all of PC. And today we're announcing a whole new line. 3 revolutionary Windows machines covering desktop, laptop, and workstations. All 100% Windows compatible, 100% CUDA, 100% NVIDIA AI Tensor Core. Everything that you see that runs on NVIDIA in all these different platforms around the world runs here. This is the first completely re-engineered, reinvented line of PCs that has happened in 40 years. Now, what's really amazing is this. So this is the RTX Spark laptop. This is the desktop. So this one's from MSI. Joseph, this one's yours. Okay, look how beautiful it is. This agent could run 24/7, meter-free. And you could download your agent. You could raise your lobster in here. This is your claw. It's running all the time. No meter anxiety. And it's sitting here connected to your whole house, connected to your laptop, connected to your display, all the cameras, your dryer, your water cooler, your water heater, your everything, whatever you want. Your security system, all connected to this, and this becomes your personal AI, your personal AI agent. And it gets smarter and smarter and smarter over time, because today we have Nemotron 3 Ultra, tomorrow we have Nemotron 4, and then Nemotron 5, Nemotron 6, and we just keep getting it smarter and smarter and smarter. And meanwhile, this is sitting at home helping you do things. If you want to book a travel, no problem. And if you want an incredible system, this is a DGX station for Windows, compatible with Windows, runs everything in Windows, and it has 768 gigabytes of memory. And so you could run a trillion parameter model. This is unbelievable. 20 petaflops, 8 terabytes per second of memory bandwidth, and this sits by your desk. You basically, if you're a developer of large language models, you're a developer of agents, having this sit by your desk gives you all the compute you need, and then when you deploy it, you put it into the cloud. Now, there's something that, if you look at this and think about this, something is happening here. Remember, 15, 20 years ago, we used to have an idea called a phone. Today, we have an idea called a PC. Today, when you think about your phone, the one thing you don't do with it is make phone calls. You do just about everything else. And so that phone means something very different to you than a phone of the past. I am certain what's going to happen here is that the PC 10 years from now and the PC that you think about today, a tool, whether you launch applications, click and type, and this PC is going to be completely different. Here's my theory. I can totally imagine, just as every house today has a home theater, or many houses have home theaters, big TVs, lawnmowers, dishwashers. I could totally imagine that someday there's actually an AI supercomputer in your house. And so you could run no meter laptop connected to your display, and this becomes your personal AI agent. And it gets smarter and smarter and smarter over time, because today we have Nemotron 3 Ultra, tomorrow we have Nemotron 4, and then Nemotron 5, Nemotron 6, and we'll just keep getting it smarter and smarter and smarter. And meanwhile, this is sitting at home helping you do things. If you want to book a travel, no problem. And if you want an incredible system, this is a DGX station for Windows, compatible with Windows, runs everything in Windows, and it has 768 gigabytes of memory. And so you could run a trillion parameter model. This is unbelievable. 20 petaflops, 8 terabytes per second of memory bandwidth, and this sits by your desk. You basically, if you're a developer of large language models, you're a developer of agents, having this sit by your desk gives you all the compute you need, and then when you deploy it, you put it into the cloud. Now, there's something that, if you look at this and think about this, something is happening here. Remember, 15, 20 years ago, we used to have an idea called a phone. Today, we have an idea called a PC. Today, when you think about your phone, the one thing you don't do with it is make phone calls. You do just about everything else. And so that phone means something very different to you than a phone of the past. I'm certain what's going to happen here is that the PC 10 years from now and the PC that you think about today, a tool, whether you launch applications, click and type, and this PC is going to be completely different. Here's my theory. I can totally imagine, just as every house today has a home theater, or many houses have home theaters, big TVs. Of that journey, this is the beginning of a new line. And so we have a roadmap for this. This is a brand new product family for us. Every single generation of architecture, we will have a desktop, a laptop, a workstation, and then a desktop, a laptop, and workstation. And the thing that I'm just incredibly pleased, incredibly honored, is that 100% of the world's PC industry has joined us to reinvent the PC. A new line, a new beginning. Thank you. As you know, agentic AI is just a digital robot. It understands, it reasons, it plans, and it acts and uses tools. Agentic AI is going to run across all of these computers. And you've seen me talk about each and every one of these over time. We're working on humanoid robotics computers of all kinds. We're working on self-driving car computers. We're working on satellites. You have GeForce, which has tensor cores. I just talked about a whole new line of PCs. Agriculture equipment, manufacturing equipment, heavy industry equipment will all be agentic. You'll even have a little agentic helper for yourself. Even your base stations, the radio stations of the future, are going to be agentic. Understanding traffic and thinking about how to coordinate with the other base stations so that you could use as little energy as possible, increase the utilization, the efficiency of the spectral efficiency. And so everything will run agents. Today, NVIDIA is largely in the center, but I am pretty certain that there will be tens of billions, hundreds of billions over time of agentic systems, agentic computers that are going to be running around the world. The biggest problem is data. In the case of language models, all the English and all the language that we have on the internet that we train on was from the perspective of us. We wrote it and we're reading it. However, in order to create data for AI, robotics, it has to be in the perspective of the robot. And most of the world's video data is from a third person, not first person. And so agentic systems, robotic systems, physical AI, the data is the hardest problem. You've seen us move up this ladder. We started with teleoperations, which is basically human demonstration. This is no different than the big breakthrough of reinforcement learning, human feedback. Then we use simulation. This is where Omniverse comes in. This is no different than reinforcement learning, verifiable rewards. Okay? And so we use these systems to bootstrap the AI model, the physical AI model. Eventually, we're able to learn from third person, reprojecting it into first person. And now, eventually, through bootstrapping, we have a world foundation model that can understand the physical world from any perspective you want. Third person, first person, outside in, inside out, doesn't matter. This is a big breakthrough indeed. And today, we're announcing Cosmos 3. Cosmos 3 is the frontier of physical AI. We are at the frontier with language models. There's so many people working on it. However, in physical AI, we are absolutely the world's best. I'm so proud of the team for doing this. This is the foundation model for all of your work. Whenever you want to create a robot, whenever you want to create a factory robot or a robot that works in a factory, any kind of robot that involves physical world, you now have a companion, a Cosmos 3, that can understand and reason, it can generate, it can simulate in the loop, it can even be the policy itself. It is on the top of leaderboards all over the world. I'm incredibly proud of Cosmos, and today we're announcing Cosmos 3. Let's take a look.
The real world is infinite and unpredictable. Physical AI needs data, but real world data is impossible to scale. For physical AI, compute is data. This is Cosmos, an open frontier omni model for physical AI, built on a new mixture of transformers architecture. Pixels, action, sound, and language flow into the autoregressive transformer, which reasons, plans, and instructs the diffusion transformer, which generates what comes next. Developers post-train Cosmos across embodiments and use cases. As a VLM, Cosmos watches the physical world, understands what's happening, describing scenes, and flagging what matters. As a world model, Cosmos generates physics-accurate synthetic video from an image, text, or video. As a simulator, Cosmos closes the loop for policy training and evaluation. And as the foundation of NVIDIA OmniDreams, an action-conditioned world model, Cosmos predicts the future, frame by frame. Post-train Cosmos, and it becomes a world action model. Perceiving, reasoning, planning, generating actions. For robots of every kind. For everything that moves. A new kind of data, a new kind of teacher, generated by computer. Cosmos, the foundation for developers of the age of physical AI.
It takes data plus compute, gives you AI. Now that we have AI, compute is data. And so use Cosmos 3, train a whole bunch of AI models. Cosmos is such an incredible open model system. It's exactly the same as Nemotron. We open model, we open the data, and we even open how we trained it so that you could enhance it for yourself and turn Cosmos into your proprietary model. We have such incredible partners working with us in so many different industries. Now, the model itself is the most understandable part of the AI stack, but the AI stack is very complicated. It has generators, the model, simulators, and the runtime. Just as it is for agentic systems, these cars, or essentially a physical AI agentic robot that is an autonomous vehicle, has also this complicated stack. Today, we're announcing Alpamayo 2, an open model for self-driving cars. We're working with car companies across the world. If you look at these brands that have signed up for the NVIDIA Hyperion, that are building NVIDIA Hyperion cars, this represents about 80% of the world's cars. The manufacturers represent 80% of the world's cars. We are going to have a whole lot of NVIDIA Hyperion systems that are able to run Alpamayo or anybody else's AV stack. We are also connected into mobility services. Approximately 97% of the world's mobility services are connecting with us so that when we deploy Alpamayo on the Hyperion runtime with the Halos operating system, we will be able to connect all of these services across the world. Let's take a look at this.
Hey Mercedes, let's go to my favorite sandwich shop.
Routing to your destination. Lane is clear. Pulling out to start drive. Nudge left due to the stationary lead vehicle ahead blocking our lane. Slow down to stop at the stop sign controlling the intersection. Stop to yield to the pedestrian since the person is in our lane. Yield to the cut-in vehicle from the left. Nudge left to clear the stop vehicle blocking on the right. Keep distance to the cut-in vehicle since it is merging into our lane. Nudge left due to the stop van blocking the right side of our lane. There is our pedestrian crossing ahead. Stop to keep distance to the lead vehicle. Keep distance to the vehicle directly ahead in our lane. Keep distance to the vehicle directly ahead in our lane. Stop to the stop sign since the intersection is controlled. Stop to yield to the cross traffic since the vehicle is crossing ahead. Keep distance to the lead vehicle. Nudge right due to the truck blocking the right side of our lane. Nudge right due to the truck blocking the left side of our lane. Left due to the truck blocking the right side of our lane. Your destination is on the right.
Alpamayo, the world's first reasoning autonomous vehicle. If you let it talk all the time, it will drive you crazy. But we're very happy that it's talking to itself all the time. That's called thinking. And so Alpamayo is a reasoning car. The technology that we've created also applies to humanoids. Of course, there are many new breakthroughs that has to happen. The NVIDIA Isaac GR00T is our humanoid robotic stack. Model, data generation, simulation, the runtime, including the operating system. This represents GR00T platform, the Isaac GR00T platform. Every one of our systems, as you can see, the exact same pattern, whether it's agentic system for the cloud, agentic system for the PC, a robotic system for a self-driving car, a robotic system for a human and robot, all the same. And of course, in every single case, we build everything completely. We build everything vertically, completely, integrated with co-design, extreme co-design, and then we open it up for everybody to use whichever part you like. And whatever you want to use, we even help you modify. But the one thing that is missing is we need a reference platform for robotic systems. These robotic systems are so complicated, so many motors, so many sensors, so fragile, and yet we need to have a way to deliver these reference platforms just like we do with PCs and DGXs and clouds and self-driving cars. We now are going to do it for robots. Today, we're announcing the NVIDIA Isaac Groot, a reference humanoid robot, all fully integrated. 25 degrees of freedom on each hand, made by Sharpa. 31 degrees of freedom on the robot. 6 feet, 150 pounds, just like me. The first number is shorter, the second number is bigger. Otherwise, pretty close. And this platform runs the new Thor and our entire software stack. Data generation stack, data simulation stack, the runtime, all integrated into a robot that is designed for everyone to use. Now, we built this for higher education and university researchers because for them to build this is insanely hard to do. And so let's take a look at that.
The next leap in AI is general-purpose robots, humanoids. But building one is hard. Every team starts from scratch, stitching together simulators, teleop systems, data pipelines, and training infrastructure. Months of setup before research can start. NVIDIA Isaac Groot, an open development platform for humanoid robots. Open models, simulation and training libraries, and data generators. Plus, the robot computer. Fully pipe clean, ready to go in hours. First, set up the simulation environment in Isaac Lab. Capture demonstrations with Isaac Teleop on a real or simulated robot. Generate synthetic data with Omniverse and Cosmos, scaling one demonstration into thousands. Train policies, evaluate them in Isaac Lab Arena. Deploy through Isaac Ross, running on Jetson Thor. Every element, modular, open. Use ours or swap in your own. Groot is powering robotics research across every discipline, for every domain, from research labs to factory floors. One open platform. And now, a new addition. Isaac Groot reference design robots. Built on NVIDIA's open platform. Ready for frontier research, for any lab, anywhere. The age of robotics starts here. NVIDIA Isaac Groot.
So many robots. We're working with just about everybody who's working on robots in the world, or robotic systems in the world. Let me tell you what I told you. The computer industry has been completely changed. In the last 6 months, everything changed. Everything changed because agents were realized, and it converged with the latest frontier models, and it made possible the AI to now do useful work. The computing pattern will repeat over and over and over again. This computing pattern of an agent, that's a model, a harness that uses tools with skills and runs in a runtime. That runtime depends on whether it's in the cloud or on-prem, on a PC, or in a robot. But the computing pattern is exactly the same for all of them. You will use different harnesses because of your preference. You'll use different models because of your preference. You will improve them for your proprietary use. You will create super agents that you can rent to other people to help them do their work. This agentic platform, this agentic pattern, NVIDIA has an enterprise AI toolkit. This is a wonderful way for all of you to engage AIs, and for us, it's a wonderful growth opportunity. Vera Rubin is in full production, whereas Grace Blackwell was created to process AI, particularly inference. Vera Rubin was created to run agents. It is in full production. It is much, much more than a GPU. It is an entire disaggregated, distributed agent processing system. NVIDIA has really become an infrastructure company, not just a GPU company, not just a systems company, but an infrastructure company to help you generate the maximum revenues, the maximum profit, and to get there as soon as possible. The agent world, this new way of doing computing, where you build CPUs now for agents, not for people. CPUs for agents has its own special requirement, and our NVIDIA Vera is revolutionary. I'm so happy about its ramp. The orders already is going to make it the fastest and the most successful product launch in our company's history. NVIDIA and Microsoft has created a whole new line of PCs. This is a new beginning. And of course, that exact same agentic processing pattern, computing pattern that I just described is also going to run on all kinds of devices. I mentioned PCs, but in the future, it'll be robots and satellites and base stations and factories in the cloud, on-prem, at the edge. This pattern, agentic AI system, this agentic computing pattern will be replicated in computers all over. How we think about the personal computer will very likely change. I want to thank all of you for your partnership, your friendship. We couldn't be here without everything that we do together. I'm so proud of how you've been so successful this last year. The next year is going to be even more. I have one more thing for you. Let's take a look.
You ready, Tyrone? Let's do this. The keynote's done at Computex. Jensen showed the world what's next. Useful AI has arrived. Agents working by your side. But in case you missed things we said today, we gonna break it all down for you, type A.
Agents used to be misunderstood. Only movie stars had them in Hollywood. Now we all got teams making dreams come true. Building companies from living rooms, but they need so much compute, we hear ya.
That's why we created Vera. Ruben Skull, the show is true. The cheapest tokens coming through.
10 times faster inference heaven. More special agents than 007.
Bluefield keeps agents' memory true.
Now let's talk about its CPU.
50% faster, that's outrageous.
Not for Vera.
It's built for agents. NVLink Fusion lens A6 smartly.
Everyone's welcome to the NVLink party.
Well, if you like that introduction,
Vera Rubens in full production. Nemotron Ultra leads the run. 5x faster work gets done. Nemocloud keeps the guardrails right. OpenShell keeps the sandbox tight.
your code migrated and reviewed.
All before this song is through.
AI is a 5-layer cake. Computer's new. Make no mistake.
Global AI clouds build lots of gigawatts. DSX keeps power lean, connecting dots.
Every watt optimized for you.
So you can have your cake.
Can eat it too.
RTX Spark is finally here.
Biggest PC moment in
40 years. Agents powering all workflows. Running anywhere Windows go.
Harnesses run on CPU.
Models fly on GPU.
Cosmos builds worlds that robots need.
Turning compute into synthetic feed.
Out from IOCs and reasons through.
Understands roads like people do.
Who is how they learn to move.
Learning skills and finding growth.
Geometry is powered by gold.
The future's humanoid. Count on more. Future's bright, come see what's next.
Thank you, Taiwan.
Welcome to Computix.
大家谢谢 Have a great Computex. 大家谢谢 Thanks for an amazing year. Thank you for all your friendship and support. Thank you. Take care. Have a great Computex.
Woke up feeling something shift. Same room, the air felt big. Mirror said I'm still that kid. I said that was the hardest one.
This was awesome. Got to review the laptops and the Windows that can run Forza, EA FC26 and others that I hugely depend on. So it will be fun. The next couple of weeks will be fun. I hope in India they ship it soon because they say that it's coming in fall. So that's what like it will be like right along the time when the new graduation season starts. So they will have a cycle refresh then, and this will be a huge for the Windows ecosystem. Like AMD is currently the leader right now, and this will be near the top of the line, I hope. The workstations are good. The GX workstations with 768 GB of memory. They are too good. Like I can take a deep dive there too. most importantly, it will be able to run my Windows games, which I can't live without. Let's see what will be the price. I think so. If it's in $5,000, or even $7,000. I may be able to go with that. So these are the issues on the VLLMs and transformers. Uh, Adding VJEPA 2.1 inference support on Hugging Face transformers. So, like, they are working here. Corrected rope implementation, converters from VJEPA 2 to HF, so in their format, and configuration of the VJEPA 2. So, like, they have upgraded from VJEPA 2 to 2.1, I think. Let's view it on GitHub. This is on the checkpoints on VIT B16 with 80 million and 300 million parameters, and VIT G16 with 1 billion and 2 billion parameters too. So the smaller ones, the 80 and the 300 million ones, are distilled, and the larger ones are large, like, and they aren't. This is linear FA versus neural FA architecture comparisons. So, like, if that you can see from the figure here, the fixed fee feature map, the that state goes to the fixed fee feature map, and using the dot product, the q value single uh, comes out. And you have in the neural FA, you have multiple layers. So this is the deep, I think so, RL series, yeah. A reinforcement learning nano degree, which is from the daily dose of TS. They are good people, and like I will recommend everyone to take a look at them if they are learning or want to go on some interviews. This is tabular V to parameterized V placements. Uh, like part 6 of the course is here. I think so. I won't have the whole access, but since I haven't subscribed to the course here, but yes, you can see the gradient Monte Carlo that uses return as a target, semi-gradient T0, semi-gradient Sarsa, semi-gradient Q-learning. Yeah, so like this, I have all done it in my past years and made a course of it on ToyML YouTube channel. So it's all there. If you want me to take a stab at that, then like I have on the button on the uh, on this book, The Sutton and Batu by like the reinforcement learning introduction by Sutton and Batu. So here is the full PDF. And the course that I like, the chapters that we had gone through, YouTube, Trimal, so this was a cohort based course, like not a course per se, just a kind of a book club in which we had gone through the nitty-gritties of if I am able to find this week in Trimal or something like that. Yeah, the Trimal AI podcast. Oh, this is the podcast channel, and there's this community channel, Trimal community. So here, like, of course, this is the reinforcement learning study group, the playlist. Some sort of transitions are I'm totally because the availability and if we consider the discount rate too, if we are expanding our state.
So, what are your thoughts on
Two states. This is my voice. I kind of like 5 years uh, ago, I wasn't too well versed, so there might be some mistakes here in this playlist, the reinforcement learning study group, in which we go through this book. But like, take it with a grain of salt, and yeah, uh, like the book details that you see are pretty good, and the code that we go through are like honestly very good. But uh, in the mathematical formulations, that since I am not a, reinforcement learning uh, doctoral candidate, so I come from a engineering background, so I didn't have the vocabulary then to view or to explain everything using the perfect words that were required at that moment. So I might be like beating around the bush, or like might be confused sometimes. But yeah, if you have a patience, then it is a great watch for introduction or beginning to give you guys an idea of like how to go into RL, or how to stop, how to start. But this right now, this is currently the one of the best projects that you can like best learning material that you can look at, the reinforcement learning course. This along with the Hugging Face. The Hugging Face one is also good. Let me give you guys an idea of the Hugging Face course. This is model, docs, enterprise, pricing, languages, organizations, learn. I think so. It is in the learn. Yeah, the robotics course, the agents course, uh, these are all good. Like the LLM course, the deep RL course, that this is the course that I was talking about. Introduction to these is pretty good. I will share you the link to this, so you guys can take a stab at it. This course and this one, that's currently happening here in Daily Dose of DS. This is a membership only, so I only get to view 50%, but yeah, this is good. Okay, then moving on. This is PCAs versus TSNEs, a popular DS interview code question. Purpose, types and algorithms, uniqueness, projection type, projection approach, TSNE, projections, can be misleading. That's a wrap. Masterful AI engineering. This is Turkish translation, read me. This was a disaster from my perspective. Anthropic gave us credits and OpenAI didn't, so that's why I didn't participate in this Outskill and OpenAI course. Kind of a competition, a hackathon that happened for 7 days. My initial idea got selected. Of course, it will because I have many good ones, but uh, the problem was they didn't give me the credits, not anyone. So that's why that was a no go for from many people. This is DeepSeek AI, DeepSeek V3 tile. VLM project, OpenAI developer, MRV2, Llama, and Mistral dense models. Fix broken dataset scripts path. MOEW and A16 method quantization. I think that this is the MOE refractor migrating to the new MK Oracle scheme. So this schemes, let me look at it in detail. Like these are the checks and fixes. So the migration is an updated version of 4267. So like this is using Mergify. And yeah, I don't know what exactly are they migrating over because the docs aren't quite as because the previous import was broken here with the MOE refactor tests. So which they did. The checklist that they did was like good. The merge was good, but when importing it was broken. So New AI chip powers world's clearest TWS earbuds. Okay. This is a paid advertisement. I think so. This agent ready, the newsletter from Gear. Uh, like this is good too. I have been following up on Gear for a very long time, and they introduced the Gemini Enterprise Agent Platform, the Data Agent Kit that deploy production ready agents and scale agents across enterprise. These are like agent platforms and coordinating AI agents to do business, like solve business problems. So, so this is the Gemini Enterprise Agent Platform that they launched. They launched on April 23rd. These were the models that they launched with, and build, scale, govern, and optimize. Keep reading. Our customer Gemini Enterprise Agent Platform. Why did I say keep reading? There was something that got my attention there. So this is will build AI agents, scale AI agents, govern AI agents, and optimizing AI agents. Simulation, observability, complex reasoning, and optimizers. So everything is there in the new Gemini Enterprise Agent platform. This is with respect to the agentic data cloud for empowering system of action. I don't think so. They have given many examples for it or the workshops. Let me try to find out if Cloud on Air with Google.com has any upcoming workshops on this events. So on June 2nd, they have agentic development pattern. Yeah, tomorrow. I think so. Let's register. Add that to my calendar. So this is a kind of a low-code solution for manage agents on an API. If you guys are unaware about this, we had a chat on the TriML generative AI and impact weekly meet that we have, and we discussed in detail about this. Agentic runtime, sessions, memory banks. This streaming and deep research using reconnection to the create and manage agents, sandbox environment, interaction with agents. Yeah, so this is cool. I don't think so. I have gotten through the Gemini agent platform's docs before, but we discussed about that, but not from an implementational point of view, in which we, since this is a low code solution, so we didn't wanted to waste the credits. I am busy with some research work, which I have streamed on YouTube for the past couple of months, so you can find it there. And we'll be analyzing the custom agents and how we can add more here. I think so. This will also result in a couple of sessions. I don't think so. I have had the opportunity to go through the sessions of Gemini Enterprise Agent platform here. This is with respect to optimizing the agent prompt, cloud. This is the deploying agents production ready path. So this was originally with Vertex AI, but I don't think so if it has been updated. Introducing Gemini Enterprise Agents, starting with the gear learning paths. Yeah, so this is good. Starting with Google's agentic ecosystem, developing agents with agent development kit. This is good. We will take a look at it after some time. Let's view some YouTube.
I'm Mike Allen, co-founder of Axios.
This is with respect to the playlist of Google I/O and analysis and learnings that we were doing yesterday. And after the event, like I felt the need to do this more. Like many of the teams that I mentored and judged, they were going through it, going through the basis, and like they were using frameworks and the solutions were good too. So like it was a good learning experience, bonding and having fun. We had fun. I think so. There's some stupid or bad frequencies that are messing with me up yet again, and I've called in the local authorities to triage and fix this. And let's follow up with them after some time.
Thank you to the Google I/O team for making these conversations possible. Demis Hassabis started as a chess savant and a gamer, now co-founder and CEO of Google DeepMind, where he's on the front lines of both the scientific race and the business race for AI. DeepMind's landmark AI breakthroughs include AlphaGo and AlphaFold, which solved the 50-year grand challenge of protein structure. For cracking that code, Demis was awarded the Nobel Prize in Chemistry. The Economist last month put Demis on the cover as a Greek god, complete with tunic, in a pantheon of the titans who are shaping all of our future. He's even been knighted the mind behind DeepMind. Sir Demis Hassabis, welcome to Dialogues.
Hey, Mike. Good to see you.
Thank you so much for doing this.
Thanks for doing it.
So, Demis, yesterday at your keynote, where you got, by the way, big applause and even whoops for announcing that the Gemini for Science, which is one of your favorites, but you left us with the ultimate cliffhanger. You said, when we look back at this time, I think we will realize we were standing in the foothills of the singularity. Take us one layer deeper. What do you think is going to happen? What do you hope is going to happen?
Yeah, I thought people seem to pick up on that line specifically.
Yes,
Yes, so it was kind of expected, but it's great to be able to expand on it a little bit. So I'm talking a lot about, obviously, AGI being on the horizon. I think we are only a few years away now from the full version of that. And the singularity is a kind of good word, I think, to describe the era that is precipitated by a technology like AGI arriving on the scene. And partly it's because it's going to be so transformative, I think the most important invention ever, that it's hard to make many predictions beyond that horizon because it will change so much. So, and I think this year with the agentic systems that we're all seeing and using, I think we can start feeling it now. And that's what I was sort of meaning by that. When we look back, I think in 5-10 years time, I think we'll sort of see as like, oh yes, 2026, 27 is sort of when it was starting.
And I love that. We're starting to feel it.
Yeah.
Expand on that a little bit. How do you feel it?
Well, I think all of you, I mean, I've been feeling it just by using our own coding systems and coding agents and just vibe coding things, even like little game prototypes in my spare 1 or 2 hours in the small hours of the morning, which would have taken 6 months before. And I just think that kind of acceleration is very interesting to see. I think we're seeing it in areas of science, obviously with AlphaFold, which was a few years ago now, but almost every branch of science, AI being applied to. And I'm also seeing the speed at which we're making advances in things like isomorphic labs for drug discovery. So I think taking that all together and using the current, sort of looking at the current progress of the foundation models and the chatbot systems and things like Omni, all of that taken together is just astounding progress, I would say.
Yeah, and based on the markers you set over the years, I feel like we're kind of right on schedule.
Yeah.
You say a few years. What is your latest marker?
Well, I feel like it's, I've been saying recently around 2030, plus or minus a year, I think is a kind of reasonable estimate from what I'm seeing now.
So 2029 to 2031. Mm-hmm. So DeepMind's original mission statement was solve intelligence. How are we doing?
Well, I think we're doing pretty well. So our original statement was, step 1, solve intelligence. Step 2, use it to solve everything else. And I think that was pretty prescient. That's what we felt AGI would be, is a general purpose technology that could help. I was thinking more about science and medicine specifically, and increasing our understanding of how the world works around us. That's always been my passion, as you know. And I think we are on the cusp of that now.
In the lifetime of the builders and searchers in this room and watching us around the world, do you think intelligence will be solved?
Yes, well, I mean, look, solved is it's just a neat term. What does it actually mean? But what I meant by that was building AGI, and I think we're a few years away. So that would be the first step to me.
And you think with AGI, different people talk about it different ways, but I think you're one of the people that thinks that there will be a moment and that we will know.
Well, I know. I think that's not the case. I think it's going to be a gradual improvement. I think that's what we're seeing. Probably a pretty fast improvement. But I have a particular test in mind, which is I call kind of like the Einstein test. So imagine you had a knowledge cutoff of one of these leading frontier models of 1901. Would it be able to come up with his incredible sort of insights and discoveries that he did in 1905, including special relativity? Right? Could a system come up with those insights and breakthroughs? And I think today's systems clearly can't. But I think I don't see why in the future they won't be able to. So that's the sort of creativity or leap of insight that I'm still looking for from these systems for it to be full AGI.
Lots of buzz among tech writers in Press Park right here at Google I/O about Google having its groove back. Brian Chen of the New York Times posted yesterday how Google is starting to win the AI race. If you win, it will be why? What is the Google edge? And what changed?
Look, I think it's sort of weird, this sort of idea of like we're back and then we're winning and then we're not back. And it's all, the thing is that at least the three frontier labs and actually the whole of the frontier, it's the most ferocious competition there's ever been, I would say, in tech history, maybe in corporate history. So there's that going on. Very capable, brilliant people in all the organizations, each trying to push as hard as they can on the research and the breakthroughs. I think we're doing really well for what we need to do, both in terms of the underlying technologies. We have a kind of broader research bench than I think the other labs have. We've always had that. I think that's what gives us our innovative capacity, to invent the next breakthroughs. You see now new models that are coming out, our 3.5 Flash Pro coming soon. We're very happy with the progress that we're making on the underlying models. We also have all our generative media models, Omni being the latest. So that's going well. Where I think things are going extremely well is on the consumer side. So applying, I think that's what the really big leap has been for us in the last year, is streamlining our tech stack, actually almost rewriting it from the ground up to be AI first and now agent first. That's a big change for a incredible engineering organization like Google that serves billions of users every day on multiple product surfaces on our incredible engineering stack. But that has to adapt so that you can ship the model, the goodness of the latest models, directly into all of those products at massive, massive scale. And I think we've got that down really well now, better than any of the other, should we say, big tech companies. And I think you're starting to see that in the progress we're making with the adoption of Gemini app, 900 million monthly users now, incredible growth there that we're seeing, and also things like AI mode in search, an unbelievably popular and incredibly useful, I think, sort of version of AI for information seeking. So I think if you look across our surfaces and what we're doing with our models, especially the small efficient models that are still very powerful, so that's really important for our own internal use cases because we've got to serve billions of users, but it's also very important for some of our big enterprise customers as well. So I think when you take a look at that at aggregate, and then you also can see the advantage we have being full stack, all the way from the chips to the data centers to cloud to frontier lab to billion user products that have AI embedded in them. I think we're the only organization in the world that has that full stack, and we're continually trying to optimize that feedback loop so that they all feed into each other.
Do you think you will win?
Well, I think we're going to be one of the big winners of the era.
Probably?
Well, I don't know. I don't really see it like that in terms of win to what exactly. So I think the AI era is going to be immense. It's going to be an unbelievable amount of new opportunities created, new economic progress made, and we've got to make sure that we're one of the key players in that new post AGI world. And I think we're incredibly well positioned for that. And as to how many players there'll be, my guess is a handful, given how powerful the technology is. But actually, stepping back from that, what I always say is, although we're ferociously, competing in this kind of race, we've actually all the leaders of the frontier labs need to think about, and they are thinking about the bigger picture of the responsibility to the world. As we bring this unbelievable technology into the world, we want it to be for the benefit of everyone and the benefit of humanity. And there's something bigger than all of us and the competition is remembering, we've got to take these final steps in a careful, thoughtful way and make sure that we're building it with safety and security in mind, as well as enabling all of the amazing good use cases that we hope to see.
Demis, picking up on your word opportunity, and the 5,000 students and professional developers here on campus are living proof of that.
Yeah.
And yet a lot of America doesn't see it, feel it. Front page of today's Wall Street Journal, the AI lash building, right? American rebellion. Eric Schmidt getting booed. Why is that happening, and what can you do about it?
Well, I think a lot of the ways that some of the, let's say my peers are talking about this, I don't really agree with. I don't really agree with the style of communication, but also some of the substance too. So what I would say, the way I'm looking at it is, there's going to be no doubt huge amount of change. So something this transformative, I've been on record saying, if you want to try and quantify it, it's going to be 10 times the impact of the Industrial Revolution, maybe 10 times faster. So over a decade instead of a century. And that might be an underestimate. Probably is.
Wait, 10 times the impact and 10 times faster.
Yeah, so you can think of it as 100x the Industrial Revolution, maybe an underestimate. So that's huge. But what I say about that, the future is not written. It's very uncertain. Are there more jobs going to be created? Are there different ones? We don't know. Nobody knows. None of these experts, so-called experts, know. And the future is to be written actually by the next generation. I'm actually very excited when I talk to students and when I go to places like we just came back from earlier this year from the India AI Summit. And the youth of India is so excited about what they can do, what these tools will enable them to do. Build companies, build applications, compete at the global scale. So this technology is actually democratizing opportunities for what you can build. What would have taken a team of 10, 50 experts to build, maybe a smart kid in their garage can build it themselves. So when I think think back to the era I grew up in with computers and home computers, and then there was the internet, and the amount of opportunities that then created for kids of the day, students of the day, who grew up native with that technology to actually go on and build the future that we see today. And I think that will happen again with the next generation that's going to grow up AI native. And I think for the next 10 years at least, and it's hard to see beyond that, they're going to be superpowered as long as they're technically trained enough, and then they bring creativity and sort of taste and judgment, these kinds of skills to the table. I think that's going to be the next era. So I'm actually very optimistic about human ingenuity to find amazing ways to use, and we're seeing that all the time, to use these new tools.
Your hunch would be net more jobs, or you can't even say that?
I think there will be changes to the job market, as always there is with any new revolution. But I don't see why there wouldn't be more opportunities. Maybe it will be more like creating startups. 1 or 2 person startups. More entrepreneurial skills will be needed because you have these incredible creative tools. So there's going to be changes, but I think overall it will be better. And then the other thing I would say on the backlash is that I think it's incumbent on the field, our field, the AI field, and industry to show the unequivocal benefits more clearly and more concretely. And that's what we try to do with our AI for Science work, and applying AI to advancing science and medicine. So that's why I spent my whole career working on using these AI tools for things like AlphaFold, as you mentioned, and drug discovery. And I think there's so many areas of science that AI can be applied to, and we're trying to do that. Material science, mathematics, energy sources. So that's what I think we need to show more of, and I hope our other peer organizations do more of as well.
Now, Demis, taking your point about style of communication, your other fellow Greek gods on the cover of The Economist, you're proudly a scientist. You're not a doomer. Mm-hmm. You're not an accelerationist. Why do some AI leaders talk about the negatives of AI? How does that help them?
Well, I'm in the middle, so I call myself a cautious optimist. Right? So I'm optimistic. Obviously, I'm optimistic. Otherwise, I wouldn't have been doing this for 30 years. That the benefits are going to far outweigh the negatives with something like AI. As long as we take our time, we give ourselves the time as society to get this next few years right. We're talking about the next 100, maybe 1,000 years of human flourishing if we get this right.
And all of us are living.
But there's a lot of challenges to get that right. So we've got to give ourselves the time to do it, rather than just sort of racing to just get the next thing out. And I think that's where we've got to kind of put our attention to and come together to discuss like the bigger impacts that all of this work is going to produce.
We have a treat, a clip from The Thinking Game, a remarkable documentary about Demis and DeepMind filmed over 5 years. We have a fascinating scene from your old offices in London. This was not rehearsed or recreated, totally serendipitous. Cameras just happened to be there. Let's watch.
Now we have a tool that can be used practically by scientists.
These people asking us, I've got this protein involved in malaria or some infectious disease. We don't know the structure. Can we use AlphaFold to solve it?
We can easily predict all known sequences in a month.
All known sequences in a month?
Yeah, easily. Mm-hmm. 1 billion, 2 billion. And they are.
So why don't we just do that? Yeah, we should just do all that.
Well, now you can really.
Why don't we just do that?
Well, so that's one of the options.
Right.
There's this.
That's a great idea. We should just run every protein in existence, and then release that. Why didn't someone suggest this before? Of course, that's what we should do. Why are we thinking about making a service and then people submit their protein? We just fold everything and then give it to everyone in the world. Who knows how many discoveries we made from that?
So a quote for the ages, an iconic moment. We saw the DeepMind working. Demis, when you said, so why don't we do that? So why don't we just do that? Tell us what was in your DeepMind and what was happening.
So look, this is that particular example, and actually I'll just get back to your last question as well about acceleration. This is the type of acceleration that we want, right, in my opinion. So you couldn't get any more accelerations in a sense than what I spent my whole career doing. I think there are so many challenges facing society today, from disease to energy, our environmental ecosystems, climate change. We need technology like AI to come and help us solve these other problems. And the number one, in my opinion, as I said yesterday, is applying AI to improving human health. With AlphaFold, protein folding and predicting protein structures is one of the critical pieces of developing drugs to help with these diseases. Only one piece, but a critical piece. And what was happening there is I just sort of worked out, because AlphaFold was, literally in that meeting, because AlphaFold was so accurate, but it's also so fast. So it could fold a protein in a matter of seconds. And then, I knew there were a couple 100 million proteins known to science, and just a back of envelope calculation, I could feel that if we put a certain amount of computers on it, we could fold all of them in a year. So there was no need to set up the normal way of doing this, which is like a server and have people submit their genetic sequences, the amino acid sequences of the protein they cared about, and then you go away and fold it for a week and give them back the structure. We could just put all of it out there for free into the world on a huge database run by the European Bioinformatics Institute in Cambridge, and just let everybody around the world, all the researchers around the world, access whatever protein they wanted almost at the speed of a Google search. So that to us felt like, it was obvious to me that was the biggest impact we could do with this breakthrough. So I think that's an example of great acceleration. But on the other hand, I'm not in the camp of the Pollyanna camp of like, well, there's no risk here. Let it rip. There's no danger. Of course, when we're bringing in something this momentous, as something like AGI, so a new era we're going into, we have to think that through very carefully. And there are going to be challenges and risks, and there'll be ways which we can try and mitigate that. But again, only if we give ourselves enough time collectively to do that.
The fact that cameras followed you for 5 years, the fact that you're willing to let them in, you recognize that you're on the frontier of something that will shape humanity. It's hard to see ourselves as others see us. What did you learn from the documentary, either the process or actually watching it?
Well, I actually hate seeing myself on camera, so it was a hard thing to agree to. But it's like there's the same film crew that did the AlphaGo movie. If you some of you have seen that for the AlphaGo match, and they came along right at the last minute to do that. And I thought it was a really moving documentary recording of like quite an important moment in AI, sort of modern AI history. The big match we had against Lisa Dodds. We just celebrated the 10-year anniversary of that. It's kind of unbelievable, really. In some ways, it feels like a century has gone by. In other ways, it feels like yesterday. But and then they proposed to basically be a kind of fly on the wall, and we trusted them with that. And they were, they happened to be around at key moments like that one. It was kind of amazing. They happened to be in that meeting because then they come over every now and again and record a few things. And one of the reasons we agreed to do that is we felt that this is a societal level transformation, this technology. We felt that people would want to know something about the people behind it, what their motivations were, why were they doing this, what do we think the good that can come from it. And I hope that documentary shows that. It seems to have gone down well. And I think they've done a good job of portraying what our motivations and passions are, things like AI for science.
Demonstrate a quick tour of your mind and world, simulations and robotics. What's going on, and why are simulations such a key milestone?
I think simulations are really important. I've been sort of enamored with simulations as long as I've had with AI. In fact, the first real professional thing I programmed was Theme Park, this game I wrote in the 90s, which was both had AI in it, and it was a simulation game, one of the first for both. It came out in 1994. And so I've always seen them as quite complementary. So both in the sense that you can use AI to learn simulations about complex phenomena. So for example, our Weather Next system that we showcased yesterday that helps predict the paths of hurricanes and other extreme weather events much more quickly and more accurately than traditional systems. But also it can provide data for AI systems. So for example, we've been using Genie, our kind of interactive 3D model, to test Waymo cars in very unusual 1 in a billion type situations that you would never see in the real world. So for example, what if you're driving down a road and there's a forest fire around you, or a biplane has done an emergency landing on the motorway, or an elephant's appeared in the road. These kind of things, which you're never going to see in your sort of everyday training data, but you want to know how is your system going to react. And so these types of simulations are very useful for testing that. And if your system doesn't do well there, you can use it to generate more data that you can learn from.
Okay, this is going to be your favorite question. I know you love to talk about the scientific method. AI for science and health. And you've talked about human health as the ultimate use case for AI.
Yes, so I think that the AI is the ultimate tool for science in the limit. It's why I started this whole journey, was to try and, as a scientist, understand better the world around us. And I felt that our minds, we could use an incredible tool to help even the smartest experts more quickly navigate all the complexity of the data that we collect and try and find connections and insights and structure in that data. And what better tool than AI to do that? And I think that's coming to fruition now. And it's just a very, very exciting time to see the pace of science pick up in all sorts of fields, many fields where we've been stuck for 30, 40 years. Like we were with protein folding. And I think we're going to see a lot of those breakthroughs over the next decade or so.
AI in the real world. What are some of the ways that people are already feeling it? And it's part of the AI lash that they don't realize it.
Well, I mean, we're using AI all the time in pretty much every product that we use. So everything that from our point of view, Maps to Gmail has now been enhanced and is in the middle of being upgraded with AI. What I hope to see is with the next generation of assistants. So you saw us talk about Gemini Spark yesterday, but also the glasses, the smart glasses, is eventually this will give us back time. That's what I hope. I hope that the smarter our AI assistants are, the less admin we need to do, the less time we actually need to spend with a lot of the technologies that are kind of mundane, and actually give us time back to focus on what we think is important, whether that's creativity, our families, and just connecting with other humans. That's, I think, in the next few years, what I hope will happen. But we can still stay connected and get the information that we need, to do our jobs or that interests us, but more conveniently at the time that we want, because we'll have an AI assistant that's helping us manage all of that.
If you look at all the keynote announcements yesterday here at Google I/O, the keynote put a bow around a lot of it, but it was also a lot, a lot to take in. Ina Fried at Axios had a great headline about AI everywhere. Hit pause, and what's something from these announcements that we should remember, focus on?
I think the main thing is that the agentic era is really here, and I think what we were really excited about this I/O is how we're integrating that across the Google ecosystem. So with Workspace, with all of the things that people use every day and love, how is that going to interact securely with an agentic system? I think we've seen the potential of agents, but I think we're just scratching the surface of what they can do, from coding to all the way to like managing your sort of admin load. I'm very excited about all of those things, and then just obviously the potential of these world models to help in the real world with things like hopefully we'll be talking about this next year, some big advances in areas like robotics.
And responsibility. How do you think about that in your work? Does it inhibit? Does it accelerate? How do you think about it?
I think it's a critical, it's not really about inhibiting or accelerate, it's a critical part of everything we do. When you're working on this kind of technology and, which we've been for a long time, and you're thinking about the implications, both obviously the enormous, amazing benefits that we're hoping for, but that comes with, it's a dual purpose technology. Those things can be also repurposed by bad actors for harmful ends. So those two things weigh heavily on us, or should do, that are at the forefront and the frontier, and understand both the negative and the positive consequences of what this technology can do.
And the last stop on our tour, future vision. Tell us what you know is behind the curtain and what we should be watching for in, let's say, coming months.
Well, the big thing that everyone's working at the moment on is this idea of self-improvement. So, of course, we're seeing a sort of a slow version of that with coding agents helping our own engineers get better and more productive with coding. The question is like, what's the next level of that? And I think coding and mathematics are kind of quite special cases because the outputs are verifiable. You can verify whether they're correct, and you can also generate as much synthetic data as you want, right? So I think there's evidence that this is a kind of compounding flywheel. So I think that's a very interesting space that all the leading labs are investing heavily on. And then I think the other area is just to build the reliability and robustness of these systems and consistency, really, of how these systems work, tool use and instruction following, and make sure that they're reliable over long-term plans. So I think, again, that's going to be the next step change for these things. And part of that is making sure that they're robust and safe and secure. I think the more powerful these agents get, and the more we kind of delegate tasks to them, the more we have to make sure from a sort of cybersecurity standpoint, they're doing exactly what we're expecting them to do, and we can monitor that, and they're being done, securely.
Okay, so that's a good frame way to think about step changes. And you pointed to consistency, right? Like, what would our step change buckets be for, say, 2026?
Well, consistency, we shouldn't be seeing, as we get closer to something like AGI, we shouldn't be seeing systems that are brilliant at certain things when posed in certain ways, but they're still tripped up if you present them with a simpler problem, say in mathematics, but you present it in a certain way that it hasn't, a little bit more out of distribution. And I think that shouldn't be the case for an AGI system, a general intelligence. That's not the case with human intelligence, right? If you're good at one sort of game or one kind of a task, and you give that person a strictly simpler problem in the same sort of domain, they'll be able to solve that problem too, right? But there won't be this kind of jagged intelligence. I think another big area that's missing, and we're focusing on too, is continual learning. How do you have systems that learn after their training, after they've been released out into the wild? How can they adapt and learn further? And that's also related to personalization and making sure that the systems are kind of personalized to the extent that you want as the user to your particular context.
Last one on the future. A year from now, Google I/O 2027, what do you think we'll be talking about? What will be the centerpiece?
I think there'll be a lot more agents in the real world kind of embedded in our workflows. I think we're starting to see that now. I think over the next year that will mature. So I think that will be a huge thing. And I hope also there'll be big advances in AI in the real world. So I'm hoping we'll see some big leaps forward in applying these kinds of models that understand the world, Gemini robotics, the SOTA robotics model out there right now, but applied to many different form factors in robotics.
And AI in the real world, I think something you've talked about as an example, Hurricane Melissa, and how AI can be used in weather forecasting?
Yeah, so that was one of the examples we showed yesterday of an incredible way that we can use AI in simulation. So weather, I think it's a very complicated dynamic system, involves solving a lot of equations in the traditional way, Navier-Stokes equations, fluid dynamics. So these kinds of traditional systems take weeks to run, and they're kind of limited in how far ahead they can look. And for a situation like an extreme weather event, like a hurricane, you want to know, and as we showed in the video yesterday, even a day ahead of time is very important for emergency services and reducing the damage to human lives and also property that these extreme weather events come with. So I think that's just one example of the big strides we're making with applying AI to learn simulations from the available data, rather than directly programming the mechanics of a simulation by hand.
So your advice to your younger self, in an interview that you gave in connection when you were awarded the Nobel Prize, you said, believe in your ideas even though they can seem quite outlandish. And you said you personally had done that. How has AI made that even more true? You said having confidence in your ideas from the very earliest stage makes all the difference.
Well, I think you need to have confidence in your ideas on anything big if you're going to stand a chance of achieving it. That's very clear. But I also think that it's not really just about confidence. It's also your passion and your belief in how important that work is. So when I talk about AI, for example, obviously we're here today where AI is the biggest thing that the world's talking about. And I think that we always imagined, went back when we started DeepMind in 2010 and before then, that could happen. But I would have also been still working on AI now, whether or not that had happened. So if it was still more of a niche, you could say academic subject, because I think it was the most fascinating problem and most important problem to be working on. It's worked out. The timing was right that we thought back then that it was a kind of 20-year mission. We're sort of exactly on schedule. But I would have been doing it anyway. So it's a little bit beyond confidence. It's a sense of like almost obsession with that problem and it being the right problem and the most interesting problem, at least for my mind and the way that my mind works and the passions that I had. That was my expression of trying to advance science, was to build this amazing tool. That was also an interesting scientific artifact artifact in of itself. So what more of an interesting thing could one spend your life and career on? That's how I felt when I was, 30 years ago when I first started on all this.
Yeah, so Demis, how you chose that road, and historians will study this, but Sebastian Mallaby is out with a great book, The Infinity Machine, and he said that you spent 30 plus hours, more than 30 hours with him at a London pub. I will say that you might be the first biography in history to spend 30 hours and not regret it. But this book boils down your choice to, you chose to use your mind, your skills to understand the universe. Tell us that road taken and roads that you didn't take.
Yeah, I should say we weren't drinking in the pub. It was just coffee. So for 30 hours. So no, it went fast because we actually got on really well. And I mean, I actually wasn't counting the hours, but he suggested that. And we had a very fun discussion around, very wide ranging on all sorts of topics. And for me, I started off on this journey because I've always been fascinated by the big questions in science, the nature of reality, nature of consciousness. And I've always been sort of almost puzzled, actually, that when we go through life, and most of us, and we don't really stop to really ponder those big questions, even though they're staring us in the face, like what is time? We don't know what time is. We have some kind of hand-wavy idea about it's a direction of entropy and it's one way. But we don't really know what it is, which is kind of astounding to me, let alone gravity, quantum mechanics, all of these mysteries. And so I've always been fascinated by that since I can remember. And normally when you're fascinated by those questions, you go into physics. So physics was my favorite subject at school. But I started reading biographies of all the greats. My favorites are like Feynman and obviously Einstein, Weinberg, all of these types of brilliant physicists. And what I realized is that, or at least for me, post-war, post-1970s, we hadn't really made much progress, in my opinion. We made a lot of progress at the beginning of the 1900s, like Einstein and Heisenberg and so on. But then towards this latter part of the 20th century, we hadn't made that much progress. And I was kind of wondering why this was. And I felt that it was like maybe we're reaching the limit of what the human mind can comprehend and understand, even the most brilliant minds, like people like Feynman, without the aid of some new tools. So that was my real feeling, that was my kind of takeaway, I suppose, from reading some of those biographies. And then combining that with reading a lot of science fiction, Asimov's Foundation series, Ian Banks' Culture series, and then philosophy books like Gödel, Escher, Bach, which was very formative for me, reading that book. It all kind of came together in that, well, we could try and directly answer some of these questions about what's the nature of intelligence and consciousness by building AI and kind of comparing it to the human mind, the human brain. But also, it would be a tool itself that could be used for science and to advance the frontiers of what we know. So it was sort of obvious to me 30 plus years ago that would be the most interesting and perhaps most valuable path forward.
Inspired by the point you made about biographies, who's a scientist living, working today, who doesn't work for Google, who either should get more attention or you admire or future biographies will be written about?
I mean, there's so many great scientists out there. I don't know what, if you're asking me who's sort of underrated, but I do feel like a lot of the big biology scientists, they're well known, right? They've won Nobel Prizes like Paul Nurse and Jennifer Doudna. These are amazing scientists inventing CRISPR, these kinds of technologies. And I think the next generation, I can't wait to see what they're going to do with the AI tools and make their own way and make their own big breakthroughs with the aid of these amazing tools that we have.
Demis, we're going to finish on a useful note for the builders and future builders in this room watching around the world, and we'll watch this conversation in perpetuity. You spend most of your time in London, but when you come to the Bay Area, you feel a palpable builder energy, which is exciting for all of us. When we visit, a lot of people here are living at creating that, but you also have a warning for all of us. You detect a freneticism.
Yeah, it's amazing energy. When I spend around half my time out here and half in London. It's always great to plug into the energy of the builder and entrepreneur ecosystem out here. Obviously, it's second to none, and it's incredible to see that enthusiasm and that embracing of the opportunities. But I would also say I do also detect, as you say, this kind of frenetic rush as well. And I think that's not conducive to thinking deeply about hard topics for a long amount of time. So I think a lot of the next advances are going to be in deep tech, using AI, maybe applying to another area of hard science. I think there's a lot of opportunities there, and you're going to have to go at that for many, many years before there's a sort of result. So I think having some sort of quieter, reflective moments where you can think very deeply about what you're planning, not just rushing in the next thing that you see. I think a lot of the times speed is favored over the direction. And making sure you have the direction right is often more important than just the speed. Speed is important, velocity is important, but if you're running 100 miles an hour in the wrong direction, that's actually worse than standing still and taking a moment to think about getting the direction right. So I often think there's a bit of an obsession out here with just velocity, and it's critical. So I'm not saying that's not important, but more critical is the direction of that velocity vector.
Very useful. Thank you. So at Axios, we always finish with one fun thing. So I wanted to ask you about longevity, escape velocity. The idea is if you and I can live 5 more years, say we'll live forever. How much stock do you put in that notion, and what are you doing to make sure that you make it?
I don't really worry about that kind of question. I'm very pragmatic when it comes to these things. So what I'm trying to do with isomorphic, and what we try to do with AlphaFold, is use these technologies to cure terrible diseases. That's the number one thing I can think of using AI for. Now, when it comes to aging, I know lots of aging researchers and scientists. There's lots of companies trying to work on this. There's lots of theories about what it is. Is it the culmination of all diseases? Is it a disease itself? Does it need to be reprogrammed? There's a lot of theories out there. I think that we should start with just by solving existing terrible diseases we know about. That will help us live longer and more healthy lives, and then let's see what's remaining. and then we'll take it from there.
And what is your personal health obsession? So sometimes you have a Whoop, right?
Yeah, sometimes, yeah. No, well, try to stay as healthy as possible while we're in the very few spare minutes I don't have. I don't sleep enough. That's one of the main issues that I've got to try and address.
What's your average sleep?
Well, I try to get 6 hours, but sometimes I fail.
Thank you to Google I/O and Demis Hassabis. Thanks for an incredible conversation.
Thanks, Mike. Thank you. Thank you.
So excited to be here. Today's session is on the future of robotics, and we're joined by two absolute geniuses. We have Kiska Rao, who is the head of robotics at Google DeepMind, and Alberto Rodriguez, who's the head of robotics behavior at Boston Dynamics. So to be with you guys.
It's great to be here.
Yeah, welcome to the stage.
Yeah.
I want to start us off by grounding this moment. As a kid, I always grew up loving robots, but it feels like 2026 is a year that a lot of it is actually coming to fruition. Can you kind of bring us up to speed on what's different this year and what breakthroughs have happened recently that has put us on this exponential?
I think we're seeing so many breakthroughs in just like general purpose AI. We've seen just like in the last few days that the rate of progress in just like general AI in the digital world. And I think all these breakthroughs are making their way into the physical world and especially impacting how we do robotics. And if you think about for robots, if they have to be useful to us humans, they must understand our human world. And I think a lot of this understanding is coming from these like large frontier multimodal models. A few years ago, we took these large vision language models and then we adapted them for robotics by adding a third mode, which is like actions. So these are like physical tokens instead of your digital tokens. And it was kind of like mind blowing to see the result of that because all of a sudden you have this vision, language, and action model, and you could like talk to the robot, and you can ask it to do things, and you get all this like understanding for free in robotics. And I remember we put like a bunch of toys in front of the robot, and we asked the robot to pick up the extinct animal, and it like went for a dinosaur and picked up the dinosaur toy, and it was like an aha moment of like, because again the robot had never seen this in the training data. This was just like all kind of understanding coming from these digital AI breakthroughs. So I think robotics is really kind of riding this wave of like general AI intelligence, and I think we are kind of in a revolution in the robotics space as well.
We're also in an interesting moment where you guys are partnering. Can you tell me a little bit, Alberto, about that partnership and what you're working on? Because I think Boston Dynamics is like the robotics company. Like a lot of people have seen your robot videos, whether it be the robot dog 10 years ago. What are you working on now? How has that changed, and what's the partnership look like?
Yeah, I would say that, okay, I'll be honest, like this is one question that I was prompted that we were going to get about the partnership, so I came a little bit prepared. And I was thinking, what problem I'm going to have on stage, and it's clear it's going to be a chair. So I spent reading a little bit of time how kids learn to sit. And you might relate to this. I think you have a 2-year-old.
I have a 2-year-old, yeah.
Yeah. So I was reading that there's clearly 2 stages in how kids learn to sit down. There's a first stage, which happens around 6 to 9 months old, when they learn the concept of balance, right? Like they sit on places and they know how to stay balanced upright with their head standing up. They learn the concept of how to stand up without falling forward or falling back, or without moving the chair back, for example. And then there's a second stage that happens when they are closer to 1.5-year-old, when they learn the notion of what's a chair, what's a place where you can sit, the affordance of sitting, right? And actually, it's funny, like there's a period of time where kids might just spend a few weeks just sitting on weird places, like on their toys or on a jacket on the floor, just to understand what it means to sit and what actually makes sense to sit. The idea that sitting has directionality, right? Like when you're sitting down, you're going to be facing a certain direction and no backwards. So if the chair were to be backwards, I should probably turn the chair so that I'm facing at you. And those 2 ideas relate to the 2 main ways in which we are building sort of generalization in robotics, right? There's physical intelligence, the idea that the robots we're building, they need to understand what it means to exert forces on the world, how to use their body to exert those forces. And then there's this idea of reasoning or common sense generalization. And like that they have to be able to interact with anything in the world, even if they haven't seen it before. That you can also see it right there on the ledge or on the table, and it's fine as long as you know how to balance. So there's 2 things that are interesting. One is that you cannot learn the second thing without first learning the first one. And like psychologists have like captured this like widely. But also the second thing is that we are building our robots with exactly the same model. We're building like 2 different sort of brains that are compatible with each other. And I would say that one of the cool things about this partnership is that we have sort of in combination a team that not just can provide like an excellent hardware, but also has the ability to bring those 2 things together. And it's kind of like the A team to build sort of a generalist robot for physical labor.
And historically, you guys are working on a lot of different form factors for robotics, but we're specifically talking about Atlas today. Can you tell me about why a humanoid robot makes sense? Like, I feel like there are so many different morphologies you could do for robots. How do you pick which one to use? I feel like we're moving from a world of like very specialized robotics, like robots in factories, like just an arm, to these more like generalist robots.
Mm-hmm. Yeah, I mean, we actually just released sort of the new generation of our Atlas robot, our humanoid robot at Boston Dynamics, which I believe in a second we'll be able to see a clip. But before just getting into your question, why humanoid, right? Why humanoids make sense? And I think that on one hand, maybe Kanisha can extend on this, like the promise of scaling up data collection as a means to create generalization and sort of common sense works best when you can learn from humans. That's sort of the seamless path to scale up data generation that feed these models. But also from a hardware perspective, the humanoid form factor, it turns out it also makes sense, right? Like having two arms is way, way better than just having one arm because you can balance loads more efficiently, because you can sort of reposition objects in a way that would be hard to do with just one arm. Having two legs, it turns out that allows you to get to almost any place that humans can go, not just because you can step up things, but you can also change your form factor, right? Like you can become thin in the right direction, but you can become strong to resist forces in the direction that you want. And being able to change that location of your feet also allows you to change the friction with the ground in a way that allows you to accelerate faster or decelerate faster more efficiently than you had wheels. So it just kind of makes sense.
Yeah, I think robotics, we talk about physical AGI, and I think we define AGI in terms of like what us humans can do. So I think for physical AGI, I expect that the robot can do anything I can do, or an average human can do. So I think that just for that reason alone, like working or at least doing research on the humanoid is justified, because ultimately that will be the test of can the AGI do all the things, and the humanoid form factors is the best place to express that.
Makes sense. Let's look at the video.
Yeah, let's look at the video.
This is the new generation of Atlas.
Yes, this is the new generation of Atlas, and here you see doing it a very physical task, lifting a fridge and carrying it to one of our developers. Just very cool, sitting there. He just asked to bring a soda. I guess why we need a reasoning model to understand the difference between a soda and the fridge. But a couple of things that are very important about this robot and why it's very important for us and for the partnership. This robot, while it maintains sort of the physicality and agility that characterizes Boston Dynamics robots, it's been designed especially for mass manufacturing. So it has the simplicity in its design that is necessary to deliver on the reliability that we need to be able to do data collection at scale and deployments at scale. So we're like super happy that we've been able to combine those two things in the same piece of hardware.
We talk about data collection and kind of how we train robots, because it seems like when I think about this AI moment that we're in, the breakthrough of the transformer has led to an exponentially huge amount of new information and better AI models, and it feels like with robotics, we've also experienced similar breakthroughs where historically we were training them by just like brute force having them do the activity over and over and over again, and now there's this whole new level of training with training and simulation, but there's also still like teleoperation. Can you kind of break down for me the different ways we train robots and models?
Yeah, so in robotics right now, there's like maybe roughly like 2 ways to train robots, and things that you can simulate are easy to learn in simulation. So for example, the robot body itself, since you build the hardware, Boston Dynamics has built the hardware, you can build very good simulators for it, and Boston Dynamics, they're the state-of-the-art at doing this. So if you can simulate the task, I think you can then train it. You have the same verifiable rewards loop, and you can like do RL, and you can train some really nice policies in simulation, and then you can transfer them to the real world, and that works well. So
that's how the fridge
behavior works. So I think a lot of like the walking, the running, the whole body, the dancing, all of this is powered through like really good simulation, and then setting up this RL loop in simulation. Then this other bucket of learning, which is maybe the harder bucket of learning, and this will take longer maybe. This is the kind of dexterity bucket where you cannot simulate the task because you want the robot to interact with all the objects in the world, and there's so many like different things and objects and the ways you manipulate them in the world. It's hard to simulate all of that. So on the manipulation side, what has really led to a lot of the latest advancements has been leveraging these large foundation models and then kind of weaving in real world data with them. So I talked about VLAs a while ago. Essentially, what you try to do is you try to train the robot on real world data, and you have these physical tokens collected through teleoperation, and you kind of interleave them with like vision and language tokens, and that is a way to kind of generalize the dexterity a bit more. But yeah, that bucket is mostly relying on real world data collect.
And what is teleoperation? Like, how does it actually work? What is teleoperation?
Teleoperation is essentially, so the way the robots learn about the physical world is just like we do. It's through your own embodied experience. It's not showing a video to a robot and then it kind of learns that. Maybe in a year or so we'll be there. But at least for today, it's really important to understand how the robot moves. The robot needs to understand, hey, if I poke my finger right now, like what will the world do? So teleoperation is how when we collect data, we control the robot to move in the world and to do the task. And that way it builds this like physics knowledge by interaction. So it's a human controlling a robot and then the robot doing the task. And through this teleoperation data, it kind of learns physics and the task. And that's been the state-of-the-art way of doing manipulation today.
And I would say that the tighter the embodiment of the pilot that is still operating the robot, the better the data that it can generate, right? Like in practice, what happens is that we usually put pilots in VR headsets so that they can actually see through the eyes of the robot, so that they don't get to use information that the robot would not have when it would try to do the exact same task. So that this notion of what the robot will be able to observe is like ideally replicated one-to-one with what the pilots or demonstrators are generating.
What are the phases of this? Like, do we need more different types of training data to really get robots in the real world, or is like visual training data enough and we just need a lot more of it?
I think we can still do more with teleoperation, just because I think we haven't really found like we've seen a lot of generality, but we still haven't found like that basic recipe of like, if you think about like vision, language, action models, there's way more vision and language tokens than action tokens.
Okay.
So I think the strategy for robotics right now is how do you leverage the intelligence in these bigger things to then accelerate robotics. So just last year we announced our Gemini robotics model, and there one of the breakthroughs that we showed was we can kind of introduce thinking in the physical world. So the idea there is typically in the digital world, when you think, it's mostly about like what code you're going to write or what text you're going to output. With this model, we had thinking about your physical actions. So it would be like if you're trying to grab like something, it would be something like, should I close my hand right now? Will it pick up the object, or should I move further and then close my hand? So by interleaving this thinking with physical action tokens, we're trying to make the actions a bit more general. So we're getting more kind of bang for a buck in terms of like the data. And I think we have a video of this in like a laundry sorting video. Maybe you can take a look at that.
Yeah, let's do it.
Now with thinking, we're able to ask the robot to like chain a whole series of tasks together, and it's completely end-to-end. The thoughts and the actions are interleaved. I can see it running in person, which is really cool. Let's see what it does with the white cloth here. It's still trying to go for, okay, so here it's seeing it said adjust the black bin a little bit so I can pick up the cloth. This is really cool. We didn't really train it to do this explicit thing. So these kind of thoughts just like emerges during inference, which is really cool to see. And it's super reactive. I can now switch this up on it, sorry, Apollo, and it knows that I have done that and it will react. I think this is what we mean by generalization for robotics, because you can train a robot to be pretty instinctive and do repetitive things, but what makes us humans so good at all of this is when faced with a new situation, we can kind of think our way through and solve that new thing. So this was an example where this setup was not in the training data, but it could like think its way out of the problem. Yeah.
Yeah, like I see a video like that, I'm like, this is extraordinary. Like the robot's like in real time, it feels like a huge breakthrough. Which leads me to this bigger question. I feel like a lot of people in the room have probably experienced seeing like hundreds of robots dancing in sync on Twitter, but then a video like that or a video of a robot picking up a banana is actually like the more impressive one. How can people understand the videos online of robots and like what's a genuine breakthrough versus like what's been like pre-programmed and it's impressive but like less impressive?
Yeah, so I think as you said earlier, I think the manipulation part of the problem is probably going to be, I think the final chapter in robotics is like, that's the most difficult part. And sometimes I work.
It's probably the only chapter, right? Like getting robots to dance is, it only gets you this far. But
exactly. So yeah, I feel like
not many people are going to pay for that.
Yeah, we work with this stuff every day, but it's hard to express to everybody how difficult like dexterity is. We have these amazing hands that we use all the time, and we take it for granted. But it is really hard. Like if you look at the state of AI today, we can code up operating systems in like 24 hours, and we can solve complicated math, but we can't scramble eggs. Like
why is that hard?
Yeah, it is because this physical intelligence it feels slightly different than the digital intelligence. Like again, I have a 2-year-old at home, and he can walk and run and climb. He's even can do some speech recognition and talking and language understanding, but he still struggles with dexterity. Like I don't think he can open up this can of water or like zippers. So there's something different about physical intelligence, and I think our researcher of robotics will tell us about ourselves too. Like how do we learn this stuff and why is it different? But yeah, the one thing I would say is like the dexterity stuff, as Albert also said, is like the more difficult part of robotics versus like the dancing and the walking and the running, just because we still haven't cracked that problem fully yet.
Yeah, I would say that like even just from a technology perspective of what's available to us today, like there's two, as you were explaining, there's two techniques that we mostly use to engineer behaviors or to get generality to emerge, which is one, learning from demonstration, and two, learning from trial and error, mostly in simulation, because that's the only place where we can sort of do the very expensive search of trial and error. And doing something like just grabbing this bottle and opening this cap is something that it is, one, very difficult to demonstrate. If you imagine putting yourself in the mindset of a pilot that is piloting the robot, being able to do this without feeling the forces that you are feeling as you're trying to screw or unscrew the cup is just very difficult. But it's also very difficult to simulate realistically the compression that happens in the skin and the sensing that happens in the sensors in the fingertips in my hand to understand what's the behavior that is going to drive this. So we have ideas for how to solve those problems reliably, but we still don't have sort of the one key technique that is going to enable the kind of dexterity that we want at the reliability level that is necessary for like industrial scale deployments that actually have value.
Well, we have to create like almost like a haptic model where it's like giving, like I think right now most of our breakthroughs have been the robots like just seeing things through cameras. How do we make them like feel things? Like is there a new type of model that comes out?
So so I think the tactile puzzle it's a real puzzle, and I think today all the state-of-the-art models that we are showing, at least for manipulation, they are vision-based, which is again is a bit weird because if you think about all the manipulation that you're doing today in your daily lives, you're probably using your like sense of touch and haptics way more than vision. So it's a bit of a conundrum, but maybe there's a few reasons for why vision is like state-of-the-art today. I think one is again we're building these models on top of frontier models, and there's way more vision data on the internet than any tactile data. So I think just like the size of the data set. I think the other thing is we do use these like wrist cameras. So for robotics, you might see sometimes a camera on the wrist or the end effector, and that gives you like a close-up view of like the actual contact points. So maybe instead of actually feeling these things, if like in the pixels you can capture the compression as we're talking about, maybe that's a substitute for tactile in the meantime, and that's kind of how it's working. So there's some like unreasonable effectiveness of this vision stuff. And I think we have a clip of maybe we can show this now of like a dexterity task that we
did. Like origami, right?
Yeah. So we're using the robot to like fold origami, and this model is completely vision-based. There's no sense of touch or force or any of that. And it's if you think about it, this task should have not been possible just by vision, but it is able to learn this quite effectively. And again, it's like looking at the creases, the folds, and it's probably inferring the forces and the sense of touch from this. So it's kind of neat that this is working with just vision. But I do feel that ultimately, I think hardware will get better. Yep. I think one thing is like cameras are like so ubiquitous. Skin is hard to hardware. Yep. So I think those maybe hardware developments will like also lead to some of this research. But as of today, vision is like what's helping us get through this.
Yeah, maybe just an anecdote of like how important tactile is, right? So part of the process of scaling data collection at a very, very large scale is equipping people with wearables, like putting like a camera on your forehead and just asking people to just go by their lives, just doing as if they were doing normal life, and then using that as a means for pre-training the very large-scale models that sort of reason about behavior. But it turns out that if you do that, the way that people move through their lives is like this. They're doing something here, and while they're thinking about what's the next thing they're going to do, they do it here, and then they move. So actually the cameras, their eyes are not looking at what they do with their hands. turns out that most of what people do is driven by tactile feedback and proprioception, and they don't need to look at it other than just for a fraction of a second to understand what to do and then how to lock in the hands and then just let the hands do their magic. So my hypothesis, my bet is that we're not there yet because we're limited by hardware reliability when it comes to tactile sensing and cutaneous sensing. But the moment we get there, and I'm pretty sure we'll get there because there's like tons of interest today, we are probably going to see a gradual transition to relying less for control loops or for high-frequency control loops on visual sensing and using it more for like common sense understanding and using more tactile sensations for driving manipulation.
Yeah, I saw a really interesting study where this doctor numbed patients' hands and then watched how well they were able to do different tasks. And it was pretty atrocious. Like, people were not able to do much. So it's amazing to me that the robot was able to learn any level of origami. I'm curious, when we think about like the different stages of robots, it seems like we have a lot of robots in factories right now, and then maybe like the second level is like front of house, and then the third level is like homes. What's the roadmap look like? Like, when do you think people in this room will have like a robot in their life, and what breakthroughs are kind of on our journey to get there?
So yeah, it definitely will be a while. It's not next year. So yeah, sorry.
What? Things you hate to hear?
So yeah, I think maybe like the next 5 to 10 years we'll start seeing.
Good.
Yeah, I think again like the main. If there's one takeaway of this, I would say is like dexterity is hard and it's still an unsolved problem. So I think that's like one of the main challenges that we still have to solve. I think even generality is not fully solved. Like maybe we can learn to open like this bottle. But the robot still struggles to open like any bottle. Like this, when humans learn a skill of like unscrewing something, we can start unscrewing like almost anything. Like so we can reapply these like verbs to like most things. But robots kind of like are still a bit narrow-minded. They can learn a verb with like a few objects, and then maybe it'll generalize to a few more, but they don't like universally learn that skill. So I think generality is still like a big bottleneck, and then dexterity is like probably the big one that we still have to solve. And I think as Alberto said, like maybe we still are waiting for some hardware breakthroughs. Like a simple task, like again like for dexterity is like picking out keys out of your pocket or like a purse. Like that's like so difficult for a robot to do. Like we won't even attempt that today, but it's something we just naturally do every day. So I think there's still ways to go where hardware has to like meet us there for like tactile sensations. So there's still like work to be done.
What are robots really good at today? Like if we were to like create like a list of like what they're already excelling at and exceptional, what would it be?
So I think again like we have seen they're very good at whole body control. So even like a few years ago, like humanoids would not be a thing because balancing was so hard. But again, like with really good simulation and state-of-the-art breakthroughs in reinforcement learning, kind of balancing is solved, I would say. I don't know if that's a hot take anymore, but balancing is solved. So like humanoids are more
problem.
Okay, you agree? Okay. So humanoids are more possible now. We can see them walking around, and I think like basic manipulation of like picking up something and placing them somewhere else, they're quite good at imitation learning. Plus this human collected data is working well. So I think basic pick and place and walking, and obviously like the dancing and all of this. Today, they're very good at.
Yeah, if you look at industrial tasks, for example, in manufacturing. The leading skills that are necessary to make an impact are things that are actually very complex, right? So it's like handling cables, right? So you want to be able to handle something that is very deformable and put it somewhere routed through hooks. It's using power tools, right? So you want to be able to grab a bolt driver, like feel the strength of a good grasp, which is something that actually takes many years for people to know, right? Or just imagine a screwdriver. How long does it take for someone to actually feel what it feels to hold a screwdriver like in a way that you will feel confident to actually use it? Some people never actually learn how to do that. So using power tools. And then the third one is bin picking, right? So there's a bin full of objects and you want to fish one, not two, not three, or not zero, but just one. Even the ones that get stuck in the corner of the bin. Those are like very hard things to do still today. But I think that we are on a great trajectory from sort of trying to squeeze and continue to invest in this bet that learning from demonstration, just like we've seen with large language models, has like a very long route to saturate performance. I'm convinced that performance will saturate just from demonstration. At some point, robots are going to have to continue to improve performance from trial and error. They're going to have to get there, make mistakes, recognize, feel what it feels to fail at something, and learn from that. Just like RL is sort of like extremely impactful in bringing large language models to high performance. The same thing is going to happen in robotics.
Is there a robotic equivalent to like muscle memory, like how a human that's like played piano 1,000 times is able to play and not really think about it? Like, are there tasks that the robot just gets so good at that it kind of runs at a lower level?
So I would say most robot models today are in the regime of muscle memory because again they see there's no thinking involved except for the latest models that we're working on. So I think they're kind of moving away from the muscle memory reactive mode to more like thinking a bit more about what they're doing in like the more thinking intelligent mode. However, it's reactive, but it's still like a large vision model that's controlling it. So in that sense, it's not tactile based, but it's kind of a vision based reactive model that it just sees an image and it kind of like makes a move and it doesn't really think about why it's taking it. Like if you ask even the state-of-the-art robotics model today, hey, why did you take that action? They don't even answer. So they don't. Yeah, so it's more like a reactive thing, but the actions are just like uploaded, but they can't explain to you why they did that.
How does the new model change that?
So the new models, basically what we did is we kind of interleaved thinking tokens and then action tokens. So before outputs an action, we basically explicitly added some tokens about like what it was doing, and this thinking could influence why it was taking the actions. So it still doesn't explain why it took the action, but you can see the thought trace that led to that action.
Okay.
And if you tweak the thought process, you actually get different actions. So you can kind of influence the action this way. So again, it's a little bit trying to connect the intelligence of like motion and physicality to like the digital intelligence, but it's still not fully there yet where, you talk to the robot, hey, why did you do that?
Can you give me an example of like when you would tweak but then lead to a different action?
It's just simple things like, it's like let's say you're trying to grab something and its thought process is that, it might say, hey, I'm close enough to close my hand and I will grab the water bottle. And if that's its thinking trace, it will just close its hand. But what the experiments we do is we edit the thinking trace and say, I'm not close enough, I need to go lower. And if that's the thought it's conditioned on, then the action would be to go lower. So you kind of like, it makes the models more interpretable and also kind of steerable because you can look at the thoughts and understanding why is it taking that action.
And is it that would replace, like the VLAs that replace the other types of models, or do they all kind of come together?
So I think this model I talked about was still like a VLA style model where it's like based on top of a vision language model. I think the one interesting thing is, again, I'm talking about how robotics is going to be affected by like these big breakthroughs in like large frontier model. I think the one thing I'm really excited about is we saw, on these Omni models, video models. And again, like we're talking about physical intelligence, which is intelligence about like motion and like physics and gravity and like friction and all these things. And these are not really captured in language or even an image. But these models, the video models, these word models, they are able to upload videos that look pretty realistic, right? And I played around with them. I tried to ask them to create videos of like texturous, manipulation, and they look pretty good. So they do seem to, again, they're talking about how they understand some basic physics. I do think that they have some understanding of physics through video prediction, and we'll really see how, again, robotics can leverage some of this like physics and motion intelligence, and then build kind of robot models of that.
At Boston Dynamics, what are you personally spending your most time on right now?
Sorry,
At Boston Dynamics, what are you personally spending the most amount of time on right now?
The most interesting thing we're working on right now?
What are you like spending the most amount of time on?
Oh, the most amount of time. Yeah. So for us, we design robots not because we like designing robots, but because we know that there's certain sort of physicality that is possible to generate the motion, and we want to bring that to products for our customers. And one of the things that we're most interested in is sort of understanding what the right kind of balance of models to be able to our robots develop a sense of general physical understanding of interacting with the world. Right, there's some sense of frequency analysis, so to speak, in how a robot has to make decisions. That tells us already that there's certain things that have to be decided like once per second. Like when you decide, oh, this is a thing that I want to interact with, and it's not that thing, and I should reach out, with a certain sort of direction or with a certain sort of free shape of the hand. But then there's certain decisions that have to be done way, way, way faster, because when the hand is accommodating to the bottle, it's a control loop that the robot has to make decisions 50 times a second or 100 times a second. The same thing happens with balance, right? When the robot is trying to carry the fridge, and it needs to react to the fridge sort of like side balancing. And sort of the fact that there's these like differences in frequency in which the robot has to make decisions already tell us that we need sort of an architecture that it is tailored to that sort of decision making. So we're very interested in understanding what is the right structure to drive a system that has general physical understanding, and what's the right way to populate it with intelligence, right? Is it just demonstration, or is it trial and error, or a combination of those two things?
So on my show, I make optimistic tech videos, like what the future will look like if things go well. And I think you guys are two of the driving forces that making that future amazing. I want to hear from both of you. Take me to your head. What is your vision for, like, what are you trying to get us to? Like, if everything is right, what does the world look like in 10 years from now?
Great question. Yeah, so I think how many millions of minutes are we going to have? Yeah, I think if everything goes well and we saw like, actually, I think there's still like a huge like safety research puzzle as well. I think robots are not going to use unless they can be really safe. I think that's another big roadblock. I think in that sense, robotics is kind of like autonomous driving too. Like we have to really solve that part too. We can't be like a side part. So we're developing, all our safety AIs along with this. But I think in 10 years, okay, if we are successful, I do think like a lot of kind of basic general day-to-day stuff, we can have robots do, and I think we'll see robots more kind of amongst us, helping us. So on a personal note, I hate to do like daily chores. I know it's very personal problem, but I think a lot of those kinds of things, the boring, the dull, the repetitive, the dangerous tasks, robots will be physically doing. And I think generally the goal is like benefit humanity, and I think physical intelligence can enable all these form factors like help us in that. So that's the dream. In the 10 years that we'll be there.
Yeah. What about you?
Yeah, I would say similar. Like the thing that drives us is to make like arduous physical labor, the kind of that is like backbreaking and very tedious an option, right? And we're doing it with our existing products. Like Stretch is a robot that unloads boxes from trucks, and these boxes are like 50 to 60 pounds, and these trucks, they're not controlled for temperature, so sometimes they can be at 100 Fahrenheit, right? And the robot does it, and it doesn't complain. And port spot is another example, right, where you will deploy to patrol and do inspections in your factory every day at the exact same time of the day, and do inspections on the same 100 places in your factory, 1,000 inspection points, and it has to do that every single day, and most of those days, maybe 499 times in a row, nothing will happen, extremely tedious. But then all of a sudden, the 500th time, something feels off, right, in one of the pieces of machinery in your factory. And having to keep the attention span and having to keep the interest in sort of understanding that just something went wrong is very, very tedious. And using robots to do those kinds of jobs, it kind of makes sense. And we want Atlas, we're targeting Atlas as a machine that is capable of giving Argus labor, right? That's why it has the kind of payload that it has.
So you're more focused on like the industrial side of robotics instead?
At the time, currently, yes. Clearly, we've sort of seen that industry, especially manufacturing, is a good entry point, at least for us. It gives us a window into a market that has the right cost for where humanoids are today, and it gives us a window where there are ways to like mitigate safety concerns in ways that would be very difficult to do, for example.
Yeah.
And so it gives us a roadmap to eventually go to other markets that, like home, for example, that would also be interesting.
Okay, thank you so much. Thank you for watching. Welcome, my name is Mira Lane, and this is, I would say, one of the most exciting times to be a filmmaker. The tools are changing, the possibilities are expanding, and these three amazing people are at the center of it. As you just heard, Doug Lyman has redefined action genre through movies like The Bourne Identity, Mr. and Mrs. Smith, The Edge of Tomorrow, and three of them are co-founders. Julina and Jed are also co-founders of 30 Ninjas, a new AI filmmaking studio and a new way to work on interactive content. So I thought we could start by talking with you, Doug. First of all, maybe take us into your mind a little bit and talk about the way you think about emerging tech and what got you excited about AI to begin with.
But in terms of getting excited about AI, I think art has always reflected the technology of the time, and this is definitely the technology of the time. So as a filmmaker and artist, I don't know if you think of myself as an artist because I make commercial Hollywood movies, but still, in terms of artists embracing AI, technology at the time, and really my career was, I started with swingers, and you would think of technology, many of you have seen swingers, but the reality is back then films were shot on film, and Kodak had come out with a new high-speed film stock. And I was able to use that to make swingers on a shoestring budget that would not have been possible 2 years before. And so from the beginning of my career, technology has empowered me to tell stories. And anytime there's been an opportunity to look at a new piece of technology, I've jumped in because I got rewarded in different ways. I've been rewarded we're in the Guinness Book of World Records. Not for anything athletic, fortunately, but for the first VR series. And then a couple of years ago, I went to one of these Google dinners where they were like thinking about doing something with AI, and I jumped right in. I was like, actually, I've got a script, movie script, maybe 2.5 years ago. And Google was like, wait a second. Like, we were thinking like maybe like a little short film, or but I've for better or worse, I've been willing to sort of jump into journeys I don't know how they'll end. I used to guide whitewater rafting trips. Leah's been on them where like they don't always end so well. But the one thing for sure is they don't necessarily know what's coming up around the bend. But like one way they'll try to navigate us through it as best we can. But sometimes we get to the other end and not what's in the boat. And it's so I right now 30 Ninjas has empowered me to make the first fully AI studio film with Casey Affleck, Gal Gadot, Pete Davidson.
Amazing.
And then a cast of about 100 other actors. And it's my kind of brand of movie is like big movies, big ideas. Like Edge of Tomorrow is very big ideas, time travel, aliens. But the biggest thing in that movie is Tom Cruise and his character. And it's for a big one, film with AI, it's like it's a giant world that's set up with cryptocurrency. But the biggest thing in the movie is Casey Affleck's character, Pete Davidson's character, Gal Gadot's character. And I think when I was making Bourne Identity. It came from making Swingers and another indie movie, and then suddenly I'm making this big Hollywood action movie, and then it was very rough go. It didn't look like what the studio was expecting a movie to look like, and because I was bringing some of this new technology and I used in Swingers, in which the studio was saying Bourne Identity looks like shit. Like that really, was said to me at the time. They're like, it didn't look like what they expected, a spy movie to look like. And at some point, Stacey Snider was running Universal and starting to yell at me that Bourne Identity was not my $50 million film score. And the fact that I'm sitting here on stage, like admitting to that now. I've completed and not with therapy, by the way, a journey where I'm willing to look back and I go, what was my film school? Of course I didn't know how to make Bourne Identity when I started. I made Swingers. I figured it out as I went along. And I think more than a therapist helping me get to that place was an Edge of Tomorrow. We're having some script issues because if you try to do anything with time travel, you'll immediately discover, you'll come to the realization that humans are never going to travel through time because it's almost impossible to even write a script with time travel in it. There's so many paradoxes. And we were having a meeting, we were really struggling. Emily Blunt made a suggestion, and I snapped a little bit. I was like, that's never going to work. It's really like a looming start date, a lot of pressure. And Emily was like, whoa, easy. Like, I've never made a movie like this before. I come up like Devil Wears Prada ship in an action movie. And I was like, well, I've never made a movie like this before either. And my producer, who's in my office, was like, oh my God, you can never say that out loud again. Warner Brothers is giving us $150 million to make this movie. You cannot say out loud you don't know what you're doing. And Tom Cruise said, I love that Doug doesn't know what he's doing. Like, I want to be on a journey with him as he figures out how to make this movie. And I think, not there, but Tom Cruise saying that to me, maybe look back on Born Identity and go, yeah, like, I'm willing, to stand up in front of you guys or on the set and be like, I don't know how to do this, but God knows I'm gonna try. Because I'm gonna have to face an audience when it's all done. And so that's probably why I'm like probably a pretty good person to venture out and make a film with AI, entirely AI, when, not that long ago, we were anticipating post-production is gonna take 40 years, 40. And I was like, but I know we're gonna figure it out. And we did, and we cut it down to 6 months. But when we embarked on the journey, it was like, this may be at my age, like, it may be like the church in Barcelona, like, the person who designed it doesn't get to do that when it's done, the Catholic Church. But I was like counting on Google and the other people in this world to sort of, accelerate the curve. And so I showed 10 minutes of the movie last week at Cannes, and it's extraordinary.
And we'll get a little bit of a behind the scenes look at it in a moment, actually. Well, maybe you could talk a little bit about 30 Ninjas, the company you guys have started, and maybe Jed and Davina, tell us about the company and the types of projects you guys are working on.
Sure. Yeah. Well, thanks. First of all, thanks for having us at Google I/O. I know this is a developer conference, and we have a very strong roots in a large part of our team. We're software engineers. Like, who in the audience comes from software development, creative technology, engineering? And also the rest of the people working a little more film and entertainment. Like 30 Ninjas was founded really to use new technology to empower and supercharge storytelling. And that's meant like many things over the years, going back to interactive cinema. We did the first ever long-form virtual reality series in 2015 called Invisible with Google Cardboard and Samsung at the time. We're actually in the Guinness Book of World Records for the first ever long-form VR series, which is cool. We've done a lot of interactive media. We can partner with large brands like Google when they're coming up with something new and exciting to be their storytelling partner. And we started going down the script with the team at Google about 2.5 years ago, first around the launch of Android XR. 30 Ninjas is sort of, right now our studio has two different arms that will eventually become one. One is an interactive story extension and character extension company. We work with XR. We have an upcoming Google Glasses project we haven't really talked about yet, which is really exciting. We work with XR headsets. We work on mobile platforms, really to take and create, and Julina talked a lot, I'm sure, AI-driven characters who are tied to linear properties. So like very much the belief that like as audiences, we're always going to sit around together and watch, listen to stories told by visionary creators that are linear. And in addition to that, technology and current audiences are really technology working on that with the characters they love, the worlds they love, the stories they love. So we use generative AI to sort of supercharge an audience connection with the character, a story in a world where they can talk to them or have an adventure with them. That's great. And then the other part of the studio is our there's a film studio and our AI film studio, and that's where as we work with the XR team, they sort of took us behind the doors and like, hey, take a look at what VO is, what comes out, and we've been working with both our own engineers and the DeepMind team to sort of refine how we work. We do what we do really well, which is work with top tier, sometimes Hollywood, sometimes sports, sometimes music creators, and endemic digital creators to tell their stories using AI. And lately, that has meant a very artist-first, human-first approach to AI storytelling video. You want to talk a little bit about a little bit of Asteroid, a little bit about characters?
Maybe you want to skip Asteroid, and then we can watch that clip. Talk about. Okay, sorry. You want to skip Asteroid? Oh, for Tia. Yeah. So Asteroid is one of the projects that Jen mentioned. We created for the Galaxy XR headset. It's a film. It's a story, space story that was Doug directed. One of these stereoscopic, but after the film, you discover that someone. Well, I don't want to spoil maybe the trailer. But after the film, you discover that one of the characters is still alive, and you assume a role, and you then try to rescue the character. You engage with the character who is written with generative AI, Gemini Live, actually. API.
DK Metcalf, football player, is one of the characters in the rocket ship of the film, and he is and he's playing himself, a version of himself, a football player who's like manager said, hey, this would be a good thing, you want to go up in this rocket, and it turns out to be anything but a good thing. And by the end of it, it doesn't end well for most of the characters on the asteroid. He ends up stranded and left behind. And originally he was left for dead, and then Google, approached 30 Ninjas about like, could we extend the story using agentic characters, right?
Yeah. So the idea was how do we incorporate that into the plot so that basically the viewer can become the player and participate in the story and assume a role in order to rescue DK.
They have to do like a sequel. They're like, could we do something where the story could continue if you like, you can imagine this being applied to movies and other things. You like the character, you like the world, and now you can interact with it, and it's been trained. So you interact with DK. It's not just DK Metcalf football player. He's DK Metcalf the character in our show. So he can talk about football because he isn't playing himself, but he also is DK stuck on an asteroid trying to get rescued. And I've always, Born Identity that works fully, right? It's like you're in the park with Jason Bourne. It's why I jumped at the VR series. And first you had to wear like this cardboard thing on your head to watch, and then when the Android XR headset was going to be coming out, it's the opportunity to make it as a film for like a really proper piece of equipment. I jumped at that to really put you in the rocket ship and try like whatever they're going to show you here, I dread, because it's not meant to be seen on a flat screen. It's meant to be experienced. You are there. You're in the rocket ship, and you're Haley Steinfeld plays the lead. Perlman's in it. You're really on the journey with it. But and that's what Jet talks about. Sort of 30 Ninjas having these two sides. There is, Julia's been doing interactive storytelling, branching narrative since it was first possible. When and trying to figure out lag, if you're going to make a choice, how can it go seamlessly where we are today? So and 30 Ninjas is very much a story-driven company, and how do we use technology and to further storytelling? And one thing is like, and I really obviously seen more. I want to get you really invested. You're there with Tom Cruise on the beach. There's more. I want you to really be there. The ability to control some of the story, some of it, because there's a role for the filmmaker. Like we need to build a world, build the characters. I don't think it's not just explore the world if anything happens, but the ability to sort of maybe incorporate the best of what storytellers like myself can do, with giving you some control within that world, is something that's really exciting to me, and something that Julian is really pioneering with 30 Ninjas. And so that's, Jet talks about two sides to the company. There's the interactive side, and then there's the other side, which is what empowered me to make Bitcoin. And
why don't we jump to Bitcoin? Why don't we give you all a little bit of Asteroid? So we've got a short clip that we'll play, and we'll dig into Asteroid a little bit before we jump to Bitcoin.
You came back on this face without them. We had 6 hours on the Asteroid. The real problem is
It's a really cool experience. You guys haven't had a chance to do it, see it on the headsets. Really immersive. And let's talk about the character at the end and how you use AI to interact with this character. So as I mentioned, one of the characters is left on the Asteroid at the end, and the movie exists. You get to interact with them in real time and talk to that character.
And this isn't the first time, by the way, that I've killed off a character and have, producers come back and bring him back to life. I did, key part of that film was that Jake Gyllenhaal had to kill Conor McGregor at the end. Like an essential part of his arc. And at some point, Joel Silver came to me and said, Conor is too iconic in this movie. We have to keep him alive for sequels. And I was like, it's the whole arc of the movie that he does. Like that Jake's entire arc is worried that there's a killer inside of him. If he doesn't kill somebody at the end of the movie and then have to leave and go back to the show, it's like that is essential to the movie, to Jake Gyllenhaal's arc. Jake's like, and Joel Silver's like, no, I know that that's essential for Jake's arc. Yes, of course he has to kill Conor. I'm just telling you, he also has to be alive at the end of the movie. And we had to figure out a way to do that. And here's the similar thing, right? Killed DK, and then they're like, okay,
it's not
it turns out he's not dead. He's gonna, and that's how we got to suddenly, an additional chapter to the Asteroid.
The real groundbreaking thing that happened with Asteroid is that we conceived of it as the 180 film and the story extension. The story extension, then using generative AI in order to create the conversation and drive the interactivity after. I would say 4 months before we were going to premiere, Gemini Live native audio came about, which was actually the ability for natural language conversation to drive the engagement with the character was really a game changer. So then you move past the NPC and you can still stay within the story world, stay within the context of the story with the stakes and carry that tension from Duck's film and the immersive experience that you're in a headset, and then talk to the character and try to save him. So it's a Unity app too, so you're within a representation of the set as well. Using and leaning on the construct that the person, the player, you assume you're playing someone from NASA, so you're on Earth, and so you're not seeing a full. It is photorealistic, but it's abstracted in terms of what the visuals are on the Asteroid. But DK, as the way that Doug wrote DK and that character, he's extremely likable. Not everybody in that film is a likable character. They end up some of them killing each other. But DK is funny and likable, and so you really do also want to save him, and that was a key point and really necessary for the character to work.
And I'm sure you've got some questions about how did you use AI in this, and did this take the job of screenwriters? And so maybe talk a little bit about that.
I mean, it's not really been it hasn't been our experience, I would say.
It predates AI. It's a great question.
But it is the AI, right? So for an AI character, the interactivity there's an enormous amount of writing that goes into it. I mean, it's a novel worth of writing, 1,000 pages for DK for a short experience. So there's
they had to write not everything that DK might say, but they had to train the model. Right. They had to put DK through ton of experiences, and someone had to write them.
And then create the game in a way that there's a dramatic situation. So then you have the game design, you have the overlay of game design, linear storytelling, interactive storytelling, and needing to care and want to resonate.
I mean, our experience in 30 Ninjas is, obviously because we're a startup, we're generating a lot of jobs. It didn't exist before that because we're an expanding company. But
we're creating the jobs, we're not generating. Clear.
Fair enough.
And like, and the script is a script written by a writer, right? So there's already a writer and a movie and a script with this character, right? So the amount of writing it takes actually to craft an AI character that not only like has a complete, backstory and is trained in doing, but also has enough guardrails around them so that, when people try to mess with the character and get PK'd trash talk other players in the NFL, he won't turn off, but he will say like, well, I think everyone who gets to the level of the NFL, you're super talented athlete, and they're all amazing. That takes a lot, and it takes a lot of humans not only to write, but also to test, and then DK test it. He's like, yeah, that kind of sounds like me, and that's pretty cool.
But what I would say is that, there is the interactive part of 30 Ninjas, and then there is the AI side, which, is Bitcoin. And, on the AI side, because I come from the film business, and I'm one of, so many of my friends aren't working right now. The business is growing. It is, for sure. The number of my friends who are not working in writers, editors, directors, and, what I find so extraordinary is how many people like that 30 Ninjas is hired, whether it's like top film editors who just, who are not currently working because there's a quarter of the number of movies being made, big movies like that. And they're fantastic playwrights who are working, generating the shots for Bitcoin, and they're bringing all of that expertise as storytellers in the industry and from different parts of the industry. So, so my experience on the job side is that because we are starting with creating jobs for people where maybe the traditional industry is not great.
Well, so speaking of Bitcoin, why don't we jump into that? And maybe you could give the audience a summary of the movie, and then we'll show us after that.
So Bitcoin is the story of Greg Wright, played by Casey Affleck, who may or may not have created Bitcoin, and the forces that come out to destroy him. And Pete Davidson plays this, fantastic billionaire magnate who's making the biggest gamble of all history. Casey and Galcato plays the reporter trying to figure out what's true and not true. And the reason why I thought this story would be fantastic to use help from technology is it set the world of cryptocurrency, which already is sort of pitting humans against machine, right? The whole thing is like you trust, right? And the whole thing about Bitcoin is don't trust, verify. Like don't trust the humans, verify. Let the computers do it. And have the humans are humans corrupting the original vision of what Bitcoin is supposed to be. So within this, the world of Bitcoin is the battle between humans and machine. And I thought, I try to never repeat myself as a filmmaker. And part of how I do that is by working with different people. There's other filmmakers who their films all look sort of similar because they work with the same, even though it's the same actors. And I try to, because I'm always going to be the same person. All I can do is change the people around me. So this time I was like, well, one of the people I'm going to change around me isn't going to be a person, it's going to be a computer. And so I'll make something different than what I've made before. And this seemed like the perfect story to do that with.
This is a full feature movie that's using AI. Describe to the audience what's happening with AI and what you're trying to do with it.
So, we started down this journey 2.5 years ago, as a Google, being like, hey, let's show you what the future's going to look like. And where I said that in terms of kind of how AI would work with director-driven movie, not like some random AI slot, but something that I want something that represents kind of the best that I can bring to the table, the best that my production designer can bring to the table, my TV can bring to the table, my actors can bring to the table. That was the most important part. Was Casey, Gal, and Peter, fantastic. And I know that it's not only can I tell that, but when I show scenes, which unfortunately I'm not allowed to show here, people are like, they're fantastic. And that's figuring out how to get their performance into the computer along with the department heads and the best of all of us. And then get the prompters who then can add a special sauce so it doesn't look like what I've done before. And that was a really challenging process. And I give a real shout out to, or he's going to kill me for doing this, to my producer, Ryan Kavanaugh, who raised the money for this movie and embarked on this journey with me when, it's one thing for a director to be crazy and be like, okay, I actually have no idea how this is going to work out. I'll go down and like, sort of crazy that you would go down this river with me. I really have no idea how to get through it. But for a producer to sort of have the courage to back a filmmaker and go like, because when we started this, my estimation, with no exaggeration, was that post-production was going to be 40 years. And it was like, we're just counting on that there are going to be technological breakthroughs while we're prepping and figuring it out, and it will continue. And now we've cut it down. It was, 2 months ago, it was 3 years of post, and now we're down to 6 months, which is kind of different than a traditional film schedule. But the entire film was captured, all the performances were captured on a stage that we designed over the course of 6 months of full prep R&D.
And it's one set, right?
It's one stage. Everything was shot on it, whether they were inside a swimming pool, whether they were on a boat, a beach, in Vegas. It's like, and then the thing that was unexpected is once, when with Bitcoin, what happened that I knew, I was like, I'm going to embark on this journey and I don't exactly know how it's going to affect me, but I'm just going to go with it. And one of the things that I discovered was happening was that normally, a filmmaker and the producers have this kind of dialogue where I want to shoot a scene in Vegas. Like, you can't afford to go to Vegas. And then it's like, but how about this conference room in the basement of a hotel in London? I'm like, oh, but I kind of want the scale of Vegas. And then like, well, if you go to Vegas, you got to give up this. And something was, well, I don't have to choose. I can do Vegas and I can go to Antigua, not of which were the original script. And I ended up going to, like 150 cities around the world, of course, because I want to do something that captured the excess of cryptocurrency. I want to make Wolf of Wall Street sleeping. And so I started changing the script, because normally you take a story, you have to condense it down to like 40 scenes and X number of locations. I was like, oh, I don't have to do that. And so it was really it changed my entire approach to having even write a script, because those limitations are no longer there. You can imagine a playwright has to write with this idea of like, how do I have everything take place in his living room? So how is that set? Here and filmmakers, you wouldn't think they have limitations, but we really do. And how do we fit into that box? And I'm like, well, actually, there is no box anymore. The box now is just making sure that everything I do furthers the story. And there's a lot of talk about job loss creation. The reality of Bitcoin is that when you suddenly go to 150 different locations as opposed to 40 in a traditional movie, those locations have to be populated with people and characters. So suddenly you have to cast actors, because that was the thing I wasn't going to replace. I wasn't going to do any computer-generated performances, even though there are some, actors out there in the world who computer might actually do a better job than they do. But I wasn't going to do that. I was just going to cast fantastic actors. And so, it was causing an issue during prep, because my line producer, who was never, I planned to shoot wherever I wanted in the world, because for creating, it's like, Jesus, you're hiring so many actors in this. There's like 125, 140 actors. Can we cut it down to 7? For instance, like Born Identity has like 50. And we did. That was one of our certainly Bitcoin is different than my other movies in terms of the scale and the number of small characters. Obviously, Gal, Pete, and Casey are the heart and center of it.
And under the hood, maybe Julina and Jeff, talk us through what is it like to work with Leading Edge Tech? How did you stitch this together? So I was on set with Doug as the AI supervisor on set with the capture. We were also running a team of AI artists within the editing so that we were generating working with the art department and the production designer in order to create the environment so that we could then pass stills and frames to the edit, and they would start to use that generative footage inside of the animatic so that Doug could then see and evaluate how well it was working, and that was our first phase essentially. And those Jen said, that's a cross-discipline team. There's screenwriting, they're storytellers from different walks of life essentially. But we also worked then very closely with obviously the VFX. There was a VFX team that was doing, we did capture on set as well, so that we would have those likenesses.
Just the capture on the set was, my films sort of benefit from, whatever I experienced before. Like Mr. and Mrs. Smith, the movie it is, because it's a projection of Born Identity. Because it was Born Identity, it was like, look how cool this is, secret agent. And then I read the script, first draft of the script of Mr. Smith, and I was like, oh, wait a second, like, why are we celebrating James Bond? Like, that guy can't maintain a relationship across 2 movies. Like, the bigger thing to celebrate would be somebody who's holding a marriage together after 7 years. It isn't gallivanting around like a secret agent. So Mr. and Mrs. Smith is very different because of my experience having made Born Identity, and because I made Asteroid, which was all performance capture and true performance motion capture. All we ended up in the editing room was a bunch of data. And I was like, holy fuck, how do we edit this together? It's like, we have to generate shots from the data first, we can be able to figure out how to start to edit. It was like, we can't go through a whole movie like that. So we decided that the process needed to involve us composing shots on set of my actors. There are witness cameras, and I can in post, I can decide to change it if I want, change the angle. But I have to commit to something on the set, so I have something to edit.
You can also use, within the process of the animatic, some scenes were working and not working in terms of how we were generating the AI and the seamless in scenes, and we rewrote and reshot some of the scenes as well, that's not unusual for a film, if you want to rewrite during that. But that was just really the tip of the iceberg, like the performance capture in those days. There was 6 months of prep.
Yeah.
There was 4 weeks, 4.5 weeks of production that we were in production. So all that prep, that small sprint, and now the hours and hours of post-production.
No, it's interesting. Look, we're an artist-first, technology-driven company. I like to think we take the best of both worlds. Film production world, which is like a very, in all my life, and the very, I wrote like, VFX studios have pipelines, and we have a process of getting from pre-production to production to post that is kind of like written to a degree in stone, as opposed to the technology side of our business, which is Apple. Like, we are always adapting everything we do to whatever the latest technology comes out there is. We have our own proprietary pipeline and workflows we can make these films with, but like, that changes, we're not doing it right, we're not changing that like every couple of weeks. And what that means is not that we're like cutting costs, saving money using AI. It means that in the current reality of making movies and television, creators like Doug are like, I don't have enough to do what I want to do. And we supercharge doing what our creators want to do by bringing in new tools, new technologies, and building a workflow around it that enables us actually to deliver something. And the way that Doug deals with it, the way that Doug interacts with this technology is going to be very different from the way a lot of other names we can't talk about, we're going to work with, and seen a lot, are going to engage with this kind of technology. And that's where it's really exciting, and where us also partnering with Google, not only getting a little bit of advanced look at some of these tools and some of these some of the things that Doug's saying, now we can do this in 6 months, thank you, Tim and my company, and similar tools, like that's great. It's also about being able to work with the research teams and work with DeepMind and really sort of like learn from each other and say, what we really need to get is here. And like sometimes we get there and then we change things, and sometimes we don't get there, we go back to some more traditional filmmaking techniques. So it becomes like a process, like you can change the film in post as you're going through it. You can iterate and the line between pre-production, post is like sort of almost doesn't matter until you get to the deadline, just like with software development, where you need to deliver and you're like, okay, here it is.
So we have a few minutes left, and I thought, why don't we wrap up with some advice that you think filmmakers ought to know or have based on your experience and what you've been playing with. So maybe Jeff will start with you with
I mean, I feel like now the advice is always just go do it. As a young or old filmmaker, and I say old filmmaker because a lot of our team are, in addition to technologists and sort of like AI native artists we find, are also like, one of the top feature film editors in Brazil is one of our lead creatives, because they don't make big budget films in Brazil anymore. So he's like working with us, and it's not a different career, it's a different kind of career. So we found him because he started making, really amazing AI shorts, and Lena judged the festival and found his short, and was like, that's amazing. So like, my advice is always like, use all the tools that are out there. Google and other companies like Google have handed you billions of dollars of investment to go tell your own stories now, so go tell them.
Julia, your advice? I mean, not much different than that, except for that I would say also, I think it's a really interesting idea to figure out what the engine, what the tools can do really well, but also try to break it and try to make it look untraditional, and how can you use and harness that within the writing and within the story. I mean, there's a sense within the story that some of the art direction may end up being, some of it's told in essentially back in memory, right? It's told from the perspective of the present, the past. So where can you lean into what AI can do in the special effects and visual effects of that? But I think figuring out what the boundaries are so that you can develop your own style, figuring the rule is also difficult to sometimes not make like everybody else's, and that person in center writing and difficult, of course, that all of the models have, essentially. So break it and find it for yourself. Advice for filmmakers here, or I think the filmmakers well,
it's almost similar to the advice I used to give, just via film schools, and I love, sharing, if someone can learn from the mistakes I've made, that makes you feel better about them. And it would always be like, don't try to copy me or copy some other filmmaker, like, chart your own path. Like, if they want someone to make a film that looks just like what I did, come to me, whatever. Like, do your thing. It sort of doesn't look like anyone else's movie. So, in a way, I'm sort of thinking about giving that same advice now, that, like, I don't know if there's any screenwriters in the room, but if there are, and I said, okay, who here has cheated and tried to ask, ChatGPT or Gemini to, like, write a scene for them? And we all raise our hand. Yep, and came up there. Like, it is, and it's terrible. Right? It's you figure out a way how to use these tools to sort of bring out your humanity, but not to cheat and just let it do it for you. But figure out how to empower and let your humanity come through. Now that would be my advice.
Well done. Right on. Might be thinking. Shout out to Jen and that.
Welcome. I'm Diana Wong, a product manager working on developer experiences for adaptive apps across form factors.
And I'm Emily Roberts, a developer. That was the plan. I planned it. I'm a developer relations engineer working on Chrome OS and adaptive apps. And today, during this talk and at I/O, you're going to hear the word adaptive a lot. Adaptive is not about developing for a tablet, or foldable, or any particular form factor at all. It's much more than that. It's about thinking beyond form factors and developing for robust, reliable app experiences that meet your users' expectations on all the screens. If I give my mom a tablet, she doesn't want to think about what is this app, like stretch out the screen and they can't take a photo with it. She just wants to do some cool stuff with it.
The reality is that our users are not on a single place. They might start a task on a foldable, move to a tablet at their desk, and finish on a laptop, expecting that experience to flow seamlessly across every surface. Users, like Emily's mom, don't always think about form factors. They think this app works or this app doesn't. And we've been working to improve our frameworks and libraries to help your apps run great across the ecosystem. We hope you can adopt this adaptive mentality too.
And all these form factors bring lots of exciting opportunities for you and some new considerations. So today we're going to talk about the Android ecosystem, how it's expanding with some exciting new form factors, new APIs and updates that can close. We're going to look at tools, including adaptive AI skills, and at the end we'll look at a few UI frameworks that you can use to bring your existing app to Android. We're also going to sprinkle in a surprisingly large amount of French pastry and a wrap, maybe. So let's get started.
Could be good. Let's start with a brief overview of the ecosystem and where it's headed. The Android device universe is no longer a phone-only story. Users are buying the ecosystem using multiple Android devices, and they expect your app to follow them without missing a beat. There are now over 580 million large-screen active devices that benefit from investments in adaptive apps. And as we expand the services that your apps can run on, that number continues to grow. It's not just the number of potential users, it's also that we've seen users that have multiple devices spend more. Users with a large screen, like a tablet or a laptop and a phone, spend 9 times more than phone-only users. And for those that are on foldables, that multiplier jumps to 14x, making it one of the highest value user segments on Android. Play is helping to increase that opportunity for themselves and spend by letting users know which apps work best across devices. Apps that are optimized for large screens now feature an optimized for large screens badge on the details page. And since last year, more apps have continued to go adaptive. Here are some great examples of apps that deliver premium experiences across Android. I'm going to dive into a couple, like Notability. Their Android debut sets a new standard for premium productivity apps. Built with Jetpack Compose, Navigation 3, and Kotlin multi-platform, it delivers an intuitive, adaptive experience across devices. It also features great style support with a low latency API. Another example is BandLab, a full-featured collaborative digital audio workstation. Users can create digital music and record a live performance in multi-track environment. When a device has a trackpad and a screen space, users want to be able to take advantage of it. Leveraging Compose, BandLab rewrote their portrait social feed so that now it can expand into a masonry-style, multi-column look that makes the app feel right on wider screens. The great thing about adaptive development is that every optimization we make naturally enhances the experience across devices. Last year, we introduced changes for all apps so they default to adaptive behavior, removing letterboxing on devices. We provided a developer opt-out behind Target SDK to give apps time to adjust, and now with Android 17, the opt-out is being removed when apps target SDK 37. On large screen devices with the smallest width over 600 dp, like tablets, laptops, and the inner screen of foldables and XR, Android won't react to certain mobile constraints, moving closer to responsive UI development. These include changes to how apps react to set orientation, or resizability, and aspect ratio. So note that these restrictions are still respected on smaller screens like phones and for games. More continuing. You can prepare by having your apps naturally adapt and look great in whatever window they're placed in, not just a 16:9 icon. Things to watch for are stretched UI, squashed or sideways camera previews, off-screen controls or animations, and your app's state after rotation or folding or resize event. Be sure to test your apps to see how they will show up for your users with these changes using a compatible emulator. If you don't have an Android 17 device, you can still test on an existing older SDK by going to developer options and selecting app compatibility options. You look under SDK 36 and you enable the universal resizable by default flag. So these Android changes help pave the way for the evolving Android ecosystem. Let's check out what's new across our Android form factors. As we announced earlier this year, connected displays is now publicly available with the recent Android feature drop. This means any compatible Android phone or tablet can instantly be transformed into a powerful productivity hub by plugging it into an external display. This is already available on supporting Pixel and Samsung Galaxy phones. And it brings compatible phone and tablet users into the desktop world of increased engagement time without the need for an additional device. Apps that are adaptive, handle mouse and keyboard inputs are going to stand out. And that's not all for desktop. If you tuned into the Android show last week, you'll know that Android will support one of the most popular computing form factors, laptops.
So Android apps have been the first app citizen on Chromebooks for a decade. And of course, building adaptively for Android, meaning awesome large screen layouts and top-notch input support remains the very best way to make sure your app looks great on laptops. And on the hardware side, we continue to iterate, like with the more powerful Chromebook plus devices. And so you can imagine how excited I am to stand here and talk about the next iteration of Chrome OS built on pieces of the Android stack, also known as Google Books. I know it was already, I'm still super excited about it. The new name and the incredible lineup of devices we have coming from a variety of OEMs represents a shift in computing. The next iteration is going to make for powerful laptop experiences running the exact same apps that billions of mobile users depend on every day with Android. This is a milestone and we should celebrate it, but I also think it's worth mentioning that it's a continuous evolution. We're bringing years of innovations and learning from Chrome OS to improve the experiences of Chrome OS and Android users across the board, not just on laptops. Some of this is already visible for phone and tablet users. For example, the Chrome browser on tablets has the bookmark bar, as shown here, and phones and tablets also have pinned tabs and connected display support. And improvements go both ways. The next generation of Chromebooks, or Chrome OS, is also being a performance boost for your Android apps. It also allows us to bring the power of Gemini right into your laptop workflows, unlocking whole new desktop user journeys. So I wish I could say a whole bunch more about Google Books and all the awesome devices coming in, all the juicy technical details. But the most important thing is that your apps are ready. And one way to start testing for that is with the new desktop emulator that is now available in Android Studio Canary, Quail, Canary 4, I believe. And you can find it in the Virtual Device Manager under Desktop Preview. And just make sure it's SDK 37 and you should get that resizing experience hub. On the documentation side, to help prepare for Google Books, we built out new guidelines on development.android.com and material.io, including design kits to cover desktop principles, new input guidance on things I love, like right clicks and hover states, and more opinionated guidance about layouts. One of the documentation updates I just want to share is something that happens when you have Android apps running on these larger screens with pointer input. Sometimes information density can make an app feel right on the desktop. So with larger screens and a precise pointer,
Sometimes having slightly more dense UI just makes it look and feel better. It can be really subtle, like the padding and button size as shown here in this model. And lastly, as I mentioned, with all these new Android devices coming, users are more likely to have more than one. Continue on is the new API in the activity class coming in Android 17, which allows users to pick up where they left off on the second device after they have been working on the first one. So you can see on the phone here, Google Docs, we're way down in the document tab, and we're scrolled way down. So to continue editing on the tablet would be a little bit frustrating to find that exact place. Continue on allows you to pass the data off, and the user can pick up right where they left off, Mongo, right in the document tab, and scroll right up into the document. To integrate and make sure your app is ready for Android 17, indicate you support continue on by setting handoff enabled to true, and then you just set up and handle that bundle on the launch intent. That's basically all you need to get integrated. To learn more about continue on and these other desktop updates, check out this recorded talk dedicated to that. Of course, design for desktop means your app's going to work great across a whole bunch of Android form factors, so let's talk a bit about those.
So looking at another class of devices where making your app adaptive can help. The in-car app experience is a perfect example of how these changes apply to hardware. Whether it's catching up on content or staying productive, users can enjoy their favorite mobile experiences the moment the vehicle is parked. If your app is already adaptive, that's great, you're almost there. For Android Auto, meaning your mobile device is running the app the UI projects onto the in-car display, you can add an appropriate manifest entry and check for eligibility details in the Android Auto docs. For Automotive OS, which is when your app is installed and the car is embedded into a payment system, your UI scales up easily like a tablet. There are a few more things to check to make sure your app is installed in addition to those automotive-specific manifest flags. So first, check your manifest for these features. Of course, your app can still take advantage of these features on devices that support them, but if your app doesn't even run, you can indicate that as requiring this false. Secondly, check your dependencies on Google services. Many of the Google Play libraries we use on mobile are also available on cars, but not all. And you can check the docs to see if you're inadvertently including a library. Another form factor that benefits from adaptive development is TV, where Android apps are getting new types of input support. Google TV supports pointing input with cursors, trackpad, and now pointer remotes for faster navigation. Think of this as a direct extension of the work you're already doing to support input beyond, like on Google Books. By implementing hover states and focal points today, you aren't just optimizing for a mouse or a laptop, you're making your app inherently compatible with the TV interactions tomorrow. Next, Android XR continues to heat up with new devices and a growing user base. Like other form factors, your existing adaptive app will be available on XR. With optimized large screen layouts and XR keyboard and pointer support, your app can provide an immersive experience across XR headsets and wired XR glasses. Starting from these adaptive best practices, you can also add immersive spatial capabilities for XR, as well as creating unique on-the-go augmented experiences for audio and display glasses. This is where the Android XR SDK comes in, helping you build these differentiated experiences. You can learn more about creating both immersive and augmented experiences in the Android XR supported platform. So that's what's new across our devices and the exciting changes we're enabling for each of them. But what's the best way to build for all of these exciting form factors? It starts with our Jetpack and Compose API.
So this year, we're going to Compose first. And Compose is the best way to build adaptive apps. Let's look at three important topics from building adaptively, and we'll start with layout. Instead of designing apps for a form factor, design for UA.
That's the truth.
There's pointer or keyboard, window size, posture changes like unfolding or folding, or detachable, or hardware capabilities like there's a microphone or camera available. And we know that not every
The dark web is kind of prevalent with all of these things. And there are many kind of hacks that are readily available if you know the right contact. I will switch the context a second to EAFC 26 because I have a couple of things that I needed to share. One was the coins that they say do not purchase. Many people are doing it. And there are whole marketplaces on the open web on Google dedicated to it. Along with people playing other people's their clients' accounts, and it's all on the Twitter and socials right now. So it's all open. And the second was the FAT Genie. This kind of soft ban that it talks about, it is due to the next number of SPCs or bids that you do in a particular time, since it is all JavaScript, so you need to be careful and be completely in acknowledgement with what their limits are. You have to keep that in the mind. I think those frequencies are messing with me again. But there's this new Prime Hero Guti available, which has 99 passing as well. In addition to Charisma, there were, as I have alluded to, there were some people trying to mess up my EAFC experience. Have reported it under confidential circumstances to both EA and the local law enforcement officials. Let's see if I hear back from them again regarding it, because I will be making a video about it soon too, like when the game is near completion and things are over. Near the end. Of the game in September, such that when the new game releases, they should be using stronger safeguards, and they should be using help of secure the top of the line models like Mythos, Anthropic's Mythos, and others like OpenAI's enterprise security models that have recently come out to fix those issues. Pixel. Send to transfer list. Quick open. Star on club. Pixel. 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 Send to transfer list. Store on club. Send to transfer list. Store on club. Send to transfer list. Store on club. Send to transfer list. Some items that need to be sold. Batches. Send all duplicates to transfer list. Store all in club. Send to transfer list. Store all in club. Send to transfer list. Next, I need to think so. Switch to transfer market. The prices might be too high right now. Oh, it's yeah, it's too high due to the SBCs. I don't think so this will drop because people need to complete these SVCs and Using any of the players right now because of the exorbitant high cost. Might do a couple of SPCs and try my luck there. What is this 4 of 87, 4 of 81 players? Historical is not worth it. This isn't, this isn't, this isn't. This is exactly gold. This is also exactly gold. So I should complete this. Got 87. Rated McAllister. So what are the items that are selected here? 82, 82, 87, 84. Okay. Eighty-one, 82, 83, 81. 35 plus upgrade. Yeah, 700 will do. I don't know. Pixel duplicates. Yes, basically, solutions limit reached. I think so. I get free 10 every day. So, used it all. Let's go through my emails first. The gear community that I was going through. The developer agents and with this is cool. They are updating their content to reflect this change. Gemini Enterprise Agent platform. Yeah, I may do this and this. These are some good courses to get a crack at how the Gemini Enterprise agents are looking after the recent upgrade. This runtime transformers, code fixes for Rule 16, update, Minic PM tokenizer attributes or transformers compatibility, bug fix, GTN, resettle generators scoring entry points, update KV, transfer security configurations. Added tips V2, advancing vision language pre-training with enhanced patch text alignment. CPU AC, object store, Chinese versus English, AMD roadmap, developer roadmap. This is for VLMs. Taught of vocabulary, views, kernels, Rockcomb performance. This is Indigo Blue Chip. I fly with this all the time, so. Code Vipassana. Not joining that. Will be in the design and analysis of this talk today. Mathematics and efficiency of deep learning group. Eugenia and Andre will be presenting today. They will be giving a talk on this paper. Panza, that's the design and analysis of a fully local personalized text writing assistant. End-to-end security in an age of agentic AI. This is happening on Thursday, June 4th at 10:30 to 11:15. Yeah, I have this in my calendar. Ticket code, easy connectors. Remove best from the feature compatibility tables. Paper banana. Automatic illustrations are there. After a bit of a break, let's return back to the live stream.
The developer has the same needs, and so we have options for different pieces of your UI. Sometimes you might want this piece of your UI to have an out-of-the-box solution that just works. Maybe you want something that has a basic implementation, but you want to customize it. And finally, you might want to build some components right from scratch for a bespoke look. An example of those ready-made APIs is the Composed Material 3 adaptive library. It has 3 different adaptive layouts, including the navigation suite scaffold. This is an out-of-the-box solution to help you handle navigation UI, allowing you to have a navigation bar on the bottom on narrow screens, and then a nav rail or a nav drawer on a wider one. For multi-pane layouts, you can use navigation 3 with material scenes. If your app follows the list detail paradigm, there's list detail scene, which automatically handles multi-pane arrangements based on screen size. There's also supporting pane scene, which helps show additional supporting info that's related to that main content when the screen's large enough, like the up next shown here. Moving on to customizable APIs, which provide a more flexible middle ground, you can take these existing implementations and then modify them to suit their needs. Let's take a look at an example with scene decorators. Scene decorators in Navigation 3 1.1 allow you to wrap your UI content with custom elements. You could use this to add aesthetic touches, or you could use scene decorators to implement the navigation UI, like bottom bars and side rails, but with an important distinction with the navigation suite scaffold we just talked about. With scene decorators, you can allow your content to drive when that decorator should be shown or not. This is particularly helpful in cases where you might have some app flows where you don't want the decorators. So maybe a camera preview screen that you want in a dialog, or full screen and you don't want the nav bars shown, and you can do this without having to manage the state up and down the stack. For some ready-to-use but customizable implementations for scene decorators, check out the Nav3 recipes page. Now, if you wanted to do scene decoration but get right into the details and build from scratch, you can do that too. Implement a scene decorator strategy, override decorate scene, and then you can decide based on the content if the scene should be decorated, in which case you return that decorated scene, or else you return the undecorated scene. Let's take one more example of this customizable versus build from scratch with scene strategies. To let nav display know when to show which scene, we introduced scene strategies in Nav 3 1.0, and it lets you determine when to show each scene based on your own custom criteria. Our Navigation 3 recipe page, again, has some customizable scene strategies for you to use and customize. If you wanted to go farther, you have that control tool, and you can really customize down to the animation speed and add all that into your own scenes. And one update I wanted to mention quickly about scene strategies is we updated the API to be plural. And it now explicitly takes in a list of scene strategies in prioritized order instead of you having to use that undocumented then infix like in 1.0. This should hopefully help you more easily implement complex scene strategies. Okay, so I know I just threw out a bunch of APIs and just skimmed the surface on them, but to learn more about scene strategies, scene decorators, and what else is new in Nav 3, check out this dedicated recorded talk. Outside of Nav 3 itself, we have some new APIs too. Gathering conditions to determine which of those scene strategies to show can be difficult. The experimental media query API for Compose provides a declarative way for you to get signals from the environment, like window size or pointer precision, and make decisions based on that. This API is going to grow, and we need your input. So check it out and let us know what you think and what's missing and what's working well. Media query was inspired from CSS, and we have 2 more APIs, experimental APIs inspired by the web. I know some of you have been asking for these for years, so I'm happy to let you know we have grid and flexbox layouts. Yay! Yeah. So grid is for creating 2-dimensional layouts. Let's dig in a little bit. And I know our talk is full of information, and everybody wants to talk about pastries. I live in Paris, and I love the pastries there. So I'm going to my favorite vegan bakery, which unfortunately is below the office, so I go there quite often. And I want to lay out some patisseries in a box, and I'm going to bring them to a party. OK, it's a square box. Let's say it has room for 4 pastries in each direction. It's a grid. To set that up, in the config block, I use the repeat word to set up 4 columns and 4 rows. Are you ready for my incredible drawing skills?
I'm so ready.
Let's start with a baguette. Woo! So you can see that it spans 4 columns and 1 row. Let's add a few more treats into my box. We have an opéra, which is 2 rows, 1 column, a tarte au citron, which is 2 by 2. And then let's add a few more little regular pastries. A chausson aux pommes, that's my favorite. It means apple slipper. So you can imagine like a slipper stuffed full of warm apple insides. And a chocolatine, also officially known as a pain au chocolat. But I'm from Canada, so there you have it, chocolatine. Lastly, just to finish this off, let's add 2 giant-sized declares there that are 2 columns each.
Okay, this looks really good as pastries, but I'm assuming you're imagining these are really toolbars and buttons in real app life.
Yes, of course. Pastries are more fun, but maybe that's a title, maybe it's a button. Yeah, but come on, pastries. You can all build pastry-based apps after this talk, no problem.
I'll take the eclairs. Yeah.
So,
go ahead.
Well, this is grid, and it provides this amazing resizable UI, and it looks good. I think everyone's going to be pretty happy about that, right?
Yeah, they look too good to be true. So are they really going to scale?
You don't believe this is what's happened? There's only one way to settle this, with a live demo. OK, let's go to a live demo of grid and Flexbox here. This is the app. This is the app running on my Chromebook, so it's running natively here. And check it out. It resizes. Hold on. Come on, mouse. OK. It resizes, stretch. It's nice. Look, I got a little blog here about me in Paris, Canadian in Paris. I added this. Here's just showing that density thing I was talking about. We'll leave on normal density. OK, this is grid. Great. I would like to talk about the second API, which is Flexbox. And let's look in the code. Here's my grid code. Here's the code we just saw. But let's talk about Flexbox. Flexbox lays things out. I should go this way, right? In a single direction. And it has 2 modes, one that allows for wrapping and one that doesn't. So let us start with no wrapping to start off with. I've got 3 little things here, chocolatine, baguette, and let's run this and hope it works. Of course, it'll work. All right. So here we have 3 elements. They're all affixed with, and they work great. You can click. Oh, I forgot to talk about, if you click on these, hold on.
It's a beautiful new Compose Flower Puff API.
Flower Puff 1.0 in Compose. Just kidding. Okay, let's get serious.
Going stable now.
Going to stable now. It's available today. OK, that was a joke, right? But this is a baguette, and look how tiny it is. It's all squashed in the middle. Your UI team is going to say, hey, don't you think we should fill up that space? Well, this is called Flexbox, so guess what? We're in luck. I'm just going to uncomment this line and comment, oops, getting a little nervous here. OK, comment this line out here. So here, I'm keeping the height fixed, and I'm allowing the width to flex and grow up to 100% of the leftover space. That's what that float value is. And with any luck, come on, Android Studio, we need you. It will stretch and grow to fill up that space. And let's just double check. There it goes. Look at that sourdough baguette expanding. So you can, again, imagine this is like a button that you don't want to have changing size in your UI, but maybe that baguette is a title bar or something like that. So this is Flexbox in the no wrap mode, and I think it's time to wrap.
I think in honor of wrapping here, just to be clear, Emily has written a rap about adaptive. I'm really kicking
I have.
off.
Yeah, Maybe I've written a rap.
Making apps is cool. I do it in my sleep. I'm so adaptive. It's gonna make you weep.
All right. That's pretty good. Not too bad. Not too bad. Pastries in a box while I'm rapping around the clock. Flex boxing like my pipes while I'm coding as I type. So.
More?
My keyboards, they be clacking when my trackpads, they be whacking. Stylus and KPI like lightning. Man, my drawing's so bad, they're frightening. I got my data in the cloud, but local storage all in shroud in aluminium. Yo, we be winning them. Hold on. No. Take a oogly look at my googly book. A grid may be square, but avec baguette ou eclair. Adaptive is rising, my UI is besizing from Android TV, foldables, tablets, laptops, cars, phones, right down to Android Wear.
Okay. That was great.
That was good.
Let's get back to something serious like pastries.
Yeah, pastries, let's get back to the pastries. Oh, I blanked on my
All right, so we're back in flex mode, and now wrap is turned on.
Oh, here's wrap. We have wrap turned on here. Let's see. Oh, wait, I'm just going to change my view model here to make this easier. OK, so we are in, remember, Flexbox, lays out in one direction. When we don't have any room here, we've added a baguette and a little chausson pomme. It wraps down to the next line. OK, no problem. So let me uncomment out a few more pastries here. And when it runs out of room, here we've got this eclair, we've got a tart, and remember that chocolatine is one. It falls off the end and wraps down to the other side. So that's as we expect. Let me just show you one last thing. What happens when we have Flexbox wrapping all those lines and it doesn't line up perfectly? So here I've got this nice eclair, and it fills up 3 columns. There's no room for here. And that last eclair, we don't want to have it all squashed in the box with the filling coming out, so we wrap it to the next line. This is just like you want.
Yeah, I need more eclair, though.
Yeah, more eclair, but you've got a pastry box with empty space in it, which is a problem. And your UI team might say, I don't know about all this empty space we've got going on. So let's look at an option we have. What have I done with that? Let's just assume that's going to work. That'll work. Let me fix the height, but let that let me go back to the code. Let that width flex and grow like we did before for these 2 eclairs and see what happens. And there you have it. The eclairs stretch out nicely. Flexbox is smart enough to know, look how giant those are. Flexbox is smart enough to know how much space, even though we're wrapping, is left on that row, and it expands nicely. OK, we're almost done with the pastries, I promise. Not that that's a good thing. But let's say the artist, that's me, is not impressed with the fact that we've stretched out that artwork. Design team's sort of happy, but it just doesn't look right. The aspect ratio is all squished. Let's see what happens if we unbind the height and let these grow. Look at this giant eclair there.
Definitely more eclair.
It's definitely more eclair. The artist is happy. The UI team is happy if you like pastries. And I've let both the height and width flex and grow up to 100% of the width. That was a lot of pastries.
Yeah. Compose is where it's at.
And those pastries are fat. P-H-A-T, like the 90s.
That's our wrap for you guys.
That's a wrap for that. Thank you.
Go on top. All right. So adaptive layouts, even the stretchy ones with pastry, are only one piece of the puzzle. Excellent non-touch input support is a must, and we've made framework-level investments to provide more out-of-the-box experiences. In Compose 111, we've improved trackpad support to be on par with mouse and pointer support, including proper hovering and tooltips. We now process trackpad events as pointer-type.mouse events, ensuring consistent behavior across pointer devices. This enables automatic recognition of advanced gestures such as pinch to zoom and 2-finger swipes. We've also shipped new non-touch-based input testing APIs in Compose 111, including trackpad injection scope and perform trackpad input. This helps you write reliable automated tests for non-touch input. Focus states are also important to input, and now in alpha, we've introduced support for focus rings designed for Material 3 components. Focus rings are a critical redesign of the Focus UI on Android, ensuring that interactive elements pop out for users during keyboard or D-pad navigation. Visual feedback is great for indicating focus, but we can do more, like visually indicating when an element is pressed or has a cursor hovering over it. That's so helpful for non-touch interfaces like Google Books and TV. So we now have an experimental API that allows for state-based styling. You can update visual properties of a component using the current interaction state, like when the component is pressed or hovered using the new Styles API. You can dive deeper into this and other dynamic ways that Styles and Compose can make your app adapt to different device characteristics in the live talk about the new Style API. Let's also talk about stylus support. So last year, we announced the Jetpack Ink API. It's designed specifically to bring high-performance, low-latency inking to the broader Android ecosystem. Now in stable, the API helps you get set up by handling geometry calculations, accessing low-latency hardware compositor pathways, rendering with custom brushes, and even serializing your inking paths. We also have an open-source demo app which showcases how to make the most of stylus, Kaye, showing it in action. You can check it out on GitHub, and don't miss the dedicated recorded talk to help get fast, beautiful stylus support into your app. Finally, we need to talk about camera previews.
Absolutely. If I'm getting pastries and taking photos of them, I need the camera preview to be perfect and get the lighting and the angle just right?
So when we look at devices beyond phones, camera previews are one of the biggest sources of compatibility issues. They often appear stretched, cropped, or sideways. And this happens when apps assume a fixed portrait-only preview. It simply doesn't hold true all the time. The recommended solution is Jetpack Camera X. The Camera X viewfinder component is built specifically for adaptive apps, automatically handling the calculations for sensor orientation, device rotation, and aspect ratio. This ensures your camera preview looks correct. And if you're wondering about implementation, just hold that thought. In a few moments, we'll show you how we're making it simple to migrate to Camera X. You can learn more about Camera X and some of the new APIs in this recorded talk. And that was just a bunch of exciting new APIs and libraries, all to help you get ready for Android 17, with a lot of them giving you adaptive behaviors out of the box. Still, we know it's a lot to keep track of, which is why we're working on tools to make it as seamless as possible for you to integrate. One of the fastest ways is to use AI directly inside Android Studio. Iterate quickly from within the IDE as the agent helps you architect and build your app. One thing that's particularly relevant are specific Android skills we've been building. And skills are modular instructions to help LLMs execute best practices and workflows. The examples of adaptive focused skills that you can try are a views to compose migration skills. So this is the first step to getting your app ready for adaptive. Let Gemini do the heavy lifting. We've talked about the benefits of Navigation 3. If you're ready to update, we have a Navigation 2 to Navigation 3 migration skill. And for those stretched and squashed camera preview issues we mentioned, Camera X can fix them. And we have a Camera 1 to Camera X skill to have all those state changes handled automatically. So let's take a look at that skill in action. Camera 1 has been deprecated for years, but it's still used. Here's what a naive implementation looks like on a modern foldable. So you notice it's stretched and how elongated that glass puzzle piece looks. It gets worse as you rotate the device. The preview is not rotated, and the aspect ratio is still broken. So updating your viewfinder to fix this is not trivial. Depending on your implementation, you may need to manually handle camera lifecycle and juggle device configuration changes. It's easy to miss things like folds, window resizing, or external monitor events, and then accidentally get the geometry and sensor orientation calculations wrong. So you can watch our skill in action. Here we ask the agent to convert this Camera 1 activity to a Camera X using this skill. So the agent locates the skill, and it begins analyzing the project structure. If you're on Camera 1, you're likely still using views and maybe Java, so it'll utilize Preview View. If it detects a compose environment, it'll use the Camera X viewfinder. And now into my favorite part of the skill, which is what not to do logic shown here under constraints. We've baked in best practices into the skill like don't manage the lifecycle manually, don't forget to close the image proxy, and don't wrap the Preview View in Android View unnecessarily. When you look at the diff, it replaced the legacy surface view with a modern Preview View. It handled the lifecycle, and it also implemented some enhancements like tap to focus. So now let's see what that glass puzzle piece looks like. The camera preview is crisp, the aspect ratio is perfect, and most importantly, rotation, it just works. So just like that, you can modernize your viewfinder in your apps. And I'm realizing this could have been in Eclair. Yeah.
I know, missed opportunity, big missed opportunity.
These building blocks are crucial pieces of an adaptive app, and we're continuing to add more. In addition to these specific migration skills, we have created an overall adaptive skill that uses the recommended patterns and libraries we've talked about to update your existing app across any size screen. Beyond updating your existing app, we've also introduced a new project agent starting in Android Studio Panda to help build a working app prototype with just a single prompt. Every new project created with this agent is now optimized to be adaptive. So that was just a quick overview. There's a lot of power with these skills, and we have a full live talk about ways to use skills and other AI tools in Android Studio, so check that out. And following lunch, we have a talk specifically about using those AI tools to help make your app adaptive. So don't miss that, as there will be some great tips, demos, and examples.
So to close out, we want to talk about some other frameworks. If you're building a new Android app, or you're updating your existing views-based app to be more adaptive, Compose, Navigation 3, and all the tools we talked about today are the obvious choice. However, it's worth mentioning some other frameworks that can provide really great adaptive experiences. This can be especially important for those of you shipping on multiple platforms, and if you're looking at bringing your existing app to Android. I'm just going to touch quickly on 3 of them today, and let's talk about web first. If you have an existing web app that already looks great on desktop and mobile, it might be worth considering leveraging that existing code to get a jump start on Android. And some apps are doing this successfully already, like Canva, a top-notch digital content creation tool that's adaptive, it looks great across platforms. They use their existing desktop-compatible web UI and then plug right into the Android system APIs when it makes sense to provide really seamless user flows. The secret to doing this right and to making your cross-platform web experiences beautiful app experiences on Android is knowing when to plug into those Android system APIs and how to make that flow super seamless and when to just let things stay purely web. Check out this recorded talk all about that. Do you already have a desktop or mobile app built on Qt and it's not on Android yet? Well, if you're thinking about bringing that app to the billions of Android users out there, you're in luck because Qt can build for Android. A number of successful apps built on Qt are already providing top-notch adaptive experiences. Check out Steinberg's Cubasis 3, a full-featured digital audio workstation, or DJ, a DJ app that works on device or with foldables or MIDI controllers and fill those concert halls with your awesome beats. Or Krita, a community-driven drawing app that's popular with manga or comic artists. And for your information, the files for this comic, Carrot and or Pepper and Carrot, with all the layers and how the work was made is available on the website by the artist, so check that out if you want. And the third and final framework I want to mention is popular with cross-platform games, Unity. However, it's also used for a number of interactive and graphics-heavy apps, allowing them to share a unified code base across platforms. So if you're using Unity, you can build for Android. Just remember, mouse and keyboard support, and of course, as always, test, especially things like folds and unfolds and rotations and resizes, and of course, mouse and keyboard. So if you're starting out fresh, Android APIs are the best choice. However, if you have an existing cross-platform app experience, one of these pathways might be a quick way to get started on Android.
OK, let's recap. The value of investing in the Android ecosystem continues to grow. It's everywhere on a plethora of screens. And our stats show increased engagement time and spend for adaptive apps. When you think Android, it's time to think beyond the phone. Connected displays allow any phone to connect to a monitor with a mouse and a keyboard input. The next iteration of Chrome OS, Google Books, continues to provide a large screen mouse and keyboard experience that's more performant and powerful than ever. XR spaces are even larger and radically rethink app interaction. And now, with the orientation and resizability API changes in Android 17, is the right time to make sure your app is there. We've got your back with great new Jetpack libraries, updated guidance, new developer tools, better testing tools, and emulator. And with awesome skills and AI capabilities built into Android Studio, optimizing your apps is easier than ever. So with that, the both of us would like to thank you for being here with us and being on the forefront of Android development. And we hope you learned more about making your app adaptive today, or at least you're hungry for a pastry now.
Hopefully both, pastries and adaptive. Yeah.
Thank you.
Thank you.
Hi, everyone, and welcome to the 2026 edition of What's New in Web UI. This talk has become a bit of a staple here at I/O, and as always, there are a lot of exciting updates to talk about. I'm Yuna, a developer relations engineer who is leading efforts on web APIs that make the web feel like a more high-quality experience.
And I'm Bramus, also with Chrome DevRel, and I'm focused mainly on CSS-related features such as scrolling interactions, animations, and the intersection of both. And today we are very excited to talk to you about the latest updates to everything Web UI, from new capabilities for view transitions to natural gesture interactions, theming capabilities, and so much more.
For the past year, we've been focused on how can we actually improve the user experience of the web, and been focusing on shipping capabilities that make the web feel a lot more high quality while making it easier for developers to build for. This shift is about more than just aesthetics. It's about how your site interacts with your users, how they scroll.
I just wanted to check on if the stream is still going strong.
How they morph between views, and how they communicate with their devices in more physical and intuitive ways. As a guide, we've identified 5 core UX principles that frame the ideal modern web experience.
And those principles are these 5 right here. Respect user preferences, implement natural interactions, provide guided navigation, maximize content, reduce noise, and adapt to the form factor. Now, we'll dig into all of these principles and what they mean in this talk. We'll show you modern UI patterns that use new APIs to meet these principles, ensuring your layouts fundamentally adapt to the user, the device, and the input method.
And if that wasn't enough, we're also going to take a look at an entirely new paradigm for web development, HTML in Canvas. Some of you may have seen demos of this online, and it's huge. This allows you to bring real, accessible DOM content directly into your Canvas-based experiences, bridging the gap between high-performance graphics and the semantic web. It's time to raise your expectations of what the web can do. So let's get started.
Make sure you're comfortably seated because we're about to show you a whirlwind of features. We're going to show a lot of links throughout this talk pretty quickly, so get your phones ready to take some photos. And for every feature shown, we will include a compatibility table that looks like this. Shown at the left there is the baseline indicator, and that one indicates whether the feature is baseline widely available, newly available, or limited available.
Browser versions, when the feature became available, are shown inside of the circle. If the circle is green, that means that it's available in a stable release. Orange, if a feature is available in an experimental version. And red means that the browser currently has no support for that specific feature yet. So with that out of the way, let's talk about user experience on the web.
Our first principle here is one of the most fundamental for web usability, namely respect user preferences. This is all about building trust and improving accessibility by adapting to your user system level choices, whether it's honoring light or dark themes or automatically toning down animations when the user has requested reduced motion. And rather than requiring users to locate some obscure preferences menu somewhere, your website should already automatically adapt to their existing operating system settings. And even though these concepts feel elemental, and we've been talking about them for years now, there are actually a few new APIs out there that make this dynamic personalization easier to build for. For example, the light dark function, contrast color, and style queries. Let's take a look at an example.
In this demo, you see a few cars with different themes within the same global design system. In light mode, they use shadows as an elevation mechanism to make them appear above the rest of the page. In dark mode, the shadows are removed, and instead we see a neon border with a lighter background to show the elevation. And you can see the emulation of light and dark here being set in DevTools. This is a common approach in design systems, but it's still relatively complex to build today. But like Bramus mentioned, there are a few new APIs that are making this much easier. So let's get started with the first piece here, and that's an API that I'm really happy to see land, which is contrast color. This API recently shipped in Chrome as a part of Interop 2026, making it baseline newly available in all modern browsers. Contrast color is a CSS function that takes the value of a background color and returns either black or white, depending on which has higher contrast against the input color value based on the WCAG2 algorithm. It's currently limited to this contrast algorithm, but we hope that developers will have more options in the future. The function is also currently limited to outputting black or white, but in a minute we'll show you how to combine contrast color with style queries to really expand your color palette.
The next piece of the puzzle here is the light-dark function. And this function is a CSS utility that allows you to specify two different color values, one for light mode and one for dark mode, and it's all within a single declaration. By providing the light value as the first argument and the dark mode as the second argument, the browser automatically selects which color to use based on the current color scheme. And a recent spec change to light-dark extends it by also accepting images. Instead of passing into color values, you now can pass into image values, one for light and one for dark. And this change is set to land soon in Chrome 150, but if you already want to use this type of capability today, there is an alternative solution.
Yes, and that solution relies on two other CSS capabilities, CSS custom functions and style queries. When combined, you can create custom light-dark functions that work with any type of value. To make this work, you first need to store the color scheme value in a custom property like --scheme, as shown here on the left. By default, this is set to light, but when the operating system is set to dark, the value is set to dark. Then inside the custom function, shown here on the right, you can conditionally set the result to either the light or dark argument. By default, this is set to the light value, but again, when --scheme now is set to dark, the dark value is used. And this is done using a style query. Finally, similarly to how you would call the native light-dark function, you can now call your custom light-dark function without any limitation on the type of value that you use.
Now, as with all container queries, you are limited to styling a child based on a parent's value. But if you want to style the element itself, you can throw in a third new language capability into the mix, and that is the if function. And this function gives you a way to write conditional logic right inside of a property's value. If the reported scheme is dark, the result is set to the value of the dark argument, and otherwise the result is set to the light value. You can find out more details on add function and if by visiting the link or give episode 92 of the CSS podcast a listen.
And if you haven't heard the CSS podcast, definitely check it out. You might hear some familiar voices. So getting back to the original demo, let's combine all of these modern CSS capabilities, contrast color, style queries, and light dark, and bring them all back to customize our elevation style and color palettes. So here you can see that the elevation mechanism works using a function too, swapping between the shadow or neon glow, depending on the color scheme using the light dark function. The theme colors are set up using style queries, and the contrast color function is used to identify the ultimate color chosen. The result of that function is either black or white, so when you store that into a custom property, you can treat it like a Boolean and use style queries, shown here with the if function, to map the result to any value. CSS is getting really powerful. Contrast color enables you to separate the page's color scheme from the local card scheme, and style queries gives you the flexibility in the output value. So here you can have a lighter background on a card in a dark mode or in a light mode, but assuming that you've tested all the color pairs, you'll always have proper color contrast, making this theme quite dynamic. To give you even more control over your customization, the CSS working group recently resolved on adding an @supports query for @rules like @container, @property, and @function. You call it using the @rule function after @supports, placing the actual @rule string to check against browser support like @function inside of it.
A final detail when visiting this demo, and one that some of you will never even notice, is that this page respects the user's font size preference as set through the accessibility features of the operating system. It's a simple tweak, but one with a large impact, because recent data shows that over 30% of users both on Android and iOS have changed their default font size in the system settings. Now, to add this functionality to your website, there is a new meta tag named TextScale, and it's available in Chrome 146. If you set the value to scale, you tell the browser that your site can handle these increased font sizes. And when applied to font size of the HTML element is then determined by the operating system, so there is no need for you to set up a base font size. And if you then use length switch relative units like M and Rem, those computed pixel values are then based off of that base font size. So to test this out of building your website, there is an option in DevTools to emulate this. You can find it in the rendering tab and then use the dropdown to change the value.
Okay, now that we've talked about personalization and gone over some new architectural primitives in CSS, let's move on to our next principle, implementing natural interactions.
And by natural, we mean that you should make interactions feel intuitive and physical, not robotic. Motion should be meaningful, and the animation should originate from the point of interaction and use a physics-based easing. The goal here is to create tactile experiences that feel as natural as a native app. But what exactly does that look like, and how are we making it easier for you to build these experiences?
The first UX pro tip in this area is to use natural easings and physics where you can. Here's an example of a dialog that combines a few techniques to achieve a nice natural effect. While we don't yet have true spring animation effects and easings on the web, this demo uses the linear easing function to approximate a bouncy animation. This code might not look very human readable, but it allows a nice bounce effect with a slight overshoot by letting you customize an easing curve by providing an unlimited number of values, typically between 0 and 1. But you can also build tools to make this easier for yourself. For example, I built this quick linear easing generator to help me wrap my head around using the linear easing function and configure it with the language that other tools use for physics, like stiffness, damping, mass, and velocity.
The next thing you might notice with this demo are the entry and exit animations. The dialog here nicely slides up when it gets shown, and it slides back down when it gets hidden. And this is done using @starting style, set the pre-animation styles, and then the open attribute on the dialog to set the target styles. And the animation itself is done with CSS transitions and allow discrete. For more details on this, as well as like general best practices on timings and easings, go check out my talk from last year, which is called, I hit the wrong button here, yes, which is called Web Animations Today and Tomorrow. The talk covers starting style, transitions, CSS animations, and view transitions. And another nice detail in this demo here is the staggered entry effect of the content inside of the dialog. And this is done using the sibling index function, which returns a number that is equal to the position of the element within its ancestor subtree. So it's a number that counts up from 1 to however many siblings there are. And here, that sibling index is multiplied by 0.05 seconds to create the staggered delay on the animations.
Another piece that you may have noticed here in this demo is that it uses a modal dialog. And here's what that modal dialog might look like in a real-world context. When you show a dialog modally, you get a few key benefits. First, when the dialog is open, the rest of the page is inert, and focus is automatically managed. On state changes, screen readers can also correctly identify and describe the UI. As of Chrome 134, the dialog element has adopted some of the niceties of popover, including declarative light dismiss. This means that by using close by equals any when a user clicks outside of a dialog or hits the escape key or uses a back gesture, it will close without any additional scripting required. This is a very nice addition that prevents folks from reaching for a popover when really semantically they should be using a dialog. So now you can get all of these nice benefits for native browser native UI, declarative light dismiss, supported with native entry and exit animations, and it's all done in your CSS right along with the rest of your styling logic.
Finally, one last detail to highlight here are the beveled corners. And this effect used to require you to clip the element in CSS, which meant that you lost access to things like shadows and outside borders. But now we have a CSS property that makes this much simpler, namely corner shape. And corner shape does what it sounds like it does. It lets you change the shape of the corners of any element. And where before you could only do rounded corners, now there's a lot more options, including scoop, bevel, notch, and even the popular squircle. To use this, you still set the radius with border radius, but now you get so many more options, and the values are animatable as well. And this is just like one of these nice little things that make your UI feel much more unique, and also can be nice progressive enhancements from rounded corners.
Yes. Natural interactions are just the start of what you can do on the web to make your applications feel more high quality. And the next evolution of that is really thinking about guiding the user journey, helping them maintain context and understand the application's flow. In a digital space, users don't get the benefit of physical cues like walls, doors, or depth of field when they navigate. Without these, it's all just a series of flat pages connected through a single URL bar. Disorienting page reloads, losing your place when you hit the back button, and the jarring disconnect of staring at a blank screen while a new page loads all make for poor user experiences. And the sad thing is, we've all just kind of grown used to this. But it doesn't have to be this way. We've been working hard on making animation transitions smoother, upgrading view transitions, shipping new declarative streaming and routing capabilities, and even providing new primitives for helping your user navigate within your page scroller.
Yes, and view transitions are the perfect tool to create these seamless transitions, and it's a feature that just keeps getting better over time. Back in 2021, we announced the first prototype for what eventually became known as same document view transitions, a feature that is now baseline widely available since 2025. And we expect a cross-document counterpart, which lets you run a view transition between two different documents, to also be available in every browser engine this year thanks to Interop 2026. Now, don't let this browser support table stop you from adopting view transitions today. Google Search, for example, is already heavily relying on view transitions, and they are treating it as a progressive enhancement. And here's one of their experiments that uses view transitions linked to gestures when the bottom sheet is getting dragged. Instead of having the view transition animation stick forward using Worklog time, they are instead controlled by a drag gesture. And furthermore, the search team has also optimized these animations so that they can be harder accelerated. Pretty sweet, right?
I like this a lot. It's pretty cool. So to let you easily build advanced interactions like this yourself, my colleague Brahmas here has created a convenient utility library called the View Transitions Toolkit. This toolkit contains a bunch of helper functions for creating view transitions interactions. For example, one of the functions provided by the toolkit is a function to optimize a keyframe for a view transition group pseudo. When applied, the group pseudo animates using a scale and translate animation instead of the default width and height animation created by the browser, enabling you to build hardware-accelerated view transitions. The result is an animation that isn't subject to jank whenever the main thread gets blocked. Another set of functions from the toolkit are the play, pause, and scrub functions. If you use those in, let's say, scroll event listeners, you can build a scroll-driven view transition like the one shown in this demo. You can get really creative with this. Combined with pointer down, pointer move, pointer up, you can build a draggable view transition. Or maybe you want to sync a view transition with a video playing. Why not? That's all possible. So check out the toolkit's homepage for more demos to inspire you and documentation to explore.
A new sub-feature of view transitions, and one that I personally find very exciting, is the addition of element-scoped view transitions. Instead of starting a view transition that covers the entire document, you can now start a view transition on a subtree of the DOM while keeping the rest of the page interactive. Yes, you are hearing this right. After 4 years of talking about it, we got all the necessary foundations in place, got all the details sorted, and we have shipped this in Chrome 147. And this demo right here extensively relies on element-scoped view transitions. When adding one of the cards to the selection list, a scope transition is started on only the sidebar, meaning that I can still hover and interact with other cards while the animation is running. Or when filtering a list of items, a scoped view transition is started only on the grid, while other elements such as the navigation bar and the dropdowns also remain interactive. So to start an element-scoped view transition, it's really easy. Instead of calling document.start view transition, you now call start view transition on a specific element. And the result here is a view transition that runs in isolation. It only scans that subtree for elements with a view transition name, and the resulting view transition pseudo gets injected only onto the scope root itself without blocking the rest of the page. And additionally, the group pseudos are automatically nested, and the overflow of the enclosing group children pseudo is clipped when needed.
What enables this isolation, yeah, this is a big deal, honestly. What enables this isolation is the effective application of view transition scope all to the scope root for the duration of the transition. And this is done automatically for you when starting a scoped view transition on an element. This declaration ensures that view transition name values don't bleed out of the scope root subtree, and it also prevents an element from being captured by an outer view transition. This allows for multiple view transitions to run at the same time, as well as the nesting of view transitions. So while the items in these lists are getting shuffled, you can also swap the lists themselves, which is pretty cool. Scope view transitions are perfect for micro interactions and in-page stateful morphing, giving the user more context when there is a visual change. This is a great way to enhance the usability of your application while also elevating how it looks and feels. These are the little things that make a big difference. And it's so much easier to do this now with view transitions, especially scope view transitions, and a little bit of CSS. It really does feel like magic sometimes. Check out our article on developer.chrome.com for more information about element scope view transitions.
And we're not done with view transitions yet. Something that Chrome Engineering is prototyping right now is a feature called two-phase view transitions. And these allow you to immediately kick off a cross-document view transition without waiting for the new DOM to be ready. And to do this, the two-phase view transition will first transition into any kind of intermediary UI, such as a skeleton screen or a loading spinner, before proceeding with the cross-document transition. Now, the API is still in heavy development, but if you can't wait to get a feel of it, you can try it in Chrome Canary with experimental web platform features flag enabled. And check out the link for more info, of course.
There's so many great updates. I definitely wanted that for a while. Another way to provide guided navigation for your users is by using scroll-driven animations, a feature that landed in Chrome in 2023 and is on its way to becoming interoperable thanks to Interop 2026. To jog your memory with scroll-driven animations, the animation's progress is linked to the scroll position of a scroll container. This means that as you scroll up or down, the animation scrubs forward or backward in direct response. You can use this for effects like parallax background images or reading indicators that fill in as you scroll. And this feature is directly improving performance for some of our partners already, like Cybozu, who cited that they were able to improve performance and decrease the main thread cost of handling scroll events by 73% by using scroll-driven animations.
New in Chrome 145 are scroll-triggered animations. And these are time-based animations that trigger when entering or exiting a specific scroll range. And scroll-triggered animations are great for building storytelling experiences, as they transform a passive reading habit into an immersive, interactive journey that keeps the user physically engaged with the narrative. And we see this type of experiences all over the web. And now, because yes, we built this into CSS, you can say goodbye to Intersection Observer or any third-party library for this type of effect. And the underlying mechanism here are timeline triggers, which are either active or inactive. In this code snippet, the trigger -d is created, and it's using a view timeline with two ranges. Now, when I flip on the visualizer, it becomes a bit more obvious what's happening. The first range is the activation range, and it determines when the trigger should become active. And then the second range is the active range, which determines how long it should remain active. And this trigger is then used as the animation trigger for a regular CSS animation. And here the animation is set to play forwards when the trigger becomes active, and the animation will play backwards when the trigger no longer is active. To learn more about scroll-triggered animations, the activation and active ranges, or to check out some more demos, go find our article on developer.chrome.com.
Another common pattern to help users keep track of where they are on a page is this so-called scroll spy. This pattern, popularized by Bootstrap, automatically updates the navigation links based on the user's scroll position to indicate which link is currently active in the scroll port. Typically, this has been implemented in JavaScript, but as of Chrome 140, you can do this with just 2 lines of CSS. Similar to the JavaScript implementation, you start off with a set of in-page links that link to specific subsections of your DOM through IDs. But instead of throwing a bunch of JavaScript at it, you enable the scroll spy by setting scroll target group to auto. Whenever one of those sections is visible inside of its scroll port, the ARIA current on the corresponding link is automatically set to true, and they get the target current pseudo class applied to them. which allows you to style them however you want. With target current as a styling hook, you can pretty much do anything, like adding a little anchored pointer to guide users or simply styling the typography of the active section.
When offering guidance for in-page navigations, it can also be useful to use smooth scrolling. You can do this in CSS with scroll behavior smooth, or you can also use JavaScript scroll into view. And new to scroll into view is an option named container. If you set it to nearest, it only scrolls the target element scroller instead of bubbling up through all ancestor scrollers. And in this demo here, you can see it in action. Whenever I press one of the dots, it calls scroll into view. But as you can see, it also scrolls vertically, which is a pretty much disorienting. Now, when I flip on the nearest option, you can see that it now only scrolls the horizontal scroller, which results in a much better experience. And speaking of scrolling to view, again, a new addition to the platform, and one that is available now in Chrome, is that all programmatic scroll methods now return promises, so you can await them. And here's a demo. The element is first scrolled into view, after which a highlight effect is added to it. And with that, it's a wrap for this third principle on guided navigation. On to the fourth one.
And this one is all about reducing noise and clutter. One thing that can ruin an otherwise awesome web experience is just too much clutter. Even if you've done everything else right, awesome morphing transitions and beautiful theming, if I see a content blocking pop-up when I first land on your page, there's a pretty decent chance that I'll just click away. And this is a big problem on the web. So this principle is focused around a more focused user experience, pun intended. Prioritize the user's content by eliminating visual clutter and application borders, avoid intrusive pop-ups and banners that obscure the screen, and use layered UI patterns for secondary content. There's a lot that you can do here. And the first one is one of my current favorite progressive enhancements that I immediately shipped on my personal blog when it became available.
And that would be the new scroll state query named scrolled. And this state query lets you detect the direction of the most recent relative scroll. For example, if you last scroll towards the bottom of the scroller, the reported value would be bottom, or the logical variant block end. And this scroll state query allows you to build a pattern that we like to call the hidey bar. When you are scrolling or have scrolled towards the end of the page, you want the header or navigation bar to hide itself. But only when you're scrolling back up the page again, you want the header to reveal itself again. And the code behind this demo looks like this. First, it sets up a scroll state container on the HTML element. By default, the header is visible, but when you scroll down, it gets placed out of view using that scrolled state query. And lastly, the animation part is handled by a regular CSS transition.
Another example of how to optimize the content area for users is to move secondary content and actions behind layered UI. And these could be dialogues, off-screen menus, tooltips, and for additional context, and more. But we also need to make sure that we build these things right. And even just purely visually, there's a lot of considerations that are involved in getting it right. So take a look at this tooltip. In this example, we have an anchor position popover, which repositions itself based on its fallback position and its position in the viewport using anchored container queries. When the tooltip is open above the invoker, it animates bottom up from the source. When it is open below the invoker, it animates top down. But that's not the only change we see. The arrow that visually connects the tooltip and its invoker also changes position and direction. This arrow is created using the new shape and border shape APIs. To create the arrow at the bottom center, it looks a little something like this, which, like the linear easing function, is a little hard to wrap your brain around. So to help me build the code for this demo, I also vibe-coded a tool to produce the output shape that I expected for the border shape. This is just a visualizer for how much you can do with shape and border shape. It lets you change the visual geometric border of any element and remain responsive. Border shape is really powerful. You can create all sorts of shapes, not just at the corners, like corner shape, but anywhere, inset or outset, and have the border, outline, shadows, all visually aligned, something that you couldn't do with clipping masks and goes way beyond what you can do with just corner shape. And as a bonus, as of Chrome 149, another neat thing that you can do with shape is use it as a value for the shape outside property. So you can create organic, geometric, non-rectangular UIs and boxes which content can float against. And it supports animation, both in shape and shape outside.
I like this. Now, when maximizing the content of a big data table, you also want to respect the guided navigation principle. And a common approach for this is to make use of sticky positioning for a sticky column and a sticky top row. But if you ever try this, it doesn't work. That is because either the column or either the row here will only be sticky, so it's one of both. And this is because position sticky only looks up the nearest ancestor scroller for the sticky container. Now, if that scroller only scrolls on one axis, like here it's only scrolling horizontally, that would prevent the stickiness on the other axis from working. Now, a recent change to CSS makes this now possible, as position sticky can now track two different scrollers, one for each axis. And this change is available for testing in Chrome 148. And the visual outcome is a sticky first column and sticky first row that now work as expected. The first column sticks to the left of the page, and the top row there sticks to the top of the page. Now, one thing to note here, that in order to make this work properly, is don't just set overflow X on the wrapping element to scroll or auto, because overflow Y will then also compute to auto, so you would end up with a 2D scroller. And the thing you must do here is explicitly set the other axis to clip its contents, and then it'll work.
What we often overlook as web developers is the form factor from which our users access our websites or apps. So our final principle is all about adapting to that form factor. We design on a desktop, code on a desktop, and resize the window to appear smaller on a desktop while we test our mobile designs. And this gets us part of the way there, but it doesn't really cover everything. And one thing that it doesn't quite cover is the modality with which users interact with the UI. So on desktop, that might be a keyboard or a mouse, but on mobile devices, that is often usually through touch. And while on a desktop, we're used to clicking on a little button to open and close a menu. On a mobile device, looking for that little icon button just becomes cumbersome when we're so used to being able to swipe something open and closed. Layouts should fundamentally adapt to the device and input method too, whether that's a virtual keyboard that's open or even just to touch target sizes.
And currently, building a gesture-driven interface is a hassle to implement on the web. You need to add a bunch of event listeners for both the mouse but also the touch interactions, but then those sometimes compete with the native scroll gesture, so you need to figure it out as well, and then some more code to build in scroll momentum and snapping back again. It's a lot of code and a very uncanny result. But now we have a new API in the works that is making all of this a lot easier, and it's called overscroll gestures. It leverages the existing principles of scrolling and overflow areas, and it allows you to declaratively create gesture-driven interfaces that feel as natural and intuitive on the web as they would on any app you use. And one of the benefits of using overscroll areas over adding these event listeners is that this API works with any input method, touch or scroll, and it feels native to the platform you're using it on.
Let's take a look at a common example, an overlay menu. You click a button to open and close it, but on touch devices, it should just be easy to swipe it closed. The activation mechanism here is via an HTML attribute. But given that this API is a work in progress, the exact code might change over time as the feature progresses. First, the container needs to be identified as supporting overscroll areas by adding the overscroll container attribute. Then you will use a command like toggle overscroll on a button, like so, to trigger the toggle open event. The button requirement is also something that is currently in discussion, but enables the input to be accessibly tied to an event invoking element. You would then connect this to an element inside of the overscroll container using its ID, in this case, menu, and the command for attribute. Command invokers are really powerful, and it's a pattern that I like seeing expand to new web platform capabilities. Finally, with a bit of CSS, you can position the overscroll elements. So here, the menu is positioned to the left of the content. So that's really it for the core of how to make this work. Now the overscroll API will take care of the rest. We have a light dismissible, swipeable modal menu that can be triggered either from a button or from a user's scroller swipe. So it's pretty dynamic.
And in case you're wondering, yes, this API also comes with a few JavaScript lifecycle events, including events for when the overscroll interaction starts, changes, ends, or is cancelled, and this allows you to create more complex interactions. The API is still a work in progress, but we're excited to hear your feedback on it as it evolves. So if you want to participate in the conversation, head over to OpenUI and peruse the open issues, providing your thoughts online or join us in person.
And if you thought that all of that new CSS and HTML was game-changing, then hold on to your hats, because this next feature is one of those rare moments where a new capability really shifts the paradigm of what you can do on the web. If you've ever built anything in an HTML canvas, whether that's a shader with WebGL or even an infographic, then you know that the canvas is essentially a black box to the browser. It's not parsable by the page that it lives within. But now, for the first time ever, you can have real DOM content inside of the canvas with the new HTML in Canvas API. Yes, this means real elements in your canvas that are searchable, accessible, selectable, translatable, and inspectable. And that also means that everything that we just walked through in this talk is also available in Canvas. This means that you can create entirely new types of UI where you no longer need a DOM overlay for accessible content, or you can create forms within Canvas. You can apply WebGL filters to text that you can interact with as their real UI elements, and you can keep that text highlightable, copy-pastable, and even preserve forms that work with built-in browser features like autofill. The community has already been creating some incredibly creative demos with HTML and Canvas, like this 3D web page by Santiago Colombato, and these fun wobbly button effects by Wes Voss. Popular libraries like 3JS also have already implemented native support for HTML and Canvas primitives, too. This feature is a big one. It means an entirely new way of building web experiences that fuses shaders and semantics. Even a simple button or a slider like this one can be taken to the next level. The possibilities really are endless, from 3D web UI to incredibly detailed shader effects and interactions, to making your 3D game accessible and translatable by the browser. We've got a bunch of demos from our team live now on chrome.dev/HTML in Canvas, where you can try it out yourself.
Let's take a look at some code to get you started with HTML and Canvas. The first thing you need to do is to set the layout subtree property on the Canvas element you're painting into. And this causes the browser to be aware of the content inside of the Canvas element. It lays them out, sets them up for hit testing, and exposes them to systems like accessibility and other browser features. Putting the element in the markup is not enough, though. Inside of the paint event, you need to draw the element in the canvas by calling drawElementImage. And the result you get back from this is a transform, which you then write back to the styles of the element. There are equivalent methods for WebGL and WebGPU to paint these elements into textures, as there are so many more things you can do with it. This API is definitely worth checking out and getting your hands on because it is so cool. You can learn more about it from this virtual session on HTML and Canvas by our colleague Thomas. And as Yuna mentioned, be sure to check out chrome.dev/HTML and Canvas for more demos.
Before we wrap things up here, there are a few additional features that are so good, we wanted to give them their own little moment here at I/O. So let's do a lightning round. Who doesn't love a lightning round? Are you ready, Promise?
Yes. The first feature we want to highlight here is the DOM state preserving move. When you move an element in the DOM using insert before, you are performing a destructive action. For example, moving a playing video in an iframe using insert before, they reload and they lose their state completely. And that changes with move before, which got added to Chrome in Chrome 133. You use it exactly like insert before, but the key difference is that it keeps the content alive during the move. So this means that videos keep playing, iframes don't reload, CSS animations don't restart, and input fields keep their focus as you are reparenting them in the DOM.
Another neat feature coming to Chrome soon is fit text. This capability unlocks the ability to precisely fit lines of text to the exact width of their containing element. This feature dynamically scales the font size itself, ensuring these text lines are seamlessly aligned with both the left and right edges of the container. In this case, we're using the grow value to allow the lines of text to increase in size to have a visually balanced and justified appearance through size scaling, rather than just flowing onto the beginning of the next line.
Next up is text box, and this property lets you tailor the space above and below the text, designed to help you center text vertically. The text box trim property specifies which side to trim, above, below, or both, and the text box edge property specifies the metrics to use for that trimming.
A feature that was built by Microsoft, shout out to the Edge team, and that is available in Chrome 149 are gap decorations. These allow you to style the gaps in container layouts like Grid and Flexbox. No more messing with borders or pseudo elements to style the rules between the rows and columns anymore. Instead, you can use the row rule and column rule properties to do so. You can give them a width, a color, an inset, a style, and so on. Check out the new blog post on developer.chrome.com from their team to learn more.
On to scroll bars. As of Chrome 145, the viewport units are now scroll bar aware, so you can say goodbye to unnecessary horizontal scroll bars when using a value like 100 VW. Lengths using the VW now automatically subtract the size of the vertical scroll bar, but only under the condition when a scroll bar or its color is guaranteed to be visible on the root element. And you can force the scroll bar by setting overflow Y scroll on the root, or reserve space for it using a scroll bar gutter stable declaration. And of course, the same applies to VH lengths with a horizontal scroll bar, as well as the large, small, and dynamic viewport units.
Lastly, pseudo elements are finally getting exposed properly in JavaScript. JavaScript events like click now expose an extra property with information about the pseudo element that triggered the event. If you read the value of the event.pseudo-target, you get back a CSS pseudo element instance, or null if there was no pseudo element involved. You can also get access to pseudo elements using element.pseudo. I'm happy this is finally coming to the web.
And that's it for this lightning round. So that's it for this lightning round. The features we mentioned here are only a selection. You can expect many more features to come to Chrome throughout the year because our engineers keep pushing the web forwards. And currently, they are actively prototyping features such as a native menu element, filterable select elements, responsively sized iframes, and tweaks to scroll access locking, and so on. So yeah, there's a lot more good stuff coming your way this year.
Yes, it's such an exciting time to be a web developer. You can create, well, pretty much anything these days. So when in doubt, remember the principles that we just went over, and remember how much you can do with the web. Respect user preferences, implement natural interactions, provide guided navigation, maximize content, reduce noise, and adapt to the form factor.
And speaking of the time speed, we'd be remiss not to mention the tooling we've been working on to make it easier for you to adopt these latest and greatest modern web capabilities. And that's why we just announced Modern Web Guidance. It's a curated collection of skills, tools, and AI-ready documentation that injects Chrome's web platform knowledge directly into your AI workflow.
These guides are internally tested, benchmarked, and adhere to modern best practices. They integrate with baseline data and include all dedicated fallback recommendations, so your agent can implement modern CSS, HTML, and JavaScript in a way that is compatible across browsers without you having to do all of the research yourself for every new feature. This is just going to save a lot of time for everyone, I think. And as usual, to learn more about Modern Web Guidance, check out the link here or the video on the Chrome for Developers YouTube channel. I know that was a lot of links and resources that you might want to dig into now after this talk, so let's wrap it up.
We are very aware that throughout this talk, we've shown you a ton of resources to dig into here, but that's only because the modern web gives us so much to work with. So there's so much to love about what we can build today. And the best part is, you already have the tools to create these amazing experiences faster than ever. So take these resources, get out there, and go make some magic.
Yes, we can't wait to see what you build. Thank you so much.
Hi, I'm Cameron, and I'm the product lead for the Go programming language at Google.
And I'm Mark, the developer relations lead for Go.
For decades, developers struggled with a difficult trade-off. You could choose productivity using dynamic interpreted languages like Python or JavaScript that are fast to write but often struggle with scale and reliability. Or you could choose production readiness using strongly typed compiled languages like C++ or Java that offer raw power but come with significant complexity. This was the exact challenge Google faced nearly 20 years ago when Robert Griesemer, Rob Pike, and Ken Thompson sat down at a whiteboard to see if there wasn't a better way. Together, they created the Go programming language. And today, millions of developers don't have to choose between productivity and production readiness. They can have both. But in the era of AI, does this challenge still matter? The truth is, AI has only made these fundamentals more critical. Languages that are clear for humans are also better for AI models, and again, for the humans who verify their output. And as AI accelerates the volume of code we produce and put into production, making it easy for both AI and humans to write more secure, performant, and maintainable code matters more than ever. Go is boring, in the best way. But what really makes Go different from almost any other programming language is that it's not just a language, it's an end-to-end platform for software engineering. Software engineering happens in teams. It's the act of collaborating with others, now including both humans and AI, to design and implement durable systems that evolve over time. Programming is a part of software engineering, but just a part. Go was built to serve the whole of software engineering through a robust end-to-end platform with deterministic tooling all around the software development lifecycle. This broader objective is also why we prioritize simplicity, performance, security, and reliability. These principles are the foundation for building systems that remain maintainable years or even decades after the original author has moved on. Today, we're going to show you how we're evolving the Go platform while continuing to fulfill these foundational principles. As you'll see, nearly 20 years after its start, Go continues to make significant industry-leading improvements to productivity and production readiness. Off the mark to get us started.
Thanks, Cameron. Go releases major updates twice a year, in February and August. In the last year, we've released a lot of exciting new features in 1.25 and 1.26 to help you and your team be more productive. All languages evolve over time, and as they do, older code can feel less idiomatic, less readable, and harder to maintain. This can also affect new AI-generated code, as newer features and patterns are less prevalent in training data. To combat this, we've rebuilt the go fix command to enable continuous modernization. Go fix leverages the Go analysis framework to deeply understand your code and apply deterministic changes, leaving you with code that takes advantage of the latest language features. The centerpiece of this new engine is the Modernizer framework, which enables code transformations that prioritize correctness, ensuring the updated code preserves the original behavior. GoFix includes over 20 modernizers today to help keep your code clear and readable. GoFix can help when your own codebase evolves too, thanks to the power of the source-level inliner. Just add a GoFix inline directive to your deprecated API, and GoFix will replace calls to that function with a new implementation all across your codebase. Thanks to insights from the Go compiler, GoFix can preserve the original behavior of your code even when there are side effects. GoFix can help you speed up API migrations so you can remove deprecated methods sooner and keep your whole codebase cleaner. At Google, GoFix usage has resulted in over 18,000 committed changes across Google's internal codebase, bringing modern Go features to one of the oldest Go codebases. One of Go's core ideas is that source code should be easy for machines to read, write, and edit, to support automated refactoring. This idea led to Go's easy-to-read syntax and standardized formatting, and continues to inspire our work on GoFix and modernizers. This very principle has come full circle to supercharge AI code authoring and unlock sophisticated source tools like modernizers that operate at scales we could only imagine when Go started. Next, let's talk about one of Go's most celebrated testing features, the testing sync test package, which graduated to general availability in Go 1.25. Concurrency is naturally complex because operations can happen out of order. As a result, testing concurrent code is also complex, often relying on timeouts or sleep calls, which can lead to flaky tests. Sync test dramatically simplifies testing concurrency by introducing the concept of a bubble, an isolated environment where Go routines use a fake synthetic clock. Within a bubble, time advances automatically when all Go routines are blocked. This test used to wait 5 seconds for a timeout, but with sync test, it finishes in milliseconds, deterministically and consistently. Sync test makes it simpler to adjust the order of events in concurrent tests and ensure that all Go routines finish by the end of the bubble. Go is intentionally boring. We rarely make direct language changes, so code in Go 1.26 looks nearly identical to code from Go 1.0. In Go 1.26, we've made a small but very high impact change to the language itself, new expression. Go users notice some awkwardness in dealing with deep structs that make heavy use of pointers, a common pattern in data interchange formats like protobuf. In response, we've expanded the new built-in, allowing it to create pointers from expressions, including basic data types and function return values. Some users and libraries have created their own helper methods to accomplish the same result, for example, proto.string. Circling back to GoFix and modernizers, in many cases, GoFix can identify these helper methods automatically and replace them with calls to new instead. These tools work together to ensure your codebase stays modern, readable, and most importantly, correct. But writing the code is only half the battle. Next, Cameron will show you how we're making that code perform better than ever in production.
Mark just walked you through some of the new features in Go 125 and 126 that make you more productive. But remember, Go isn't just about productivity. It's also about how that code performs in production. Go was built to solve Google-scale problems, so it's no surprise that Go has become the backbone of the modern cloud. Many of the world's best-known cloud technologies are written in Go, including Kubernetes, Docker, Terraform, and more. This ubiquity is a direct consequence of Go's enduring focus on production readiness. And part of what enables us to pursue that focus is Go's compatibility promise, a formal commitment from the Go team that code written to the Go specification will continue to compile and run correctly without changes across all future releases of Go. Because of the compatibility promise, many of these things get better from version to version with almost no work. You upgrade, you recompile, and your system is simply better. In other ecosystems, as code ages, it becomes a liability. In Go, it becomes an asset. If you do need to change your code to realize a new feature or benefit, GoFix, which Mark showed you earlier, will do that for you. With that in mind, let's go over some of the ways we've improved the platform over the last few releases. This year, the biggest headline for performance is the new Green Tea garbage collector, introduced as an experiment in Go 125 and enabled by default beginning in Go 126. Green Tea is a major departure from traditional garbage collector design that moves beyond the hardware-imposed limits of traditional algorithms. Green Tea operates by shifting the fundamental unit of work from individual, scattered objects to large, contiguous memory blocks called pages. This works with modern hardware design instead of against it, minimizing high-latency memory fetches and letting the runtime use incredibly high-throughput vector acceleration. The result is a 10% reduction in garbage collection CPU costs for most applications and up to 50% for those with complex memory layouts, all without changing a single line of code. Green Tea is an evolution of our runtime designed to leverage modern multi-core systems more effectively. It's also a brand new foundation that unlocks previously impossible opportunities for transparent optimizations, like NUMA awareness in modern server CPU architectures. In a similar vein, in Go 125 and 126, we introduced runtime optimizations that shift significantly more memory allocations from the heap to the stack. Stack allocations are considerably cheaper and present no load to the garbage collector. They also enable rapid reuse and have better cache locality, resulting in faster memory access. Another transparent win. Again, you don't have to touch your code to get it. But we aren't just making existing code faster, we're also opening doors to new types of workloads. In Go 126, we've optimized the transition between Go and C, making C Go calls 30% faster. For any high-performance systems that rely on low-level system APIs or specialized hardware libraries, this significantly reduces the cost of crossing that boundary, which makes possible new use cases in areas like machine learning, gaming, and graphical user interfaces. In other words, we've changed CGO from a tool of necessity into an opportunity to build entirely new classes of applications. We're excited to see what you do with it. Looking closer to the metal, in Go 126, we've introduced first-class support for SIMD. SIMD enables modern CPUs to perform vectorized array manipulations, running certain kinds of loops in parallel. These capabilities are essential for many kinds of performance optimizations, including the sort required for certain kinds of AI infrastructure. In fact, we're using SIMD ourselves to make the green tea garbage collector even more efficient. And speaking of AI, last year we launched an official SDK for the Model Context Protocol, or MCP. MCP allows your services to provide context and tools for LLMs through a unified protocol. With this SDK, you can reliably leverage Go's signature capabilities to expose data and functionality to your AI applications. We're using our MCP SDK to build servers that expose more of the Go toolchain to agents and AI-powered development tools. You may have seen a prototype MCP server in Go Please, our language server, and you can expect to see more in the year ahead. Next, we've made observability more ergonomic with the new flight recorder. Tracing can be expensive, so the new flight recorder allows you to keep tracing always on in a ring buffer, only flushing it when you need it, giving you the data you need with minimal production overhead. Finally, we're keeping Go secure for the next decade with expanded post-quantum cryptography, randomized heap-based addresses, and improved FIPS 140 support. These sorts of proactive security features are how we stay well ahead of the curve and how we ensure that Go can continue to be used in the most critical workloads. And there's lots more that you can read about in our release notes on go.dev. Together, all of this continues our focus on keeping Go both productive and production ready. And as we do all this and more, you can rest assured that any changes we make now and in the future will continue to fulfill the Go promise of compatibility. Go remains and will always remain fully backward compatible to Go 1.0.
As you just saw, Go remains laser-focused on improving productivity and production readiness, continuously adapting it to the changing needs of software engineering and the workloads we create. After all these years, we're still delivering monumental, groundbreaking improvements. How do we do it? Well, we do it together. Today, our ecosystem is larger and more robust than ever, and we continue to see a lot of really high-quality tools and libraries emerge, especially for new use cases around generative AI. And we see hundreds of thousands of Gophers around the world meeting up, attending Go conferences, and collaborating online, all because they love Go. So thank you to the Go community. It's because of your contributions that Go is growing and bigger than ever before. We're very proud to be a part of this journey with you. For more information on anything we discussed in this video, be sure to check out our homepage at go.dev. Thank you for joining us this year at Google I/O. We can't wait to see what you build with Go this year and in the years to come.
Hey everyone, welcome to What's New in the Gemma Open Model family. My name is Olivier, I'm the product lead for Gemma, and today I will be joined by Gus, a product manager on our team, and Jan Valentine, our developer relation engineer. So, what is Gemma? Gemma is our open-weight large language model at Google DeepMind. We started Gemma in 2024 with a simple premise. How do we create a model that you can run everywhere and fully customize to your need? That created two requirements for us. Number one, make sure that the model is reasonably sized. Number two, make an open-weight model that you can fine-tune to your will. With Gemma 3, we did exactly that. We created a multi-model family of model running from IoT devices at 1 billion parameter to larger consumer GPU at 27 billion parameter. And we made sure to apply one thing which is part of our philosophy, aka give you the highest efficiency possible running on your local machine. And a couple of weeks ago, we announced Gemma 4, our most capable open model to date. Thank you. We apply the same philosophy with Gemma 4, giving you 4 model size ranging from 2 billion parameter to 31 billion parameter that you can run everywhere. You want to run at the edge on IoT devices, use a 2 billion parameter model. You want to run on a higher end phone or lower end laptop, use a 4 billion parameter model. You have a more powerful machine and you want the highest efficiency and latency, use a mixture of expert at 26 billion parameter. Finally, you're looking to fine tune and have the highest quality possible. We have a 31B ready to go. And we maintain our philosophy around efficiency. Our Gemma model, here evaluated on LM Arena, are scoring as well as model 20x the size. We want to make sure that you have the best bang for the buck, the highest amount of intelligence per watt. Our models are highly efficient by training. As you can see on the right-hand side, we've improved Gemma 4 capabilities across the whole spectrum, from text use case, creative writing, code, or reasoning with science, legal, and so many other areas. The reception so far has been fantastic, and we cannot thank you more. We have more than 100 million downloads. We had more than 6 million downloads of the AI Edge Gallery, which you can demo outside, and the reception has been, again, incredible. We are very, very happy to see that people are using and enjoying the Gemma 4 models. In terms of capabilities, we've changed a couple of things compared to Gemma 3. Now, our models have a larger context window. We moved from 32,000 tokens to 128,000 for smaller size, up to 256,000 for 31B and 26B. Now, all of our models come with both reasoning, aka thinking, and function calling, making them fully ready for the agentic era. Finally, we changed our license. We moved away from a custom Gemma license to a popular Apache 2.0 license, giving you full control when you deploy in production. We know that the Apache 2.0 license was very well received, and we're very happy. We want to see Gemma being used more in your pipeline. In terms of capabilities, I want to highlight a couple of things. On the vision side, because we know our models are being used at the edge, we made sure to give you the highest amount of efficiency. We have now variable aspect ratio images and vision understanding. We can process charts, document, and screenshot better than ever, and we have multimodal translation being built from the ground up. On the agentic side, our models are fully ready with multi-step planning, tool use, and autonomous task completion. You can now use them in whatever agentic pipeline you have ready to go. Finally, audio understanding on the smaller size has been completely redone from the ground up. We are more than ever multilingual in essence with speech understanding and have good transcription and translation capabilities. Of course, text understanding, we have that since Gemma 1. We continue to be state-of-the-art in English when it comes to our main Gemma family. And we've extended that across like internationalization, which is something we'll cover after. From a vision standpoint, a couple of things to highlight. We have object detection. We can do bounding boxes, which is quite important if you want to use Gemma in IoT use cases or robotics use cases. And again, as I mentioned, we have multimodal translation from image input, and we'll show you more demos like in the rest of the presentation. Gemma comes with multiple architecture ready to go for where you want to deploy them. If you want to push Gemma at the edge, we have per layer embedding, which is a new technique we've developed for Gemma 4 to optimize efficiency. If you want to deploy them on your laptop, we have two types of architecture, a 31-bit dense, which is going to make fine-tuning easier and help us like get the highest amount of intelligence per tokens. The other one, per parameter, sorry, and the other one is a 26B MOE, giving you the highest efficiency in terms of runtime. From a benchmark standpoint, I don't want to spend too much time there. Please go and try the Gemma model and see if they fit your use case. What I want to point your attention to is the capability of a Gemma 4 E2B model compared to the previous generation at 27B. Our 2B model this cycle is matching or even better than our 27B last year, and that makes me very excited about the future. I'd love to see if next year we're able to give you the 31B capabilities in your pocket running on your phone fully locally. I think that makes up for a very exciting future. Now, I've talked about multilinguality, and I wanted to show you that it means a lot to us. On the left-hand side, you can see Euroeval, which is an independent benchmark leaderboard where the model is being rated across like European languages. And what you can see there is that all of our Gemma models are scoring pretty well. Our 31B specifically ranked from between number 1 to number 5 on almost all European languages, and that is across open source and closed source model. On the right-hand side, you have another example where we're comparing Gemma to other very successful models on Japanese languages, and our Gemma model is getting very close to GPT 5.4. We have very strong compatibility with Southeast Asian language, and Korean is another language where we excel at. Now, another benchmark, which was quite amusing, food truck bench. So I didn't know this one before releasing Gemma 4. It's actually like measuring the reasoning capabilities of the model as well as the function calling. And we found out that the 31B is, to quote the line, a beast at that. The model is doing extremely well in an environment where you need to have deep reasoning, and I would say reasonable function calling. As you can see here, Gemma 31B is competing with DeepSeek V4 Pro, which is a more than 1 trillion parameter model and lots of top-line closed source model. In terms of efficiency, as I mentioned to you at the beginning of our presentation, we want to make sure we give you like the best bang for the bucks, and LM Arena has done a couple of analysis on that front. We've also released MTP Drafter enabling speculative decoding on a model lineup, giving you up to 3x speed up when it comes to your decode speed. So if you haven't used it yet, I would massively recommend you to move towards MTP and gain the highest efficiency performance on your Gemma implementation. Now, again, Gemma being fully open weight and compatible with the open source ecosystem, we have support across the board. We are supported from a mobile and web app standpoint. You also have all your favorite softwares ready to go with Gemma 4 on your local machine, and we have deep implementation on the cloud server. And this year specifically, we also made sure that we had a day zero implementation with Gemma 4 in the Android ecosystem. So you can either try our smallest Gemma running directly on your phone, available through the API that Android is exposing to developers, or to code your Android apps locally with our Gemma 26B model when you're on the plane or you don't have access to the Gemini API. And now I will pass over to Gus, who will cover our implementation in the cloud.
Hi, everyone. Good morning. I'm Gus, one of the product managers for Gemma. Very happy to be here. Nice to see some familiar faces. As Olivier was saying, Gemma is pretty cool. A lot of great features. And when you decide to build something more than just running for you on your machine, if you want to go and build an application or use on your company or your institution, you need to serve this model somewhere, right? So they have to be served from any provider. You can use on any cloud provider, any inference providers that we have. But of course, we did everything we could to make sure that on Google Cloud we optimized as much as possible. And this is what I'm going to tell you a little bit about. First, if you Gemma is available in all the services inside Google Cloud that you can use a model, right? So for example, in Gemini Enterprise Agent Platform, we have the model garden where you see multiple models that you can use. From there, in this screen on the right, you can with one click deploy the model for you. You create an endpoint right there. You can choose the GPU here. You can choose which variant of the model. You can choose how much memory. You can choose a lot of things. It's one click deployment, right? You click, show this screen here, and then you have an endpoint for you. This is the easy one. You can use a H100, RTX 6000. We have multiple GPUs that you can play with. This is one option. The other option, still on the Gemini Enterprise Agent Platform, you have a model as a service that we call. Instead of you one-click deploying the model, we have the 26B already ready for you to use. You just call the API, right? And then you pay per token like other inference providers, right? That's an important difference here. When you do this serverless Gemma 26B, you pay per token. When you deploy using Model Garden, you pay per the endpoint. The endpoint's yours. You are paying for it to be online. So it's a different way of paying for resources. Of course, when you do that, you have access to API, SDK to access these models. This is on Gemini Enterprise Agent Platform. And we also have an option to fine-tune the model right there. So for example, if you want to do some post-training, some reinforcement learning, you have access to also do this on the same part of the Google Cloud Platform. You can use the same tools that you're already used to, and you do a further fine-tuning and customizing the model. I'm going to talk a little bit more about fine-tuning later, but this is also one option that we have. When we talk in deploying using cloud, there are multiple levels of difficulty or challenge that you face, and that depends on how much you understand and how much you want to use time to manage your servers, your endpoints, right? Gemini Enterprise Agent Platform, I would say, is in the middle. You have some control, but you also, there's a lot of stuff that helps you do it easier. When we talk about Google Cloud Kubernetes Engine, I would say this is more advanced, but you also have control of everything. You have access to every knob. You can change any configuration that you want. We also have, of course, Gemma there. We have recipes for you to easily follow and deploy, but there you have access to the VM, and you can change anything you want, right? Of course, we have recipes with everything pre-configured for you with the best parameters, but if you want to change something to optimize for your infrastructure, for your use case, you can go and do all of that. You have total control and flexibility on these endpoints. Of course, everything is always optimized for performance. We work with them to also have the MTP models already available for you whenever you want to use. And this enables you to create all your agent works already with the servers there. So you have all of that. So it's when you talk about GKE, you have access to create this provision. You have access to all these GPUs. You can use TPUs also. You can use any kind of hardware you want. You choose how you create your VM. And you can deploy that and start serving. It's pretty quick, but it needs you more expertise, I would say, right? GKE give you all the power, but you also have to pay attention to all the details. But if you want something that's the easiest solution, we have Cloud Run. So you can also very easily 2 lines of code deploy Gemma using Cloud Run. What's the difference from the other two? Cloud Run gives you an endpoint. You just deploy and it gives you an endpoint. This endpoint, you can access the queries and use Gemma the same way you would use local or other providers. But if you don't use, the server will spin down and scale to 0. Or if your app becomes very popular, you get many requests, it can also scale up to maybe 100 GPUs. And it can do all of that. And when you start from 0, for example, let's suppose your server goes down because nobody was using for whatever reason. When you go back up, it takes you a couple of seconds of warm-up, and the endpoint is already there. So it's super optimized for you to, if you want to do something quicker. And this is the easiest solution, I would say. So we have Cloud Run as the easiest, most straightforward solution. We have Gemini Enterprise, which was called Vertex. Gemini Enterprise, that's the middle term. You have some more options. And something that help you, and then you have GKE, which you have access and control of everything. So you choose wherever you want to play the game there. That's great. Now you understand what Gemma is. We showed you all the capabilities, what it can do, where and how you can deploy. That's great. But let's go a little bit beyond Gus, Olivier, Ian just saying how amazing it is. Let's try to show some cool demos and show it working real, doing some fun stuff. We have a bunch of demos, and we are going to go from, let's start from this side. We're going to go from Enterprise, or the 31B model, which is the stronger one, show you some more advanced use cases. Then we're going to show something that could run on your local machines or laptop right now. Then we'll show something that runs on your phone, that could be already running on your phone. We have demos outside also. And then we'll show some IoT and robotics. Let's go over all of this. I hope you get excited with this. The first one, I like this very much. Let me see if I can do play. Okay, so what's happening here? I want you to pay attention to the query that's happened there. The idea is, do you know those bikes that you pay to use per time, like the city bike management system? What happened here is we asked Gemma, hey, help me optimize the revenue, and here's the database. So the setup, now that it's running, now I can explain everything else. The setup is we get the ADK framework, the agent development kit, running using Gemma 31B, that's on Cloud Run. We configure it to have a BigQuery MCP server connected. So the model can do queries to this database that it doesn't know. It's just a database. This database is, of course, the city bikes database. It has all the points where the bikes are, demand, there's time, when bikes were used, all of that, right? All the analytical database you would expect. With that, we ask the model, hey, help me optimize for revenue. And all that you're seeing here, this is not accelerated, this is real speed, right? The model creates a plan to, first of all, understand what's available on this database. Like you would do if I ask you this thing, first thing you would do is like, let me take a look on the database and what's available. That's exactly what the model do. Oh, let me see what is available on this database. From there, it devises a plan to find where it can optimize the service to get more bikes, to add other points with bikes. It tries to do a bunch of experiments until we get to the end and show these are the places where you have to increase the number of bicycles. And during doing that, you can see there, for example, there's a moment it makes a mistake when it tries to join two tables, and there's a type that's wrong. It can fix this. Oh, there's an error. Let me fix this join. All of this by itself, right? There's no other user turn. There was one query at the beginning, and this runs for 3 minutes, the model trying stuff. It does, and then it makes a mistake, it regenerates, it fixes something. Oh, I found something new, and it keeps going, trying to optimize the service. And this is a pretty good example. I strongly recommend you try stuff similar. The model, it shows that Gemma 31B specifically is very strong on planning and executing that plan. Even if it has to execute code somewhere, run a query somewhere, or get more information from other sources, think more, join this information, and keep on this planning. This is the power of Gemma 31B. I guess this is so it found the best locations, and it knows, that's the answer, right? So it's showing what are the 10 best locations to improve the service, right there, based on all this back and forth. So now I know. Thank you. Gemma is pretty cool. Nice. This is one, right? Running on server, you can do that, connect to MCP. Let's go into another one. This is using Firebase AI logic. And the challenge here is a little bit different. Imagine you are running the model on your phone. If you try to run models on your phone, there's some moments where the model might not be available for you on your phone because the phone is maybe old, doesn't have enough memory, or something like that, right? So if you're an app developer and you build a feature that requires the model to be there, when the model is not there, you face a challenge automatically there. What do? One option is to have a hybrid solution where you have the model running on the phone when possible, and when it's not possible, you call the model on the cloud provider. So you have a hybrid solution that uses both local, you saw the video. It runs local or on the server depending on what you want to do. Firebase AI logic helps you do that. You configure for it to prioritize local, and if it's not available local, it will just route the same query to your server that you configure there. So that gives you an easier way to do a hybrid solution. Why this matters? Because it simplifies your life as a developer. Because if you have to do that by hand, it can be quite annoying and hard. So Firebase AI logic helps you do all of that. It can use your AI core implementation locally, if it's available on a Pixel, on a Samsung device. If it's not available, you can call the server and make this, from the user perspective, completely transparent. You don't know that you're missing anything, and you implement the same logic. This is also already available. For the next demo, I'd like to call Ian. He'll show a bunch of more demos, and I'll come back later. Thank you.
Yes, thank you very much, Gus. So my name is Ian. I'm the developer experience lead for Gemma. And the next thing I want to talk to you about is Gemma's coding capabilities. So all of our models can code, even down to the E2B model. And what we're going to show here is a demonstration of a game called AI Venture, where you can vibe code along using the model, and we'll play the video so you can have a look.
Want to learn how to build agentic workflows and integrate vibe coding into your apps? Well, we built AI Venture, an open source retro dungeon crawler that doubles as a Gen AI masterclass for developers. Built on an Angular and Phaser.js stack, AI Venture is powered by Google's Gemma 4 open weights model. First, we'll explore vibe coding. You prompt a chicken NPC to build a web app. Behind the scenes, Gemma 4 writes HTML, CSS, and JavaScript on the fly and renders it locally in an iframe to validate the constraints. Next, you'll build agentic behaviors. When encountering a puzzle you can't physically cross, you must prompt a robot NPC. This triggers an autonomous thinking loop. Gemma 4 evaluates the game state, executes specific tool calls to locate a hidden switch, and interacts with the Phaser.js game engine to solve the puzzle. The biggest takeaway? You have complete flexibility in how the model is served. You can run Gemma 4 entirely locally with zero ongoing server costs using Transformers.js in the browser, or by plugging into Ollama or LM Studio via their OpenAI compatible interfaces. Need cloud scale? A simple config change routes your request to the right Gemini API or Google Cloud. Ready to look under the hood? Scan the QR code and explore the GitHub repo and read the full developer solution. Take on the quest to expand your AI tooling knowledge with AI Venture.
Thank you. So there you go. As Pastian mentioned, you can run this model in a number of different scenarios. And we have an example you can try outside using LM Studio. And we also have a version that runs with LightRT and WebGPU directly in the browser. So you don't even need a connection to do it. Next up, I want to show you a demo about the speed and performance you can get about running Gemma in parallel. And to do that, we're going to move over to this laptop right here. So what I'm going to showcase in this particular example is I'm going to show running multiple agents running on a single server, in this case this laptop, which are going to do a task for me. So we're going to use it to build some SVGs. So how about we do, let's go for a cute animal mascot for Gemma. There we go. Let's see if I can spell it right. There we go. And we're going to execute that with 15 different agents. So let's run that query. First of all, the orchestrator, which is in the top, is going to delegate that task amongst the different agents that we've got running. And it's going to do things like little animals and stuff like that. And what you can see in the left-hand side is the total throughput of all of these agents running simultaneously. And this is the parallel capabilities of running a system like Llama CPP directly on the device. And you can think of it that each one of these parallel agents is kind of like a unique user or a unique session. What you'll notice, actually, is that the speed decreases. And that's because when you're running less stuff in parallel, it is limited by how fast it can output tokens. Again, showing the concurrency. Oh, there we go. Got some crazy little agents here. Oh, I like this guy, this little sunshine guy. So that was obviously a little bit of fun, just create some SVGs. I tried to show this to demonstrate the throughput. But if you wanted, for instance, to do a more complex task, you can enable thinking and take a little bit of extra time and have each of these sub-agents reason about what they're actually building. I'm going to show you another example right here related to code. So We're going to use this example to show how Gemma can code different programming languages and do this in real time. So I'm going to do an example. There we go. Example of calling. So we're going to call the Gemma model Google. So it's Gemma 4. In this case, we're going to call the 26B, and it's 4 billion activated parameters. And we're going to pick the IT versions. The IT version is the instruction-tuned version of the model. So that's the one that has the chat template, understands function calling, etc. And we're going to call it with the OpenAI compatible endpoint. And we're going to run it on localhost. So if you're not familiar with this, most of the services like LM Studio, Llama CPP, Ollama, etc., have a OpenAI compatible endpoint where you can direct it to your local machine rather than to a cloud service. And this is one of the easiest ways to get started using Gemma, to take that existing interface and kind of swap it over to that. So we're going to run it on localhost on port, in this case, 8080. And let's make that, we're going to make, how about 8 agents? How about that? Let's do that. So let's run that one. So again, what it will do is it will pass that instruction onto the next model, and then they will subdivide that as a different task. So you can imagine in this scenario that this could be a workflow that you want to run, or maybe it's your favorite agent harness. And each of these is going to run in parallel on this local machine, so it will work offline on whatever task you're currently running. So we'll wait for that to complete, and then we'll have a look at some of the output. So one thing that's super interesting to point out here is that this is the model's base knowledge about how to do programming in each of these languages. If you want to give it additional reference documentation, or you want to create a skill to be able to understand your code base and how that operates, you can provide that as a tool to Gemma, and Gemma will execute that before doing it. So yeah, we can see that thank you. You can see here that we've got different versions in different languages. We've got Rust, JavaScript, Python. Some of them, they have recognized that there is a library that they can actually call to do this. Others that don't have a library will basically use like a HTTP request endpoint and will work directly with a JSON service. So yeah, again, as I mentioned, you can tailor this to whatever task you want, but imagine having your own little army of agents running just on your laptop and wherever you are, whether you're on a plane, whether you're in low connectivity, whether you're out on a hike, you can make this work. Thank you. So we'll move back. So next up, I want to talk about mobile. So we also mentioned that we have an E2B and an E4B model that are specifically tailored and optimized for mobile applications. And they run with accelerators on CPUs, GPUs, and TPUs thanks to LiteRT and AI Core. So let's have a look at the video.
So most people have heard that Gemma models can run on a range of different devices, laptops, desktops, etc. But not many people know that they also run on mobile phones. So I've got a Pixel 10 Pro here, and I'm running the Google AI Edge Gallery app. And what I'm going to show you is how Gemma can be used to take photographs, understand the world, record audio, and to use agent and agent skills all running locally on this device. So let's see a couple of examples about what we can do. So first, I'm going to show you agent skills. Agent skills is where you can ask the model on the phone to be able to interact with different apps and applications. And the model will decide which of these is most suited for the purpose. In this case, I'm just going to ask the model a prompt, and then it's going to pick which application to use. So I will record a voice note, add to my mood tracker. I'm feeling about 8 out of 10 today. I'm feeling calm and excited to talk about Gemma. So I'll send that off, and then the model will then listen to that track because it understands how to do audio input, and then it will pick which application to use. So in this case, it's decided to load the mood tracker, and it should record that entry into my mood tracking journal. There you go. So another thing Gemma can do is it can read and understand images. So I'm going to take a photograph of these books right here, and I'm going to ask it to output the books as a JSON schema. Take these books and output as a JSON schema with a title for each entry. And it will think about that prompt, decide what output it needs to generate, and it will invent a schema that it thinks will fit. Or maybe I just want to have a new item on my desk for an arrangement. So I can take a photograph of these plants right here, and I can say something like, suggest 3 things for me to add to my arrangement, give a sentence for each. Another thing that Gemma can do on device is it's multimodal and understands audio input. So you can record snippets of voice or audio and have Gemma process it naturally, doing things like transcription and translation. So in this case, I'm going to record a clip, make a note of things that I need to do today. I need to pick my kids up from school, I need to go to the grocery shop and get some milk, and I need to buy some flowers for my wife. And what's also important to remember is that this is running entirely on the device, so it'll work offline or in areas of low connectivity. So let's give you an example. Imagine I was offline and I wanted to know what this was. So let's take a quick photo. What is this thing? And Gemma will process the image, try and understand what's in it, and give an answer directly, all without connectivity. Okay, so it thinks it's a small toy, which is correct. So I've shown you a couple of examples about what you can do with Gemma on a mobile device. So go to Google AI Edge Gallery app on Android and iOS and tell us what you think.
Yeah, thank you. So the Edge Gallery app, you obviously can download on Android and iOS, as mentioned. And if you want to play around with it, you can try the different modalities out and the different skills that it's able to understand by checking out our demo booth. So the next natural step from moving on from mobile is to move into streaming and streaming inputs. So in this particular example, I'm going to showcase a different example about how you would have a conversation with a model, right? In order to do this, we need to have incredibly low latency models on both the processing, but then the whole stack. So it needs to be able to work in under a second from basically the end of you finishing your sentence to the start of the model responding. So let's see what that looks like.
Hey Gemma, tell me a little bit about yourself.
I'm Gemma 4, large language model developed by Google DeepMind. I process text and images to provide information and complete tasks.
Cool. Can you tell me a little bit about Shakespeare?
William Shakespeare was an English playwright and poet widely regarded as the greatest writer in the English language.
Actually, hold up. Do you know what? I really want to know about the solar system. Can you tell me about that?
The solar system consists of the sun and everything gravitationally bound to it, including 8 planets, 4 planets, moons, asteroids, and comets.
That's cool. Can you explain how a black hole works?
Black hole forms when a massive star collapses under its own gravity, creating a region of spacetime with gravity so strong that nothing, not even light, can escape.
That's so cool. Thank you.
You're welcome. You have any other questions I can answer for you?
There you go. So you can see how you can make assistants with this model with incredibly low latency, and we were using voice activity detection there. So the interesting part to me is that as part of this process, you are streaming and chunking the audio as it comes in, and then the model is processing the first part of the output, and it's able to generate the TTS, which is a separate model, while this is happening. And that is what leads to that kind of low latency and the ability to do things like interruption. So if you want to try this experience, again, we have it at our demo booth outside, and we'd love to hear what you think about it. And then obviously the next natural process for doing this is to move into the world of different modalities, so including things like vision. And we have a fantastic demo here from our friends at Hugging Face and Polymer Robotics. And I want to introduce to you Reachy Mini. And what Reachy Mini is going to show you here is how you can interact with a model that can see and can hear and then can respond with emotions. So let's have a look.
Hey there, I'm Reachy Mini. What's on your mind? Hey Reachy, can you tell me what you see in front of you right now? It looks like a chessboard set up on a table. What are we playing? I'm just learning about chess. Can you teach me how the knight moves? That sounds like fun. I can certainly try to explain the knight's move. It jumps in an L shape to any of the 8 surrounding squares. Well, in that case, I'm going to move here. You're in checkmate. I win. Oh dear, it looks like you just won. That was a quick game.
Poor Reachy, yes. I think a bit unfair because obviously Reachy doesn't have hands to move the pieces himself. But yeah, as you can see, local assistant you can have a communication with, they can see and understand the world around you, and again, powered by Demo 4. So thanks again to Joshua from the Transformers JS team for this incredible demo. So next up, we're going to talk about personal assistants. And here to explain a little bit more about how that might work, we're going to hand over to Olivier.
Thanks so much, Jan. Very exciting. So a couple of years ago, for the first time ever, we loaded a local model on the phone. And I was in the product team that took care of it. This model could barely reply back to you. Very simple query, still struggling a little bit. 2 years ago, we also showed you what a multimodal assistant looked like with Astra running fully server-side. And since that date, we're quite excited to see what it would look like if we were to do it entirely on device without internet on a phone. And this is what it looks like.
Hey, Gemma, do we have internet now?
So you have a full tool call at the system level?
No, we don't have an internet connection right now.
What is this warning about?
That sign is a warning about the puma habitat. It advises that pumas are part of the local environment and that you should be cautious if you encounter one.
What is the derivative of this function?
A little bit of math on camping,
x squared plus 7. X plus 10 is 2x plus 7.
Oh, hey!
Hey, Cindy. We are now streaming from the extra glasses on the phone.
When is our group hike tonight? Your group hike is scheduled for 6 p.m. today.
Is this a puma?
No, that is a dog.
Good boy. I'm quite excited by the progress we've been able to make on device in just a couple of years. And the good thing is that if you're curious, we actually have the phone that is being run on, and we can do the demo outside after the talk. Now, let's actually look at what it could do to help people in their everyday life. So we have an example with someone who is visually impaired, and you can see the value of AI running on device to help people in their everyday life.
It's 28 degrees and clear. Perfect running weather. Let's do a slow run. And I'll guide your pace with audio cues. Whenever you're ready. Great rhythm. Keep that stride. There's some gym gear on your left. Stay on your current track. Left turn coming up. Ease into it. You've got this. And now, take it slow. You got room.
By using Gemma 4 to understand the runner's surroundings, the Gemma running agent acts as a guide, giving blind and low vision runners the confidence to navigate safely and avoid obstacles in real time. We're also exploring Gemma running agent with the new intelligent eyewear. It's not just a new way of running. It's a massive leap toward true, wearable autonomy.
Stay in that lane. Perfect. Great run.
So this is currently a prototype, but we will keep on working on it. And for me, this combination of local AI, fully offline, helping people with accessibility is what I think AI for good should be, and we are very excited to continue in that direction. On that note, I will hand back to Jan for the rest of the demos.
Thank you, Olivier.
I am
So, I'm going to show you a quick video about...
Today I'm very happy to bring you those 2 tiny ducks to showcase what Gemma 4 can do on device. They are Open Mini Ducks version 2 by Antoine Caron on GitHub. And the idea was to bring the power of Gemma 4 to do on-device inference and to make those ducks smart. In terms of the technical stack, this duck runs Gemma 4 E2B on LightRT on a Raspberry Pi 5, and this duck runs Gemma 4 E2B on a Jetson Ori Nano. They both have a microphone, cameras, and speakers, and through multimodal inputs of Gemma 4, they're able to process and understand the environment like never before. Let's see what Duck Gemma with a Raspberry Pi 5 can do. So when we wait for the system to boot, just going to describe some of the features that this project online built. They built antennas for expressiveness. There are some LEDs just to show some expressions, and a speaker next to it. And then it enters attention mode, which is this loop that just shows some expressiveness and the fact that Gemma is not listening. And we're going to try that on the other duck, and it will send you some love, also on the booting phase, if everything goes right. Hey Gemma, explain me what a large language model is. So we're using parakeets to do speech-to-text, Gemma 4 will do the inference, and we'll use Kokoro to do text-to-speech.
A large language model is a complex AI designed to understand and generate human-like text. I am here to assist you with tasks and interactions.
Introduce yourself. Tell me more about you.
I am Autumn, a small duck robot's brain.
Very snappy. Autumn is ODM, so Open Duck Mini, so that's why it calls itself Autumn, which I think is pretty cool. So this is a great way to bring intelligence onto those ducks. The next step is for them to start walking, to see each other, talk to each other, and maybe go autonomously explore the world on their own.
So, thank you. So Xavier, the creator of our ducks, is outside. If you want to have a chat with him, and you can have a chat to the ducks and see what they can do. And this really shows when you shrink Gemma models down to things that run on IoT devices like Raspberry Pis, that you can run physical local agents that can see, act, and react in the world. I have one more slide to show you, and it's on this new topic here. So we mentioned Gemma is designed to run on the edge, and this is really the smallest we've been able to get. So this is a Coral board, which is a dedicated MPU that can do one tops. It's an open architecture built by the Coral team, and the demo on the top is showing the Gemma 3 270M model doing translation, and the demo on the bottom is showing a function Gemma, which can take voice input or text input and turn it into actions. And the incredible part of this is we're able to shrink these models down to things that are potentially suitable for things like wearables, really low-powered and low-cost devices. So Gemma really kind of stretches that whole range. Now, these obviously just all the things that we've shown you. We have a massive ecosystem of developers and builders and companies that are working with Gemma models. And to give you a bit of a rundown on that, I'll pass to Gus. Thank you, Gus.
Of course, thank you. Nice. Pretty cool, right? Lots of cool demos, lots of inspiration for you to help us build the demos for the next year. So that's pretty good. And that's a pretty good point to get here. What is the Gemmaverse? We launched these Gemma models for the community, for the enterprise, for developers to build cool things and share with the world of what they're building. And more than just building an application, when we share a model, you can improve the model and change how the model behaves. And this is what we call the Gemmaverse, is this collection of models that people keep creating based on Gemma. As of today, I'm pretty sure that number is wrong. We have more than 500 million downloads. And I think it's wrong because I think it's way more than that, right? This update like a couple of weeks ago. Thank you. And we have more than 100,000 variants of Gemma models. A variant is someone like you from the community that goes and improves the model on a specific task, language, or something. I'm going to show some examples in a little bit, but we have a lot of people creating these variants. And how do you do that? You usually fine-tune a model. So fine-tune a model is kind of, if you have a kid, you teach something new to it, right? So the model is the same idea. You can teach a new capability, or you can improve something that already knows, or you can change how it behaves. I'm sorry. And this is where you fine-tune. So if you want the model to speak in a way that's more tailored to your enterprise, that's why you fine-tune. Yesterday, in the developer keynote, Kevin used Antigraph to fine-tune Gemma to be more concise in its answers, right? It can give you an answer that's maybe too fluffy, as he said. I don't agree, but that's okay. But he wanted something more straightforward. That's something you can fine-tune the model with maybe 100 or 1,000 examples, and the model will be more straightforward if that's what you need. Or you can do it for teaching a new language, which is way more involved and also super cool. So there's all these options. And people have been doing this from Google. We've done this, for example, for MedGemma. MedGemma is Gemma 3, then our model from last year, fine-tuned for the healthcare area. So you can ask questions more related to health, to X-rays, to all this kind of information that's way more focused on a vertical. So MedGemma is available too. You can play. There's MedGemma 1.5 already that's released this year. You can play with it, have fun. It's one of the variants we have available. We have many. One other variant that was released last year is the cell to sentence. So the cell to sentence is a variant of Gemma 3 27B that you can help. It's helping find new treatments for cancer. This is pretty cool because, you can cure cancer. No. This is helping find treatments. These treatments are being tested already. It's not something like, it will get there. No. It's being tested already, and we have already some good results. So this is way more advanced than just a toy, right? More than that, we did some variants, but the community did a lot of variants. We have many colleagues that did multiple variants. We have some examples here. For example, the Crane AI Labs. They got the Gemma 3 model and fine-tuned it to teach better Swahili, and which impacts a lot of people. Gemma can do a little bit of Swahili, but they could do even better, and that enables way more people to have access to LLMs. We have Seiya over there, which are people that we work together to make a version that was even better in Portuguese. Portuguese is pretty important to me, so it was pretty fun to work with them. And we have multiple others. We have ePermit, which is our colleagues in Ukraine using Gemma models on their government already to help make process faster. So we have many variants that are already helping with the Gemmaverse. And that being said, I would love to know what you are building next. There's so many possibilities, and Gemma is here to help you build even more cool stuff. We will not have time to answer questions right now, but all of us will be here in front in the Q&A session. So please come ask your questions. We're more than glad to chat. Thank you very much.
Hi, everyone. I'm Sachin Kotwani, and I'm a group product manager on the Google AI team. Presenting with me today is Aaron Walsh, developer relations engineer on the team. Today, we're going to talk about Google's suite of tools for implementing on-device AI anywhere on the edge, from mobile to desktop to IoT. 2026 is a special time for on-device AI. There is an electrifying energy and enthusiasm about what's possible and what's yet to come. Now, on-device AI has been around for many years, but initially it was limited to computer vision and general models. You have been able to run LLMs on device for a couple of years, but let's be real, they weren't that great. Their usefulness was limited, especially when compared to cloud-based models. This year, however, LLMs have made a huge leap. Just look at this chart, and you'll see the impressive evals for the latest Gemma 4 E2B and E4B models. The 4B model actually outperforms the much larger Gemma 370B from last year on most of these metrics, not all, which shows how much things have changed. But better than telling you, let me show you. Right, if we can switch to the Pixel 10, I have the Google Edge Gallery app here, and I'm going to take a picture, and I'm just going to say describe. Let's keep it simple. Okay, there you go. You can see how detailed it is and how fast it's decoding. Just imagine the kind of things, the kind of application that you can build with that. So let's read here. It's a portrait-style photograph of a man with a warm and friendly expression. Thank you. The man appears to be middle-aged. All right, maybe I'll have to double think what I said about the Gemma accuracy. I think it's pretty good. All right, we go back to the slides. Okay, so not only are the model's raw capabilities, as you just saw, and the underlying runtime impressive, but also the fact that all of this is running entirely on the device without an internet connection. This helps reduce cloud API costs when the local model can do a good job at the task at hand. It can also allow you to work offline, for example, on a flight, or for use cases where cloud latency may be greater than acceptable for your application, or where strict data requirements may prevent you from sending the data to the cloud. And it's not just the models that have gotten better. Devices are now more capable too, and that's because of improvements across compute targets. On CPU, Android now integrates ARM's SME2 with an XNN pack and LightRT, which allows models like Gemma to deliver up to 6 times faster responses. What's more important, developers benefit from this automatically by using the supported libraries and frameworks. GPUs are no longer just for gaming. They've evolved into efficient, high-performance engines with dedicated tensor cores for AI processing. And now, dedicated NPUs can run models at speeds of over 200 tokens per second and more power efficiently than ever before. The hardware is so fast now that the bottleneck are no longer the processors. It's how fast the phone can move data from memory to the chip. The advances in both hardware and small language models like Gemma 4, 2B, and 4B together make now the perfect time to bring on-device AI to your applications. And Google AI can help you with that. Whether you want to take advantage of ready-to-use tasks such as pose detection or gesture recognition, or you want to run a language model or bring your own custom model, you'll find everything you need in this comprehensive suite of tools. The AI solutions can run across a wide variety of platforms, so you can build your solution once and deploy on Android, iOS, web, desktop, and IoT. And you wouldn't be the only one to do so. Developers have been using our stack for quite some time now. Here are some numbers. There are over 250,000 apps just on Android using the Google AI stack. Those are running on over 3.8 billion devices, which are generating over 1 trillion daily interpreter invocations per day. Google AI solutions seamlessly utilize hardware acceleration, ensuring your models run as efficiently as possible, depending on the available CPU, GPU, or NPU. We are fully committed to maximizing hardware acceleration across the ecosystem. Last year, we released production-grade NPU support for Qualcomm and MediaTek chipsets via LiDAR-T. And today, we are super excited to announce 2 new LiDAR-T NPU backends, Google Tensor and Intel. Meanwhile, we're also making steady progress on integrating additional support for Broadcom, Raspberry Pi, and Exynos. Erin, you want to tell us how our developers can take advantage of all this?
Absolutely. So that's really all exciting stuff, and it sounds like there are tons of great tools in the AI Edge stack. But in the world of on-device AI, there's so many tools, models, frameworks, platforms. So as a developer, where do I fit into all this? To answer that, throughout this talk, we will take a look at 3 different developer personas and how they can navigate the Google AI Edge stack and for their distinct use cases. Meet Megan, Rob, and Chris. All 3 developers are building on-device AI features in different ways. Megan is exploring different LLMs. Rob wants to quickly ship common use cases to a wide range of devices. And Chris is building a hero feature that requires control of the whole ML pipeline. So we'll see how each one of them would use the stack. Let's start with Megan. Megan is an indie game developer, and she's building an open-world fantasy role-playing game for mobile devices. She wants to leverage the power of LLMs to enhance her game. Sachin, what options do we have for Megan?
All right. So for Megan, we have a full set of tools. First, as we saw earlier, she can always use the Gallery app to explore and see what's possible with out-of-the-box models like Gemma. What's more interesting is that you can use the open source code of Gallery to create your own app, whether it's by forking it or pointing your agentic hardness to the source code. You can also download Gallery on your phone now on both Android and iOS and play with it. Under the hood, all of this uses LiDAR-TLM. And while LiDAR-T is our runtime for tensor in, tensor out processing, LiDAR-TLM adds a text-in, text-out interface. It provides high-performance inference that's specifically optimized for edge devices, and it leverages hardware acceleration and optimized kernels specifically for LLM operations like heavy caching. And of course, it's designed to work seamlessly across Android, iOS, Windows, Linux, and macOS. In terms of models, you can pick from the various versions of models like Gemma, which we have optimized and pre-quantized for you in LiDAR-TLM format, and they're available in Hugging Face. Optionally, you can also create a custom fine-tune of the model based on your own data for your specific problem or domain. This will be particularly important for the smaller models, such as the 1B or smaller than that. And optionally, you can test your implementation across a wide range of real devices using Google AI Edge Portal, which we'll talk about a little later. Erin, you want to go into Megan's specific use case in a little more detail?
Yeah. So it sounds like LiDAR-TLM is an ideal solution for Megan as she navigates the world of on-device LLMs. But what exactly is she looking for? Like we mentioned earlier, Megan is building her mobile game, and she wants her world to feel alive. Instead of players clicking through the same pre-written dialogue trees every time they try to talk to a character, she wants dynamic, conversational, non-player characters, or NPCs. If the player asks the blacksmith about the weather, or tries to haggle for a sword, the NPC should react naturally and stay in character. Initially, Megan considered hooking her game up to a cloud-based LLM, but came across a few challenges. For starters, hitting servers every single time a player stops to chat with a random town guard would burn through her budget very quickly. Plus, mobile gamers play everywhere. They play on subways, airplanes, the back of cars, and if an NPC freezes because the player drops cell service, then the immersion is broken. And even with a perfect connection, relying on cloud introduces latency. In gaming, waiting for a server response would make a dynamic conversation feel a little clunky. So Megan realizes that a good solution is to run the intelligence entirely on the player's device. She needs an LLM that is lightweight enough to run on a smartphone without running out the battery, but capable enough to hold a fantasy conversation. So she does a little research and chooses Gemma 270M to power her NPCs. As she's building her game, she can simply use system prompts for each character, like, you are a grumpy blacksmith from Ironhaven, you hate wizards and you love gold. In doing so, she generates fun NPC interactions for her game. So now that Megan has figured out her NPC solution and chosen her on-device model, how does she go about running Gemma 270M in her game? This is where she dives right into the LiDAR-TLM APIs. LiDAR-TLM offers native APIs in Kotlin, Swift, C++, recently JavaScript and Flutter, and all she needs to do is include the library into her project. LiDAR-TLM abstracts away the complex boilerplate of on-device AI. It provides Megan with the methods to load Gemma 270M into memory, manage the ongoing chat session so the NPC remembers what the player just said, and run fast inference using the device's local hardware. And the result is Megan's players get to experience a deeply immersive world where they can play anywhere at no server cost, all powered in the background by LiDAR-TLM. Earlier, Sachin demoed and mentioned the AI Edge Gallery app, but it's important to know it's much more than just a showcase for really cool LLM demos. It's also a highly practical developer resource. Because the entire source code for Gallery app is available on GitHub, Megan can look right under the hood. She can see exactly how the Gallery app uses LiDAR-TLM to load models, manage local sessions, and run inference, and use that implementation as a proven blueprint for her own application. She can even use the Gallery app source code as a blueprint for agentic coding. Megan can give her coding agent a choice, her model file, and the Gallery app GitHub repo, and spin up an app that runs inference locally on her LLM in minutes. In fact, let's show this prompt on screen with Google Anti-Gravity right now. So can we switch to the computer screen? Okay, so we are open up in Anti-Gravity. All we have is a completely blank folder. I've preloaded this model into it, and so you can get this model just by going to the LiDAR-T community on Hugging Face. You can download the model straight from there, and all it is just an empty folder with just the model in it. And so we will copy and paste this prompt into Anti-Gravity, we'll let it run, and for the sake of time, we're going to skip to what it builds. So here we are. It'll come up with, so first what it does is it downloads the Gallery app as a reference code over here. So you'll see a reference in the Gallery app, and then it will give you an implementation plan. It'll ask you some clarifying questions, like do you want to default to CPU or use different hardware acceleration, and then you go back and forth with it on there, and it'll give you a walkthrough of what it builds. And so here in this prompt, we've asked it to just build a very simple chat app. So we've downloaded the model from Hugging Face. It's in LiDAR-TLM format, and we just want to instantly make a chat app for a phone. So can we please go to the phone? So here we are. We have Gemma Chat. The phone is on airplane mode right now, so there's no connection anywhere. And we're just going to ask, hello, which model are you? Run it, and you can see it types right back. So it's pretty easy to grab a model file and spin up an app that runs local inference on it using LiDAR-TLM in very, very short time. Can we go back to the slides? So back to Megan. Once she has everything smoothly running on her own test device, she faces the reality of deployment. And how will her game actually perform in the wild? Mobile games are already memory intensive, just from 3D rendering and audio. Megan needs to know exactly how much extra memory Gemma 270M is going to consume, so she can guarantee her game won't crash on older phones. Instead of guessing, she uploads her model to the Google AI Edge portal. This instantly unlocks access to a massive cloud-based fleet of real physical devices, allowing her to benchmark her model's performance on the variety of different phones her users might be playing on. And while an open model right out of the box is a great starting point for her game, there are a few ways Megan can level up her LLM implementation. For example, if she wants her characters to speak in a distinct fictional dialect, she could go even further and fine-tune an LLM for her NPC characters. To do this, she can start by consulting the Gemma Cookbook. It's a detailed resource packed with practical step-by-step guides for fine-tuning open models. Once she has fine-tuned her model, she can't run it in her app just yet. So she uses the Google AI Edge Torch tool to convert her model weights into the optimized lighter TLM file format, the same one we used with Google Anti-Gravity earlier. And once she has that lighter TLM file, she can use the lighter TLM CLI tool to run her model locally and test different presets and prompts to ensure the model is performing up to her standards. The tutorials on Google AI Edge documentation will walk her through every step of this process. And once Megan is satisfied with her new model, she doesn't have to rewrite her game. She can literally just drag and drop the model files right back into her existing layer TLM architecture for her game. And if Megan is targeting Android users specifically, Gemini Nano, which is based on Gemma, is a great option. Gemini Nano is integrated directly into the OS of the latest Android devices via AI Core and natively hardware accelerated. Check out Karen Chang's IO talk, Deploy Android on Device AI with MLKit Gen AI, and the MLKit documentation to learn more about using AI Core for Android. So now Megan's game is officially ready to be launched. And no matter where her AI journey takes her next, lighter TLM gives her the flexibility to keep her NPCs running fast, local, and entirely on device. So now that we've gone through a fictional persona scenario, let's talk about a real-life lighter TLM user journey. Sachin, you want to tell us about Kakao?
So lighter TLM provides a very simple text-in, text-out interface, very easy to use, but it's actually really powerful. If you have needs that go beyond fine-tuning, you can use this flexible lighter TLM framework for more custom implementation. And that's what Kakao did. Do we have Rex and the Kakao team in the audience? All right, they're going to be here. So Kakao, oh, right there, hey, thanks for coming. So Kakao is using lighter TLM to deploy the Kanana Nano 1.3 billion parameter model as a built-in feature of the Kakao Talk Android app, which allows them to offer real-time, on-device AI interactions without relying on external servers. They shrank the original model's runtime footprint by over 600 megabytes through advanced memory mapping and KV caching optimizations. In addition to this, custom OpenCL priority settings were implemented to ensure that the AI runs in the background without causing UI jank or any kind of lag for the user. To maintain high quality across the Android ecosystem, Kakao leveraged lighter TLM's flexible backends to route pre-processing based on the chipset, utilizing GPU acceleration where available and CPU-only execution for others, ensuring stable, accurate outputs regardless of the hardware. So now you've seen how powerful lighter TLM is for running your LLMs on device. But what if you're looking for a simpler way to leverage AI? What if you just want to quickly drop in a common AI capability without having to build it yourself? Let's pivot to Rob. He's looking for pre-built, plug-and-play AI solutions that just work right out of the box. And this is exactly where MediaPipe tasks come in. So if you're looking for ready-to-use AI tasks across audio, vision, and text, MediaPipe tasks allow you to seamlessly do things like image classification, pose detection, hand gesture recognition, and more. These are super easy to implement, and there are thousands of apps using them. Erin, even though they're really easy to implement, why don't you tell us how to go about it?
Yeah, definitely. MediaPipe is really fun. So let's follow Rob's journey with MediaPipe. Rob is a talented cross-platform developer, and his product is native Android, iOS, and web apps used across thousands of devices. Rob wants to add powerful, everyday AI features to his products that would reach his very large user base, and he doesn't have time to reinvent the wheel. He just needs reliable features, minimal overhead, and to meet his Friday ship date. So MediaPipe Tasks is Rob's toolkit of pre-built, highly optimized AI tasks that he can drop right into his apps, no matter which platform he's applying to, on mobile, web, or desktop. Today, Rob is building a new mode for his selfie app that automatically sends a picture the exact moment a user jumps, capturing that perfect midair flying shot. But how does the app actually know the precise second the user leaves the ground? Rob doesn't have time to build and train a custom computer vision model from scratch just to track body positions. And the beauty is, he doesn't have to. Instead, he can just grab the pose landmarker task from the MediaPipe Vision APIs. By tracking the Y coordinates of the user's shoulders frame by frame, the app watches for that value to drop as the user jumps upward. And the moment their upward momentum peaks, the app instantly snaps that perfect midair photo. To get pose landmarker up and running, Rob can dive straight into the MediaPipe documentation for a step-by-step guide. Or he can simply let his AI agent handle the implementation for him. Either way, MediaPipe APIs are designed to make complex AI tasks incredibly simple to integrate. And when he's ready for some inspiration for his next big feature, he can head over to the MediaPipe gallery in Google AI Studio. It's a great place to explore fun example projects and even vibe code a few prototypes on the fly. So let's take a look at an awesome project that actually uses the exact solution that Rob chose. It's an interactive twist on the classic Chrome Dino game, where you still have to jump over the cacti, but this time I'm going to be the dino. So let's show the computer. All right, so we have Google AI Studio pulled up. There's this MediaPipe tab right here. You can see a bunch of fun projects, give them a little preview, and today we're going to play Dino Jump. So I turned on the camera feed debug, so it shows you exactly what pose landmarker is doing my shoulders, and we're going to step back and we're going to play this game. So I got to start it off, and then there we go, and one more. Okay. So that was really fun.
Pretty good.
All right, let's go back to the slides. Oh, we're still jumping. So MediaPipe is incredible for dropping in those quick pre-built tasks, and Rob will have this new feature ready in no time. But what happens when your use case isn't on that list? We've talked about LLMs and plug-and-play solutions, but we all know the world of on-device AI is so much broader than that. So let's move to our third developer, Chris. What if you need to run a completely custom model using a classical ML architecture? Sachin, why don't you tell us more about that?
Thank you. All right, so we talked about text-in, text-out LLMs and high-level APIs. But if your needs call for a custom model that's not covered by either of these, you can also bring your own custom model from a variety of frameworks. LiDAR-T allows you to do just that in a tensor-in, tensor-out format. For example, you can convert models like YOLO to run on-device using LiDAR-T. We offer an easy-to-use set of tools that takes you all the way from model conversion to a runtime that runs a portable TF-like file format, all with industry-leading performance across CPU, GPU, and NPU. And we have many examples of successful deployments where developers brought their own models. The Adobe Lightroom team uses LiDAR-T for several AI features. They're reporting up to 30% performance improvement in various image editing functions, including select subject, select sky, scene enhance, adaptive portrait, thanks to the latest MLDrive GPU delegate that's part of LiDAR-T. Snap is seeing approximately 30% performance lift on many use cases when compared to the previous generation TensorFlow Lite GPU delegate. Epic's Unreal Engine enables 30 frames per second AR experiences by leveraging the NPU via LiDAR-T. Uber deploys various AI-powered capabilities using LiDAR-T on millions of Android devices. Argmax offers audio-based models and an SDK for real-time audio transcription via the NPU integration. And Pico OS offers fast, private, on-device capabilities for a jet lag-free for lag-free, jet lag is what I have, for the lag-free spatial experience on Project Swan headsets. That is, of course, in addition to the many Google apps that use LiDAR-T to power a variety of capabilities. So what do you think, Aaron?
Sounds really awesome. And it sounds like our third persona, Chris, could take a beat from all those cool customers. Our third developer, Chris, is an expert AI engineer. He uses custom models, often built using classical machine learning architectures and popular frameworks like PyTorch, JAX, and Keras. He wants to be able to run his models on device and optimize every ounce of performance to meet strict latency, memory, and power constraints. So for Chris, the core LiDAR-T framework is his ultimate tool. But what exactly is Chris building for? Chris is an environmental conservationist, and he's building a suite of offline tools for field researchers. His team's goal is to monitor the migration patterns of a rare bird species deep within the rainforest. And for this, he's building a continuous acoustic monitor designed to sit in the canopy and identify specific bird calls. So Chris is building a custom audio classification model from scratch. He needs to surgically separate the specific call of the rare bird from the chaotic background noise of the jungle. And because the device is solar powered and constantly running, he can't use an LLM for this because it would drain the tiny battery in hours. So Chris builds his own PyTorch model and tweaks it until it correctly identifies the rare bird calls. But then he faces another challenge. How does he actually run his model on a low-power IoT device sitting offline in the woods? To streamline his workflow, Chris uses the LiDAR-T CLI tool, a Python-based command line toolkit designed specifically for managing, running, and benchmarking LiDAR-T models on different hardware accelerators and platforms. And it also has a custom skill that Chris can plug directly into his coding agent of choice, like Google Antigravity. By handing the terminal commands off to his agent, he can create a more seamless, modern developer experience. So here's how he takes the model from repository to hardware-accelerated workflow, or hardware-accelerated deployment. First, Chris uses the LiDAR-T CLI tool to convert his PyTorch model into the highly optimized, flexible TF-Lite format. And then he can perform ahead-of-time compilation on his model to target a particular NPU. By targeting NPUs, he can get maximum battery life from his monitoring device. And finally, he can benchmark the model's performance on a connected device. And then next, it's time for deployment. To get the absolute best performance out of his IoT hardware, Chris uses the LiDAR-T compiled model API. This modern API is a game changer for edge development and deployment. It automatically handles hardware acceleration, seamlessly compiling and routing the model to the device's NPU. This ensures the model runs blazingly fast while just using a fraction of the power. But Chris's work isn't done yet. He's also building a mobile companion app for human scientists on the ground. Out in the field, the researchers are wearing big protective gloves, and they don't have any cell service, but they still need to quickly record their notes and findings. They need an offline voice-to-text transcription feature. So this time, Chris doesn't need to build his own model. He can leverage existing pre-built AI. He heads over to the automatic speech recognition leaderboard on Hugging Face and decides to pick the parakeet model to balance quality and speed. And he integrates it as an off-the-shelf solution to power his app's hands-free dictation. LiDAR-T already provides a few ready-to-use, pre-optimized ASR models, like Parakeet, Whisper, Quen ASR, and Moonshine, that support a variety of on-device applications. There's also a pre-built sample app to run these models, and so it's easy for Chris to directly download his model of choice from the LiDAR-T Hugging Face community and run it on his device using the sample app. In fact, let's try this very simple app out right now. So can we show the phone on the screen? Oh, we're still on Java Chat. So I'm going to pull up ASR app. We're going to choose Parakeet. It's going to load, and we're going to run it on TPU. All right, so now let's load it up. Let's test a bit of live transcription. Hello, we are testing audio speech recognition live on stage right now. All right, so I think there's a little bit of interference, but it works. You can use this. You can see it on GitHub and download and try out the models for yourself and run them on different hardware. So you can go back to the slides. And so to conclude Chris's journey, we've seen how converting a custom model and leveraging the latest ASR technology allowed him to build the perfect offline solution for research in the rainforest with LiDAR-T. So now we've seen how 3 different developers navigated the Google AI stack to tackle vastly different technical challenges. Whether you're deploying on-device LLMs or dropping in pre-built AI features, or engineering a completely custom AI pipeline, the Google AI Edge ecosystem provides the tools you need to bring your vision to life. So Sachin, what should we know going forward?
All right, so one of the most important things for all of you to remember is that everything that we showed here is running on the device. There's no internet connection required for any of these capabilities, even the large models that we're running that we demoed, including the Ask Image feature. So all that is pretty impressive. So to recap, we started with the Gallery app where you can see what's possible by running Gemma on device. The app is available for you to download on Android and iOS, and you can even download the source code from GitHub, fork it, modify it, use it to build your own apps. Next, we covered MediaPipe Task for ready-to-use tasks for various audio, vision, and language capabilities. Really easy to implement and use. We touched on how LiDAR-T LM powers the LLMs on device. And finally, we talked about how you can use LiDAR-T to bring your own custom models. And now, it's your turn. We really look forward to seeing all the great things you build with this rich stack. And if you have any questions for us, we'll be outside at the AI Q&A table from 1 to 3 p.m. Thank you so much for attending.
This looks cool. So you have the agent platform, Bindu. It communicates and gives a payment layer for AI agents. Uh, Using one function call, you can rapidify your handler with Bindufy, and a few seconds later, your agent is online with its own cryptographic entities, speaking A to A, the other protocols, and ready to demand USDC on any EVM chain before it does any work. Your handler stays as small. The framework inside the handler, Bindu doesn't care. Agnos, LangChain, or Crew AI. The inside your handler, you can have any of these frameworks. MTLS, OAuth 2 via Hydra and DID signature. ED25519, X.509 cert. So 3 layers of security here. It can be breached, but yeah, it's a good initial layer, like initial part of how the A2A request lands and the different middlewares before it sees the body. A2A JSON, RPC, MTLS transport, DID identity, OAuth 2 via Hydra, X402 payments, push notifications, skill systems, private skills, agent negotiation, storage scheduler, public tunnel, polyglot SDKs, cloud deploy, gateways, observability, and that's the demo. A small society of Argno agents passing work to each other. Premium advisor, Hermes, the nose researchers, research Hermes agent, Bindu in 90 lines. That's cool. Yeah, this is a cool project. I guess the foot SBCs must be refreshed by now. I don't know. Let's try. I was working on the upgrades part of it. Mixed league upgrades. Oh, it has reached its. So I guess these are two different timelines. Let's uh, try to close it all and go for a couple of games here. I don't know if my CPU will be able to handle it right now. Mendeley is open. Sonic, I had to go through this paper in detail. There are some interesting things in this that needs my attention. Let's close this for now.
What's in the game?
So for this evolution, I am buying Vinicius Junior. The transfer market certainly reduced. Because I cannot play Henry on the left midfield. We'll be sending him to the stands. And having Vinny. Evolving him. Let's sell Sancho. I have no need for him right now. Vinny. Let's watch him for a couple of games. How is he able to perform? What's his jersey number in Madrid? Vinicius Juniors. I think so. It was 11, but let me confirm. What's the Vinicius Juniors jersey number in Real Madrid?
Vinicius Jr. now wears number 7 for Real Madrid. He got that jersey number before the 2023-24 season, replacing the number 20.
So he wears number 7, so that's what we will give him. He should be 25. Donnarumma. Thuram. Let's give him number 77. Thauvin, sorry, it's Thauvin, not Thuram. What are the playstyles here? He doesn't have a quick step. Let's go to 1366 bar. I think so. Then I will be able to play the frame rates have dropped quite a lot.
Well, conditions really couldn't be any better here tonight. A very warm welcome to you on this fine evening. I'm Guy Mowbray and I'll be joined for commentary by Sue Smith, the former England forward. And we've got a division rivals game on the way for you. How do you see this one going then, Sue?
It's a real pleasure to be here. It's been buzzing ahead of kick-off. Let's hope the football lives up to the atmosphere.
And we're off. Let's see what this one has in store. This is today's Nutters team. Gianluigi Donnarumma is in goal. Vinicius Junior starts alongside Andres Iniesta in the centre of midfield, and they're playing with just one up front. This is the visitors' team for today. Unai Simon is the goalkeeper. Fernando Hierro plays alongside Ibrahima Konate as centre-backs. And they've decided to go with 2 in attack for this game. Fabregas. A really good interception to take the ball. Cesc Fabregas. Could be something developing here. And it's on here. And a really smart stop there. Played into the box. Oh, he tried to power it in when composure was surely the key. Vinicius Junior. Whether it be...
Still some lag here. What I will do is, I will turn the stream off, play the game, and then come back. So, ciao up until now. Until then, sorry. We'll report back with the winnings or losings, whatever I have here.